many well-known enterprises in the client list. MongoDB is supported well and it is performing well among the enterprises. Its parent company is a billion-dollar firm. MongoDB is expected to gain more market share in the upcoming years as many data analytics platform and cloud vendors started supporting MongoDB natively. Moreover, MongoDB is one of the primary components of the hot MERN web stack as well as the MERN web stack. MongoDB is ranked at number 5 among databases and number 1 among the NoSQL databases by the famous DB Engines ranking. You can see the list over here. MongoDB is in rank 5. Do note that in the ranking, the databases above MongoDB are 20 plus years old, whereas MongoDB is 5 plus years old. And all these databases are relational databases, whereas MongoDB is a NoSQL database. Postgres recently gained share because they have introduced NoSQL feature along with OLTP feature. Learning MongoDB has very good job prospects, mainly due to its high adoption among enterprises across different verticals, including travel, telecom, analytics, business intelligence, retail, healthcare, education, media, and others. Secondly, the global NoSQL market is expected to grow around 35% between the period of 2013 to 2020 to a value of around $4.2 billion. In addition to that, this particular research shows about the relative adoption of NoSQL skills among LinkedIn members in September 2015. The blue one is MongoDB, as you can see here. This is the Indeed.com job trends for MongoDB and its competitor Cassandra. Among all these facts, I personally like MongoDB because of its simplicity and easiness to learn. It won't take more than 30 minutes for a developer to start working with MongoDB. This course about MongoDB is organized into 4 sections. In the first section, we'll be seeing the importance and the basics of MongoDB. We'll be covering about 4 useful IDE or editors, and we'll be covering about JSON and other important basics about MongoDB in the first part. In the second part, we'll be covering the core parts such as queries, arrays, full text search, etc. And in the third part, we'll be covering the advanced parts such as GridFS, aggregation, sharding, and replication. Finally, in the fourth part, we'll be covering all the key things which we haven't covered in part 1, 2, and 3, such as indexing, regex, Mapreduce, etc. So in the part 1, we'll be seeing about the importance of MongoDB, how to install it, what are the key features of MongoDB, and about the package contents in MongoDB. Following that, we'll be learning about JSON in detail. Then to the important section of this part 1, that is 4 tools. We'll be learning about 4 key tools which can help you in learning MongoDB very easily. So we'll be using these 4 tools to do a basic CRUD operation so that you'll be understanding about these 4 tools clearly. Following that, we'll be seeing a demonstration of how to load test data from different sources into MongoDB so that we'll be able to use the same test data in the upcoming demonstrations. In the part 2, we'll be seeing about queries, arrays, update and delete. Following that, we'll be learning about JavaScript. Please note that JavaScript is an integral part of MongoDB. The shell of MongoDB is JavaScript capable. Then we'll be learning about full text search, how to do a text search in MongoDB. This is important because MongoDB is a schemaless database. Then in part 3, we'll be covering 4 topics: GridFS, aggregation, replication, and sharding, out of which GridFS and aggregation are very, very important to be learned. Then in part 4, we'll be learning about Mapreduce, Regex, indexing, MongoDump, and Resto. Then we'll be learning about capped collection, embedded documents, TTL index, and finally we'll be learning about save and insert. In part 4, the key topics are Regex, Mapreduce, indexing, and embedded documents. So this is our course content. Let us start with the part 1 now. Hi, this is a simple pre-course preparation. We are going to see some simple basic introduction before we start with our MongoDB learning. MongoDB is a document-oriented database. A document is nothing but a simple JSON content. This is the one you need to remember, that is, a document is nothing but a JSON content. When compared to other data formats like XML, YAML, JSON is very simple and can be easily managed. That's why JSON is a preferred format in case of REST HTTP web services. And similarly, you might have seen JSON is being widely used in AJAX requests also. This is a sample JSON content. As you can see, we have curly braces in the beginning and the end. Then we have key value pairs. Key is always a string type, whereas value can be of different data types like string, numbers, boolean, etc. We have a separate JSON section in our course which details about this. In addition to that, we are covering different features of JSON. So this JSON content is referred as a document in MongoDB. It's simple. In MongoDB, we save documents, which means we save JSON content in database. That's the meaning of that. In SQL databases, we save text content in structured tables. In MongoDB, we save structured JSON. So like other SQL databases like MySQL, Oracle, MS SQL Server, in MongoDB also we have a server with many databases. Then we have collections. Under collections, we'll be having documents. And to query these documents and to update these documents, we'll be using JavaScript-like queries. It won't be like SQL queries. Whereas in the SQL databases, we have server, then under server we have databases, then we have schema. Under schema we have tables, and we use SQL queries for working with the data. So these are the primary differences you have to take into note. That is, here we have collection and documents, whereas in the SQL databases we have schema and tables. As most of us have some SQL background, MongoDB team has given a clear SQL to MongoDB mapping chart. To go to this document, you can easily give a Google search MongoDB SQL. It will be the first one in the result. Click on this. So this is a document I have been saying about. In this, under terminology and the concept section, things are explained clearly. For instance, the term database in SQL Server and MongoDB is same. In the SQL databases, we use a table, whereas in MongoDB, we call that as collection. Following that, in every table, we have rows. And here in every collection, we have documents. So that's the difference. Here it's row, here it is documents. Then in a table, we have columns. And in MongoDB, we have fields. You'll be able to understand clearly from the image shown here. Now let me show a quick demo of how working with MongoDB is like. There are more than 5+ very good clients available for MongoDB. That is same in the case of SQL Server databases like MySQL, Oracle. So I'm using a client called RoboMongo here. I have connected to my local server which is running in my machine. And these are all the databases. Under database, we have collection. So under test database, we have around 8 collections. A collection is similar to a table in the SQL database. So chat messages is a collection which has around 14 documents. So let us view the documents first. So this is a query which is used to view the documents. It can be easily done like this also, db dot. The collection name is chat underscore messages dot. Then we are going to do the find. The result is going to be same. If you view the individual document, it's a JSON content. Similarly, you can insert documents. For example, in our case, we have a field called chat. So I'm going to do the same. Key and value. Save. So our document must be here. Yes, we got it. So this is the one we inserted. Now I'm going to insert one more document with a completely different structure. For example, I'm going to insert this one. Save, done successfully. Let me do a find again to see our latest update. As you can see, it has dynamically added fields and the structure got changed. This is the main advantage of MongoDB or any other NoSQL database, is that you can change a structure dynamically at any moment. So do remember this point which we have seen previously. In SQL databases, we save text content in structured tables, whereas in MongoDB, we save structured JSON. So this is important. This is what we have seen before. Now let me do a demo in MySQL. I am connected to my local MySQL database. I'm just going to create a new table. The table name is chat messages. The table is created. Now I'm going to insert into that table. Successfully inserted. Now let me select from the table. So this is the text content present in that table. In MongoDB it's the same but in a different manner. So this is the difference between SQL and working with MongoDB JSON data. In this article from MongoDB team, that is SQL to MongoDB mapping chart, the difference between the queries in SQL databases and in MongoDB are given here clearly. You'll be able to understand easily. So always remember this, MongoDB is a document database. A document is nothing but a simple JSON content. That's it. Now let us see the next pre-course preparation topic before we get into MongoDB learning in detail. The most important 7 things before we get into the MongoDB course, that is, try to use a very good client with MongoDB. The time required for this will be less than 15 minutes. In MongoDB, everything is JSON and JavaScript based. You'll be playing with JSON content. A document is nothing but a JSON content. So this you need to understand it clearly. There are many good clients are available for MongoDB because the command line provided by the MongoDB team is not enough. It takes quite a lot of effort to work with the command line. So I basically recommend you to use a very good client. I'm using MongoBooster, which has IntelliSense support. I'm in MongoBooster client. You can see here I'm connected to MongoDB. I have the collections listed. I have the documents here. And the most important thing is we get IntelliSense support. For example, if I type db.chatmessages. I'll be able to see the methods available with the examples here. And similarly, it gives you a lot of code snippets that you can use in your code. So this is MongoBooster. In addition to IntelliSense support, it has quite a lot of ready-made tools. You can use them from here. You have text data generator, you have schema analyzer. You can import from JSON files, you can export. and you can even import tables from MySQL, Postgres, and then MS SQL. So I always recommend you to use a good client like MongoBooster to learn MongoDB easily. In our course, we are covering about the 4 famous MongoDB clients that you can use. That is RoboMongo, now it's called as Robo3T, MongoCHEF, that is now called as Studio 3T, then the famous MongoBooster, and finally NoSQL Manager. Now to the second one, that is the unique ID field. The time required to understand this is less than 10 minutes. It's very easy. Every MongoDB document must have an associated unique ID. This unique ID field is automatically generated by MongoDB. You can also provide your own unique ID. So you need to understand about this unique ID field because this is new in MongoDB when compared to the traditional databases. In traditional databases, for tables, we need to specify a column as an auto-generated unique ID, whereas in MongoDB, this comes by default. For example, this is the object ID which is generated by default by the system. So for every insert I did, object ID is generated. This is the ID field, and you can see the object ID is generated. To learn more about this unique ID field, please visit the MongoDB documentation page. It's available here. In this documentation page, you can see about documents. Under this, the information about ID field is provided. ID holds an object ID. Click on this, you'll be able to get more details about the ID field. And this particular line is very important, as you can see here. The field name underscore ID is reserved for use as a primary key. Its value must be unique in the collection and is immutable. So this is important. To get more details about the ID key, visit this page. Based on types, under this object ID, details are provided here. So that's a point number 2 about the unique ID field. Just learn about that, it's important. In MongoDB, a document is a JSON content. So this is very important. JSON is easy. Most of you might have known about it already. We have a separate section about JSON, and we are covering some of the tools like XML to JSON converter and JSON generators. You can easily understand about JSON from this page. So these are the data types available. And similarly, this example shows you how JSON is organized. For CRUD operation, that is create, retrieve, update, and delete, we have demo session with 4 different clients, and similarly later in section 2 we are covering this in detail, including arrays. It's very easy. You can easily insert, update, delete, and edit documents using the MongoDB clients. I'm using here MongoBooster. You can see how easy it is. So you need to learn CRUD operation in detail. Finally, we have the most important one, that is SQL to MongoDB method mapping. This is very important because, as you know, that MongoDB doesn't support SQL. As most of us have SQL background, MongoDB team has provided a very good documentation for SQL to MongoDB mapping. Similarly, we have a section about MySQL and MongoDB. So please use this. So this is the third most important thing. It takes only 15 minutes. The fourth one is the important one. That is, you must know how to use the MongoDB manual. This is the manual page and you can see things over here. For example, if I search for how to find a document, you'll be able to see the methods here. Similarly, under collection, we have set of methods which you can easily understand by their name itself. And similarly, under every method, an example is given. So this document is as good as of Microsoft's document. You have example for most of the methods and the functionalities. So you need to learn about the MongoDB manual. The fifth most important one is aggregation. The time required for this is less than 20 minutes. Aggregation is of high importance because you'll be playing with data. That's how we are going for MongoDB. So you'll be grouping data, you'll be analyzing data. So MongoDB provides a set of operators for projecting the data, analyzing the data, grouping the data, summing the data. For example, you want to get the sales total in a particular region for a particular product, you'll be using the aggregation. In other big data systems, we'll be using Mapreduce framework and you'll be writing your own code. For example, in Hadoop, you have to use the Mapreduce framework and you have to write your code. Whereas MongoDB provides you with the aggregation framework where you can use the operators and methods available to do that very easily. If you see this documentation page with this example, you can easily understand how this is happening. So this topic aggregation is of high importance because this is one of the main reasons we are going to use MongoDB. The sixth one is GridFS. This is one of the easiest topic to understand. In MongoDB, we have a size limit of around 16 MB for every document. So to overcome this, MongoDB has provided a separate efficient GridFS framework. So using GridFS, you can easily handle binary files like video files, audio files, or PDF files, and you can partially retrieve them and you can distribute them easily. This is one of the main use of MongoDB, and most of the medical companies using MongoDB use this feature. Now to the seventh and the final one, that is the basic small things. The time required is 45 minutes. As I mentioned earlier, in MongoDB, the document is a JSON content. You can embed documents within documents so that you can relate between two documents, or you can keep documents in different collections and then you can relate them using document reference. So this you need to understand it, and we have a separate section for explaining this. It's here. Then comes data models. It's explained here in the documentation clearly how to have relationships between different documents. So you need to understand these basics. Then, as every databases, MongoDB has indexes and how to use them. So this is clearly explained in the indexes section. We have a video content here. Since MongoDB is schemaless, text search is very important, and how to do that. We have a separate video section here, and similarly this is the documentation page for text search. MongoDB is primarily a OLAP database, but it can be used for OLTP purpose also. MongoDB supports atomicity for a single document operation. Also note that you can have multiple documents within a single document. So this gives a traditional OLTP table-like feature. You need to learn about that. This is the documentation page for that. Then how to do batch operations in MongoDB. This is the easy feature, and this is the documentation page for that. And finally, we have how to use programming languages with MongoDB. So we have a separate section for that. We have Node.js, PHP, C# and Java covered here, and we even explain about the GridFS functionality also. So these are the 7 important things you need to know about MongoDB. For those who wish to learn MongoDB quickly, there is a short 50 minutes video tutorial with a accompanying document in the bonus section. This covers most important aspects of MongoDB. As you can see here, it has all the key features of MongoDB covered. You can use that if you want to learn about MongoDB in less than an hour. We have a document with 20 simple questions for self-learning. It's easy and informative. Please use that. These questions will enhance and encourage you to learn about MongoDB by yourself easily. Similarly, we have 11 simple resources to boost your MongoDB learning. This is a video section. This is available here. It's very informative. Please use that also. We have many assignment activities in this course. I'll show a few of them. These are all practical activities that will surely enhance your practical know-how of MongoDB. These are very important. Please try to finish these activities. Similar to activities, almost every topic is followed by a quiz section. Please do them. They are very informative. Most questions will have an accompanying answer with a link which gives you a good knowledge about the topic. The sources used in the course are available in the resource section. Few of them are here. Please use them also. Let us continue with the course now. Do remember that these are the most important 7 things you need to learn with MongoDB, and we have a separate 50 minutes video tutorial for those who want to learn MongoDB quickly. That is available in the bonus section. You can easily understand features of MongoDB if you understand the business requirements the team had before designing MongoDB, because requirements is a king. The design team of MongoDB had 2 primary requirements, that is, the database which they are going to make has to be for analysis purpose. It's not for transaction purpose like our MySQL or SQL Server or Oracle. So the data is not going to be in a row and column format. It will be schemaless. The second one is it has to be modern because it has to withstand against existing database and the new upcoming database. So it has to be modern. These are the 2 primary requirements the design team might have had before making the MongoDB. So let us expand further into the first requirement, that is the analysis part. It has to be a OLAP, not OLTP. Since it is a OLAP database, it has to support variety of file formats, data formats, and data sources. So it needs to be schemaless. It will be document based, similar to our Word document, Microsoft Word document. Excel can be compared with the traditional OLTP databases, and document can be compared to the OLAP databases. So it is structureless, and you can put anything into anything. For example, in a Word document, you can put an image, video, or a table or anything into that Word document. So it is completely structureless. Whereas for Excel, it is based on rows and columns, which can be compared with the traditional OLTP databases. Since it is schemaless, it needs a powerful language support because you need to analyze, query different types of data formats. So we have the powerful established language JavaScript supported in MongoDB. Since it is document based, you will have millions of documents which needs to be properly identified. So they have unique identifier auto-generated for every document. For every document, unless until you specify, MongoDB has a unique identifier. Next is full text search support. Since you have document based non-structured data, it needs a powerful full text search support like our traditional databases. The next one is very important because it needs to integrate with big data systems and BI platforms in ease so that we have connectors. For instance, the big data may be handled by Hadoop or Spark based systems, and reporting level may be handled by MicroStrategy or Cognos based reporting systems. So we have connectors for all these platforms from MongoDB. Administration must be easy, that we know. For that, we have JS capable shell. Following this, for analysis purpose, we need Mapreduce supported framework. So we have easiest form of Mapreduce, that is called aggregation pipeline in MongoDB. This is a very interesting part. And finally, To handle large file formats such as blob and lob in case of traditional databases, we have something called GridFS system. So GridFS is very powerful when compared to the traditional databases blob and lob data type. Since MongoDB has to handle variety of data and huge amount of data sets, we have GridFS in MongoDB. This is used for storing and retrieving partial data from a large data. The next one is it has to be a modern database. So this is a requirement. So for that, we have JavaScript support in MongoDB. Then we have the important one and very useful one, Regex support in MongoDB. Then my favorite one, that is time-based data. So we have time-based collections where the data will be expired after a certain threshold. After this, we have BSON and JSON data format. As you know, BSON is for storing and JSON is for presenting. Then we have easy backup and restore options such as Mongo dump, Mongo restore, BSON dump, Mongo import and Mongo export. Those are all very simple commands, so you can easily export and import data. Then we have cloud hosting options. And finally, we have driver support for all the modern languages. There is a huge list. You can visit the MongoDB page to see the language support there. So these are the two requirements the MongoDB design team had, and these are the features they added to satisfy these two requirements. So hope you understood this section. So let's move to the next one. Hi, I have added a bonus lecture section with resources, that is MongoDB in less than 50 minutes. It's sharp and precise. It will be very useful and can give you a good know of the key necessary parts of MongoDB. It has totally 12 topics with resources section. So I request you to visit that for a quick start with MongoDB. It complements this course. So in just less than an hour, you'll be able to work with MongoDB well. Please use the bonus section. In the bonus or supplementary section, new videos are added. In those videos, steps to work with MongoDB and the 4 different programming languages are shown. They are really easy and very interesting. Using these 4 programming languages, we'll be seeing how to list database, list collection contents, create new collection, insert single, insert many, find and find with options, sorting, filters, projections, update, the key ones, that is bulk write, run command, GridFS, and then delete many, drop collection and drop database. The most interesting among these are find with options, bulk write, run command and GridFS. So I request you to visit the bonus section to see how to work with MongoDB from these 4 different languages, Java, PHP, Node.js and C#. Working with C# and MongoDB is very easy when compared to other 3 programming languages. In this stage 1 or part 1, we'll be answering this simple 8 core questions to understand MongoDB well with clarity. The first is going to strengthen our purpose for MongoDB learning, that is why MongoDB is important. After seeing the facts about MongoDB's importance, we'll be answering about key features of MongoDB to focus it, as well as why it is different from traditional databases. Following question 1 and question 2, we'll be seeing the most important and the easiest among all these questions, that is how to install MongoDB. Installation of MongoDB is simple and straightforward, not complex like that of SQL Server or Oracle. We'll be demoing how to install MongoDB on 3 different platforms, Windows, Mac and Linux. After installation, we'll be seeing about the details of the tools bundled in the installation package in question number 4. Question number 5 is critical and a very useful one. We'll be detailing about JSON basics, JSON XML formats and related tool to learn JSON easily. In 6, we'll be exploring about the GUI based tools that will help us in learning about MongoDB easily and quickly, as the tools provided by Mongo team along with the installation package or command line based. The GUI tools will sure speed up the learning process for beginners. Next we'll be doing the main thing, that is the CRUD operations in MongoDB. We'll create, update, delete and retrieve documents. In the question number 8, we'll load the test data to MongoDB so that we can use them to learn about query operations. We'll be using the test data provided by MongoDB team as well as the famous Northwind sample data similar to that of Microsoft SQL Server. So these are the 8 questions we are going to answer in the part number 1 or the stage 1. These are very simple and very interesting things. This forms a basis for MongoDB learning. Let us start with why MongoDB is important. Why MongoDB is important? Have listed a few important points. The first one is its huge and famous client list. You can see top companies over here. This is the Wikipedia page for MongoDB. You can see the production deployments for famous companies. Adobe is using it, Craigslist is using it, eBay is using it, MetLife is using. Similarly, visit the page mentioning about who uses MongoDB in the MongoDB website. You can select by industry or about the global regions. There are many companies listed over here, well-known companies. The second most important thing is DB Engine's ranking. MongoDB is ranked at 4. This is very notable for a database which is just 7 years old, and MongoDB is above Postgres and DB2. This is the DB Engine's ranking page. You can see MongoDB here, whereas its competitors Cassandra and Redis are at position number 8 and 9. MongoDB is at position number 4, just below SQL Server. MongoDB is a very stable company. It is valued at $1.6 billion. You can see the related article over here in WSJ. This is the article mentioning it. Big data startup MongoDB is now valued at $1.6 billion. And finally, the most important one, that is Indeed.com job trends. This is the job trends for MongoDB in comparison with the other competitors, Cassandra, Neo4j, Couchbase, CouchDB. So you can see the job trend for MongoDB. It's increasing and it's way high above its competitors. The other 4 points are: it's simple and very easy to learn. It's really interesting for a RDBMS guy or for a beginner. It's based on JSON and JavaScript, so learning is very easy and it's going to be very logical. And there are many good interesting concepts in MongoDB such as GridFS, Sharding and aggregation. These 3 are very interesting chapters. We'll be seeing about this later. So these are the key points which shows why MongoDB is very important. The first one is because of the huge client list. Second one is its DB Engine's ranking. Third one is it's a stable company valued at $1.6 billion. Fourth one is Indeed.com job trends. In addition to that, we have seen 4 other points which are also important. We have seen the answer for the first question, that is why MongoDB is important. Now to the second one, what are the key features of MongoDB to focus at? I have shortlisted the important features. There are only 6 features that a beginner needs to know about MongoDB. The first one is it's a document-oriented database, so there are no tables or no rows-based data. Data is organized as documents. The second one is it's a NoSQL database. So of course 2 things we need to remember about NoSQL. That is, there won't be any schema, no tight rules. Every document can have totally different structure and we can embed documents within documents. There are no joins. NoSQL databases are designed for horizontal scalability. The third one, underscore ID is a primary key and it is auto-generated field for every document. So for every document we'll have this primary key auto-generated. If you want your own primary key, you can replace this, but by default underscore ID is a primary key which will be auto-generated. This is not the case with the traditional database. This is important. Data is stored in BSON and presented in JSON. BSON and JSON are similar. BSON is a binary format of JSON. Before seeing point number 5 and 6, let me show a local MongoDB instance which is running on my machine, so things can be understood very easily. This is a MongoDB server which has a product DB. Under the database, there are 3 collections. And for example, if you take the collection number 1, which acts as a group for documents, I have 3 documents under this collection. These are the 3 documents. You can see them in JSON format. If you shift to table view, you can understand it better. So 3 rows I have. Here we refer rows as documents. So I have 3 documents. Each can have its own structure. That's a specialty. So no tables, no row-based data, and every document can have totally a different structure. I can easily change the structure of every document by adding a new field over here. So these documents are totally independent of the other documents and they can have their own structure. These documents are collected under collections and collections are under databases. And this is how MongoDB works. We'll be having a MongoDB server with many databases. So a server can have many databases, and within database we have collections. There are many collections under database, and within collection we can have many documents of different structure. So the same we have seen over here. So we can have a server, and a server we can have many databases. Here I have only one. Later I'll be showing with many databases. And a database we can have collection, and a collection we can have documents with different structures. In a simplistic terms, traditional RDBMS arranges the data in tabular format similar to MS Excel like this. A sheet refers to a table and we have columns and rows of data. Whereas MongoDB is a NoSQL database, it's schemaless. So it arranges data similar to MS Word like this. No schema, no hard defined rules, and structure can be changed at any moment. For programmers, MongoDB arranges data similar to PHP arrays, and in Java or in C# similar to hash maps. So you can put anything into anything and the structure can be changed dynamically, and different kind of data can be kept in a map. So just remember this. The MongoDB data is stored in binary JSON, that is internally, and for the external viewing it is presented in JSON format. JSON file is similar to this. For example, this is the address component, and you can see here various key values present like this. A JSON document will be saved in MongoDB, and you can have embedded documents, a document within documents. Recording embedded documents, you can embed a document within document like this. This is from MongoDB documentation. For example, here we have an embedded document contact and access as a sub document inside the main document. And as mentioned in the point number 3 here in the presentation, the ID is a primary key and it is auto-generated field for every document. You can see it over here. This is the ID auto-generated. This field ID can be related with other documents also like this, similar to our traditional database joins. Let us see the ID field in the MongoDB instance. This is the ID field I have been talking about. This ID field is auto-generated for every document. Whatever you insert, this field will be auto generated. Just remember this we have mentioned in point number 3. And I haven't shown about every document can have a totally different structure. The demo what I have shown from the MongoDB instance, the document had a similar structure. So I want to just show you how we can save a document with a different structure. Let me copy this portion. It's very easy. I'm going to add 2 more fields here. Quantity is going to be 10 and a subtype is going to be sports equipment. On clicking validate, JSON is valid. So I'm going to save this JSON file into MongoDB, which in turn is going to save this in JSON format internally. So on clicking save, I've saved it. You can see here this is the 4th document which I created just now. So the first 3 documents have different structure and the last one has a different structure. You can confirm this in the table view also. So 2 more columns are added. This is what we mentioned here, that every document can have totally different structure. The 2 additional points are point number 5 and 6, which means server-side JavaScript is supported, JavaScript expression and function is supported. And the final one, which is going to be important one, that is a sharding, horizontal scaling, replication, GridFS, aggregation, capped collections are the key ones, additional things. These things we'll be learning in the upcoming sessions, and similarly we'll be seeing about server-side JavaScript support. Till that, for a beginner, these 4 things are important. Let me show things from MongoDB documentation so you can understand how it is working. Remember that these 2 points are not necessary in the initial levels. I mean, for the beginner level, this 5 and 6 are not necessary. I'm just showing for your knowledge now. Replication is similar to the traditional database replication. As you can see, primary has 2 secondaries, or in the other way around. This is a common scenario. You can also have an arbiter which is used for voting, which will vote which is primary and which is secondary. So this is for replication. We'll see it in detail later. And for sharding, it's very easy to understand. As you can see, a collection is distributed among shards or separate machines. So for example, if you have a 1 terabyte connection, it is splitted across machines like this. So we'll be seeing a demo about sharding also to understand it clearly. GridFS is very simple and easy to learn among this. GridFS is for saving big data similar to blob content in our traditional database. Aggregation is similar to our traditional RoboMongo database stuff. And capped collections are collections with limitations in size. We'll be seeing about this 5 and 6 in later sections. So now let us focus on these 3-4 key features of MongoDB. Okay, before moving to the next section, let me recollect what we have seen in this session. We have seen about the key features of MongoDB. That is, it is a NoSQL database. It's a document-oriented database. And the ID key is auto-generated by MongoDB, and it's a primary key for every document. And data is stored in JSON format. Internally, it will be saved in binary JSON, that is JSON. This is a simple JSON document structure. And we have seen in traditional RDBMS, the data is saved in rows and columns similar to MS Excel, whereas in MongoDB, it is similar to MS Word. So the data is structureless and anything can be saved into anything. For programmers, instead of MS Word, think about PHP arrays or a Java hash map. So these are the main MongoDB components. We have a MongoDB server. A server can have many databases. This is similar to our traditional RDBMS concept. And a database can have many collections, and a collection can have many documents. We have seen the same through a demo with MongoDB instance that's running locally on my machine. I used a client called RoboMongo to demonstrate the same. So in my local machine, I have a MongoDB server with a MongoDB database, and under the database we have collections similar to that shown in the diagram. Under collections we have documents. Here we are seeing the table view of that. The real view is a JSON view. So every JSON file or every JSON here, it's a document. You can see the tree structure of that. And as we have seen, every document will have a auto-generated key, that is a ID column. Also, we have seen every document can have its own structure. I have created a new document under the same collection with a different structure, and I have added 2 more fields here, quantity and subtype. So these are things we have seen in this session. We are going to see about the 11 simple resources that will give you a great boost to a MongoDB learning. These are very simple resources and are very handy. The first one in the list is SQL to MongoDB mapping chart. This is an important one. So this will help us to understand about MongoDB easily from SQL point of view. So Google for SQL to MongoDB. The first result will be the mapping chart under MongoDB manual 3.4. Click on that. So this is the article SQL to MongoDB mapping chart. It's very good, very useful. For instance, a table is called as a collection here in MongoDB. A row is called as a document. A column is called as a field. Similarly, you get examples for every SQL query. For instance, for this SQL query, you can find a corresponding MongoDB method call. So that's how SQL and MongoDB are related. This is a very good document. As a beginner, it is necessary that you read this article in depth to understand about MongoDB easily and clearly. The next one in our list is what is NoSQL. There is a very good article from MongoDB which is available here, that is www.mongodb.com/NoSQL explained. So Google for MongoDB NoSQL explained. So the first link is going to be our article link. Click on that. In this article, you'll be able to learn about NoSQL database types, dynamic schemas, the benefits of NoSQL, and about auto sharding, and a good summary about SQL and NoSQL. So this is an important article as a beginner. The third one in our list is the interesting one, that is MongoDB and MySQL compared. So if you know about MySQL earlier, this article is going to be very, very helpful to you. So search for MongoDB and MySQL compared in Google. The article is in the top search list. Click on that. So this is the article. Under this article, we have terminology and concepts clearly explained. Why use MongoDB is explained, and when to use both MySQL and MongoDB is also explained here. So this is a very good article, very informative. It won't take more than 10 to 15 minutes for you to read this. It's a very good article for a beginner. The fourth one in our list is an important one, that is a MongoDB cheat sheet, a very well organized cheat sheet from CodeCentric. Google for MongoDB CodeCentric cheat sheet. The first result is the cheat sheet. Click on that. A very well organized cheat sheet is provided. As you can see here, we have information about inserting documents, finding documents, and various operators here. And similarly, we have indexes covered, and the important one, that is the pipeline stages for aggregation, and the aggregation examples are provided. I personally like the replica sets and the durability of writes section here. The information is very well condensed in this cheat sheet, so please use this one. The fifth one in our list is the FAQ section. This is a very good section from MongoDB team. Google for FAQ MongoDB. Click on this link. For the basic level, we have questions like how does a collection differs from a table, how to see a size of index, all those. And for advanced, we have how does sharding affects concurrency, and how does Mongo's use connection, and similarly information about the storage engine fundamentals. So this is an important FAQ section. Please go through it. Following this, we have the ref card from dzone about MongoDB. It's very interesting and very clearly organized. To find it, Google for dzone MongoDB ref card. This is the ref card. Either you can download the PDF or you can read online. For instance, in section 11, we have query operators. And in section 18, we have MongoDB restrictions clearly explained. So I personally recommend this one for beginners as well as for advanced users. Then at 7, we have MongoDB shell quick reference. This also comes under MongoDB documentation. So Google for MongoDB quick reference. The first one is the article we are looking for. It has various topics covered. In this document, we have basic shell JavaScript operations like this. And similarly, we have queries explained. It's a good document to use for beginner as well as in advanced levels. At portion number 8, we have online course catalog for MongoDB. This is from MongoDB University also. It's free, though not organized well. It has very quite interesting topics. So Google for MongoDB University online course catalog. MongoDB University online course catalog. This is the link. We have MongoDB basics covered here. We have MongoDB for Node.js, Java, .NET developers. Similarly, we have the interesting one, that is MongoDB with Spark. So this is a limited set of free videos, but they are very, very useful. It's available under university.mongodb.com courses catalog. At 9, we have resources.mongodb.com. There is a good catalog of videos here. Visit resources.mongodb.com. Click on this starter kit. Under this getting started section, I like this video series which deals about mean stack. It has 6 parts: part 1, part 2, part 3, part 4, part 5 and part 6. So these are very informative, and similarly we have information about BI connectors also. This can be very useful if you are working with business intelligence. Then at portion number 10, we have a very interesting, very useful presentation. I would say a must to learn for beginners, that is transitioning from SQL to MongoDB. So this is a presentation available under MongoDB presentation section. Simply Google for transitioning from SQL to MongoDB. The first link is the one we are going to see, that is webinar transitioning from SQL to MongoDB. You will be prompted with a form to view this presentation. Once that is done, this is the video I have been speaking about, transitioning from SQL to MongoDB. It gives you a good view about MongoDB. Don't miss this. Then at 11, we have an interesting online hosting service, that is MLab, which gives you a 500 MB free hosting service. It's very easy. If you don't want to install MongoDB in your system and you want to try online hosting, I would suggest this one for beginner because it's very easy. You just need to click create new here. So this is going to create a database. Under plan type, select soundbox. You'll be able to see the available AWS regions. Click continue. And then you need to give the database name here. Let me give a test DB. Let me make it as test DB 11. And then click continue. So we go to the new database. Click on this. So this is a URL you will be using for connecting to this. You can create collections under this. So you'll be able to see 5 tabs. The first one is collections, where you'll be able to add collections under the database. Then you have users. You'll be able to add users. You'll be able to see the stats, see the backups, and the important one, that is tools, where you'll be able to import or export databases, JSON files and CSVs. It's very simple. Try to use one if you want to explore further about MongoDB. Similar to this, MongoDB has Atlas database service. We will have a separate video about MongoDB Atlas later. So these are the 11 simple resources that will give you a great boost to your MongoDB learning as a beginner. As a beginner, you just need to remember these 4 points. The fourth one is data is stored in JSON format internally, but will be presented in JSON format. MongoDB is a document-oriented database, so there won't be any columns or rows. And it's a NoSQL, so no schema, no structure restrictions. Every document can have its own structure. As a NoSQL database, it's designed for horizontal scalability. And this horizontal scalability stuff is called as sharding. The final important point is underscore ID is a primary key that is auto-generated field for every document. So these are the 4 key points you need to remember as a beginner. Now let us move to the third question. Now to the question number 3, that is how to install MongoDB. This is the easiest step. Just Google for MongoDB download. The link will appear. Downloads MongoDB. Click on that. Under this, you can see MongoDB distributions for different platforms. So mine is Windows and it's a 64-bit one. So I have selected this. On clicking download, it's a 100 MB file. It begins immediately. There's no need to register this form. Or if it is not starting, you can click on this link. So this is the installer. After downloading, you can just double click the installer to install. It brings up the setup wizard. After successful installation, you can see MongoDB under this directory, C program files MongoDB. So under this, you have a directory called server. On double clicking it, you'll be able to see a bin directory. And here are the exe files which we'll be using. These are the 2 important files we'll be using, that is mongo.exe. This is a client, and mongod.exe. Guys who have worked with MySQL knows about mysqld.exe. This is similar to that. The next step is to run this MongoD server. Under this directory, that is C program files MongoD server, I just need to start the MongoD process, which is the server. On clicking MongoD process, we must see in the console the server is starting up. If you are able to see this line that is waiting for connections on port 27017, this is the default port on which MongoDB runs. Then your server is up. If you are not able to see this one, probably you may not created this folder, that is C data DB directory. So just create this directory C data DB and start this process. You'll be able to see MongoDB running on port number 27017. I repeat again, if you are not able to start up this process MongoD, just create this directory, that is C data DB directory. So MongoDB will use this one and it will start the MongoD process. Now to connect to MongoD, we have many type of clients available. Let me use the default one, that is mongo.exe, which is provided by MongoDB. This is a CLI based client. I'll be using a different window for this. Yes, Mongo has connected to MongoDB now. So this command show databases shows me two databases, that is local and product DB, which we have seen earlier through the RoboMongo client. As a beginner, using this Mongo shell is very tough. So let us use a GUI products which can ease our development. So with this, we have answered the question number 3, that is how to install MongoDB. Let me recollect the steps what we did. We just did a Google search for MongoDB downloads, and on clicking the link, it has taken us to the MongoDB download page, where I have selected the corresponding platform and the version. It's a 100 MB file. On installing, it's been seen that it is installing to the directory C program files MongoDB server 3.2 bin by default. And there are many exes available under this directory, out of which mongo.exe, this is a client, and mongod.exe, this is the server. Both are important. So the first step was to start the server. So what I did is I navigated to the directory, and then I have started the MongoD process, and I have seen that MongoD started listening connections at port number 27017. If you are not able to get this one, make sure that you have a directory C data DB under your C drive. If you create this directory and start the MongoD process again, you'll be able to see that MongoD has started running. The next step was to check the client, that is mongo.exe. I have connected to MongoDB server using Mongo client. This is the CLI interface, and after connection, I have entered the command show databases, which has listed two databases, that is local and product DB from the server. With this, we are finishing our question number 3 successfully. Now let us see what is in the installation package, which is important. We are going to see a simple demo of how to install MongoDB on OS X. It's very simple because the documentation is very clear. It's clearly explained in this page. There are two ways to install MongoDB in Mac. Either you can do it directly on Mac, or you can go with a package management system like Homebrew. I prefer the second one, that is to use Homebrew for installing and managing MongoDB. So I'll be demonstrating that. As you can see here in the documentation page, the MongoDB installation has only 2 steps, that is to give a brew update and a brew install MongoDB. That's it. So these 2 steps will get you MongoDB in your system. To up and running, you need to use a brew services start command. So we are going to install MongoDB Community Edition with Homebrew. Homebrew is easy. If you haven't installed, it won't take more than 10 minutes to bring it up. It gives you a lot of comfort, and it is one of the well-known and must-to-have softwares for Mac. I have already installed Homebrew in my machine. Let me give a brew update now. Done successfully. Now I'm just going to issue the command brew install MongoDB. Will automatically locate the resource and install the MongoDB on my local Mac machine. So this must not take more than 2 to 5 minutes. Done successfully. As you can see here, how to launch MongoDB is mentioned here. Brew services start MongoDB. Let us see the services list, brew services list. Yes, MongoDB is stopped and Redis is running in my machine. Let me start MongoDB using brew services.mongodb command. Successfully started. Let me do a services list again. Yes, as you can see, MongoDB is in started status now. So MongoBooster is up. I have connected to my local host 27017. I'll be creating a test database and a user profile collection. Done. Under this collection, I'm going to insert some records. So I'll be using insert method for that. Successfully inserted. Let me view the documents. Yes, we have the document. To stop MongoDB, it's very easy. You just need to issue brew services stop MongoDB. Let me do that. Done successfully. Now, if we see the brew services list, MongoDB must be in stopped status. Yes, it is in stopped status now. So just remember these 4 simple commands: brew update, brew install MongoDB, brew services start MongoDB, and brew services stop MongoDB. And if needed, you may use this command also, that is brew services list, which will give you the list of services running. Installing MongoDB in Linux is very easy. The steps are clearly given in the MongoDB documentation. It won't take more than 2 to 5 minutes to bring up the MongoDB in your Linux box. So this is the documentation page having MongoDB installation details on Ubuntu. I'll be using the latest Ubuntu 16 for this. In this documentation page, the 4 steps to install MongoDB is mentioned clearly. The first step is to import the public key using the package management system. The second step is to create a list file for MongoDB. That's for creating the sources. Once that is done, we just need to reload the local package database. That's refreshing. And finally, we just need to give a apt-get install MongoDB. That's it. It's very simple. I'm in the command prompt of Ubuntu now. As you can see here, the version is mentioned. So let me start copying the steps from the manual. So this is step 1. Imported. The next step is to add the source list. That's a repo name. Yes, it's done. The third step is a common one, that is apt-get update. So let's do that now. It takes some time. That's also done. Now the final step is to do a apt install MongoDB. That's it. It must not take more than 2 minutes for this one. Done. As you can see here, a new group and a new user with the name MongoDB is done successfully. Now the next step is to start services. That's also is mentioned in the manual. You just need to copy that. That is service MongoDB start. So let's do that. Done. Now let us connect to the MongoDB using the Mongo client. It's connected. I'm going to see the list of databases available. Yes. Now I'm going to create a test database and then some collections and some dummy documents. The collections users is created. Next, I'm going to do some inserts into that collection. So name is admin. I have created 3 documents under that collection. Let me view them now using find command. Yes, all are available. So this demos us how to install MongoDB on Linux machine. It's very easy and straightforward. The steps are given clearly in the user manual. Just follow that. Question number 4, tools bundled with MongoDB. This is the list of tools that are bundled with MongoDB, out of which 6 are important. The MongoD process, this is a core process. This starts a MongoD server in port number 27017. Followed by a Mongo tool. This is a CLI based client which is provided by the MongoDB team to access the server. Then we have Mongo's tool. This is used for sharding. This we will be seeing while we are covering sharding. Then we have MongoDump and bson dump. MongoDump is for dumping the binary data, whereas bson dump can give you a view of the binary data in text format. Then we have the important ones, that is Mongo import and Mongo export. As you can interpret from the name itself, these are used for importing and exporting Mongo databases. Then we have MongoStat and MongoTop. These are used for database operations. And similarly, we have Mongo Oplog and MongoCHEF. These are both admin related tools. This is the installation directory and a bin. You can see these files here. There is one more tool that we have listed here is Mongo Files. This one is used for GridFS functionality. We'll be learning about this while we are seeing about GridFS. To start the server, we just need to call the MongoD. So let me do that through command line. MongoD. So this one has started the server in port 27017. So this is the first one in our list. Then we have Mongo. So Mongo is a client. So it's connected. So let me do a test by issuing a command. Databases. This is how the CLI interface works. Then we have Mongo Top. Followed by this, we have MongoStat. So these are the key tools. We'll be seeing about Mongo Restore, bson dump, Mongo Export and Mongo Import in a separate section where we'll be using tools like MongoCHEF and MongoBooster for doing the same, as well as we'll be seeing the command line also. So now let us move to the next question. This section we are going to see about a JSON file format. We generally use data files in either CSV, XML, OAML, JSON or in binary format. JSON, which stands for JavaScript Object Notation, has become very famous and widely adapted as a data interchange format after the advent of web technologies, especially Ajax, and after REST web services became famous. Though XML is still leading in enterprises and in other old systems, JSON has started replacing it as a communication data format. As you know that in most cases REST is replacing SOAP's XML format. JSON exactly sits between CSV and XML, where a CSV just represents data without any rules, and XML is full of rules where the data information becomes cloudy. JSON creates a simple rules-based data format which can be used in wide variety of systems, and moreover it is very lightweight. So among these three file formats, CSV, JSON and XML, JSON is preferred because it's lightweight and can be easily managed. But for configuration information, YAML or a groovy file format is preferred. YAML is completely compatible with JSON and it is very reader friendly, whereas binary file format is preferred for quicker data transfers, but encoding and decoding is going to be a overhead. This section we are going to learn about JSON, and we'll be learning these three key things. The first one is we'll be learning about its structure, then we'll be seeing about its practical uses, and finally we'll be using some online editors that will help you in understanding JSON better and eases your work with JSON. So this is the to-do list we are going to do now. First one, as I mentioned earlier, is going to be the JSON structure, followed by json.org. Then we'll be seeing the data format used in Google Maps and in iTunes. Then we'll be converting JSON to XML format and JSON to CSV. Here we'll be using a simple online editor for this. This will enhance your understanding about JSON. After this, we'll be seeing about programmable web, a website that works as a directory for web services. And finally, we'll be seeing about OData format. So these are the simple things we are going to learn in this section. The first target is to learn about a JSON structure. For learning JSON structure, I recommend you to visit this website, jsoneditoronline.org, because here they have given a very simple example so you can understand things very easily. For every JSON file, there has to be a curly brace at the beginning and at the end. Second thing is JSON is nothing but a collection of key value pairs. The keys has to be surrounded with quotes. So these are the two simple rules we have for JSON. So the first thing is the curly brace has to be there covering the complete content. The second rule is in the key value pairs, key has to be covered within double quotes or a single quote. Regarding key value pairs, as you can see here, there is a colon separating keys and values. Keys has to be of string type, whereas value can be of any of these following types. It can be of an array type. For arrays, you have to use square braces. It can be of Boolean type. It can be of null type. It can be of number type. It can be of the famous string type, or it can be of a complex object type. You can see object type here, where the key value pairs are surrounded by a separate curly brace. So this is a representation of an object. You can have an array within an object and an object within an array like this. So that's a power of JSON. It's very easy to master. Let me repeat again. A JSON file must start and end with a curly brace. JSON file is a collection of key value pairs. So the keys has to be surrounded with quotes, whereas value can be of any of these types mentioned here. It can be of an array type. For array type, you need to specify square braces, and it can be of Boolean type, it can be of null type, it can be of number type, it can be of the famous string type, or it can be of a complex object type. An object type has to start and end with a curly brace, and you can have different types of key value pairs within an object, and in an array you can have many objects also. So this is the simplest example for a JSON file. Let us move to Wikipedia to understand about JSON better. This is the wiki link for JSON. There is a very good simple example is given here for personal details. As I mentioned earlier, JSON has to start and end with curly brace, and all the keys has to be covered with a single quote or a double quote like this. Key value pairs will be separated with a colon. To start with, the first name is of string type, age is of number type, address is a object type, So it's covered under curly brace. Here we have many key value pairs. The interesting thing is the phone number. Phone number is of array type, but as I mentioned earlier, within this array type you can have many object types. So we have 1, 2, 3 object types within the array type. So array type, it is surrounded with square braces. Then we have children, which is a empty array, and spouse is null type. So this is a simple example of JSON representing a person. Additionally, JSON must have a .json extension. The internet media type for JSON is application JSON, whereas for XML it is application XML. Let me move to json.org, where there are 3 very good simple diagrams given so that we can understand JSON better. But before seeing the diagrams, there are 2 key points that needs to be mentioned. That is, JSON is built on 2 structures. The first one, as we know, it's a collection of name value pairs. This is called as an object. Whereas the second one is a collection of ordered list of values, which is called as array. So these are the 2 key things for a JSON. The first one is a collection of name value pair. The second one is an ordered list of arrays. Ordered list of values. Now to the diagrams. Object is of key value pair. It's a collection of key value pair which is surrounded with curly braces. Key value pairs will be separated with comma. This is what the first diagram represents. So if you see the example here, you will be able to understand it better. So this is an object type where we have key value pairs separated with comma. The next one is array type, which has square braces with many values separated with comma. Array type which has many values separated with comma. The third diagram is for value. Value can be of any of this type. Either it can be a string, number, object, array, true, false, null. Array, boolean, null, number, object, string. That's what they have given here. So these 3 diagrams can make you understand JSON better and faster. In our list, we have successfully seen about a JSON structure. We visited json.org. Now, before proceeding with Google's JSON format and iTunes JSON format, I wish to show you a website which will be very, very useful for you. That is Learn X in Y minutes, where different programming languages and technologies are listed. If you want to learn about a particular topic, it won't take more than 5 to 10 minutes, because the information is clearly organized and it is very, very, very easy to study. For instance, if you want to learn about Git, the details are given in a very simple and easiest way so that you'll be able to pick it up within few minutes. Here for JSON, they have given a good simple tutorial. So if you follow this, you'll be able to understand JSON far better. I personally recommend you to visit this website, Learn X in Y minutes, to learn about JSON. Google Maps data in JSON and XML format. We know how important is Google Maps data. This is the URL for that, which is going to give us the exact lat and long for this particular location, 1600 Amphitheatre Parkway, Mountain View, CA. So this is a geocode response in XML format, which has the lat and long for this particular location clearly mentioned. This is the place ID. The same output can be in JSON format also. This is the JSON format of that request. So we have lat and long here, and it's very simple to understand when compared to XML. For iTunes search API, under this page, the search API examples are provided. For example, if you are searching for this particular item, Jack Johnson, on clicking this, The resultant will be a text file. I'm going to open in Sublime Text. So the result is in JSON format. Let me save this in JSON format. So this is how iTunes Search API gives a result in JSON format. These are the major use cases for JSON format. Now let us see how to convert JSON to XML and JSON to CSV format. This is very easy. JSON to XML. There is a website by name Code Beautify. If you click in this sample link here, you'll be able to see the JSON format and its corresponding XML format. So if you are very comfortable with XML and you don't know JSON, search for XML to JSON format. To JSON under this website, Code Beautify. XML to JSON. So you can feed your XML format and see the corresponding definition in JSON. Similarly, if you want to see about CSV to JSON format conversion, it's available here. Let me take this for example, or let me go the sample given by them. So the result is in XML format. If you want to see JSON, this is a JSON format. So if you're comfortable with CSV format, you can see what is the corresponding output in JSON easily under this website codebeautify.org. So with this, we have finished how to see JSON in XML format and JSON in CSV format. Next is a programmable web, which serves as a directory for many web services. This is an important link to remember. API, mashups, and web as a platform. This is a directory. Under the API directory, the APIs are categorized clearly. You can watch here whether is there, mapping is there, mobile is there. Similarly, you have almost 14,000 plus categories, and featured APIs are listed here. The most important is you can filter by protocol. On searching for currency conversion, filtering APIs by currency, and the format is in JSON. This is the resultant. On clicking the first result, Wine OS currency conversion, the details of the API, the URL, all those are given here. The protocol formats is in HTTP or JSON. If you see the JSON formatted APIs, you can easily click this link. It's going to take to a page where the APIs having JSON formats are listed. There are many famous APIs. I recommend you to go to this website, Programmable Web, and explore it. To our final one in our listing, that is OData. OData is a protocol. It is very simple but very powerful protocol for creating and consuming RESTful web services. Recent days, OData has become a key part in modern web systems, especially Microsoft environments. OData has become a OSI standard, so it's going to play a great role in the future. These are the applications using OData. The official homepage of OData is this one, odata.org. In this page, the definition for Open Data Protocol is given here. It's for RESTful APIs. The key thing is that the data format used for this RESTful interchange is in JSON format. JSON has become a de facto standard. Though Atom is also supported, JSON is widely used for OData interactions. To see how JSON is used, scroll down to this heading, create a new resource, where a request for creating a new resource using JSON is given. Here the content type is in JSON format. This is how JSON is used in OData. Similarly, for querying also JSON format is used. That's below that. To learn more about OData, please visit the Microsoft page, Open Data Protocol by example. It gives you clearly how OData works. With this, we are finishing about JSON. Now let us move to the next topic. We are going to see about the basic but the most necessary CRUD operations against MongoDB. CRUD stands for create, read, update and delete, that you know already. We'll be using 4 different tools for this purpose. All 4 are famous, frequently used, very powerful and feature-rich tools. Knowing these 4 tools is going to enhance your knowledge, confidence and brings more clarity to the learning path. To start with, we'll be using the most famous tool among these 4, the RoboMongo free tool. Then we'll be using the powerful MongoCHEF tool. MongoCHEF has an outstanding drag and drop query builder which can make you work against MongoDB with a minimal knowledge. Following this, we'll be using MongoBooster. It has quite a lot of features which will astonish you. One of the loveliest thing about this tool is that in addition to IntelliSense feature, it can show you the API exactly right in your command line. So there is no need for you to refer to the documentation. Right there in the command line, you can see the API of the command or the method you are going to use. And finally, we'll be using MongoView. This is also a great tool. MongoView has been there for quite a long time. It can easily help you in migrating from your pre-existing MySQL to MongoDB, as well as has a great GridFS and a server monitoring interface. We have separate sessions for these 4 tools. Those will explore these tools in detail. But now to begin with, we are just going to do the CRUD operations using these 4 tools. And in the later sessions, we'll be seeing about these 4 tools in detail. Again, I'm repeating, these are simple tools that can easily be learned in 15 minutes of your time. But learning this is going to give you a lot of confidence and clarity. Let me start with RoboMongo first. We are going to do a simple CRUD operation against MongoDB using RoboMongo client software. These are the simple steps we'll be seeing in this exercise. To start with, we'll be connecting using RoboMongo to the Mongo server. Then we'll be creating a database. And in the third step, we'll be creating a collection under that database. This is the RoboMongo interface. On clicking this, you'll be prompted for MongoDB connections. I have a saved connection, so it is getting listed here. In your case, you just need to click create and you can provide the name you like in the name field. For example, MongoDB local. These 2 values get auto-populated. That will be the localhost and 27017. This is the default port of MongoDB. Let me test with that. So connection is successful. Authorization is skipped, that we know. Then on clicking save, it gets saved. And on double clicking this one or clicking connect in the bottom, it will connect to the MongoDB server. In the left side, you can see all the databases in the server getting listed. Our first step is to create a database. So we are going to do this, create database. Then we are going to give a database name, db underscore crud demo is the name. So I got the database here. Initially there won't be any collections, that you know, because we haven't created a collection. To create a collection under this database, right click on the collection folder like icon here and click create collection. Let it be a demo CRUD collection. Now we got an empty collection without any documents under that. On double clicking this collection, it will open a shell prompt for this collection. We are not going to use that as we are going to see only the simplest things initially. Now back to our listing. We have connected to server, we created a database, we have done creating a collection under the database. Now to the crucial ones, that is create a document, read a document, update a document, and delete document. We know that a document has a JSON structure. To create a document under this collection, right click over here, click insert document. So we got the opening and closing braces of a JSON. Now we need to put some JSON content under this. I'm going to take the personal details JSON content from Wikipedia. This describes a person, so I'm going to copy this. After copying the content, I'm going to paste it here. So there is no need of an extra brace. On clicking validate, it will show whether the document is valid or invalid. For example, if I delete this one, it must show it is invalid. Yes, as we expected, it is showing that this JSON is invalid. Let me introduce that again. It's valid. On clicking save, we are going to successfully insert our first document in Mongo database. Now to view the documents, right click here on the collection, click view documents. We got the document. To see it in JSON view or in tree view, you can click here. I'm going to see that in table view first. This is the table view, and then in JSON view. This is the document we have inserted. It has automatically added the ID element to the document because every document has to have a unique ID key. Either it will be auto-generated by MongoDB if you are not providing, or you have to provide a unique document identifier over here. Next step is to create one more document but with a different structure. That is the beauty of MongoDB. I'm going to paste it again. I'm going to remove the address and phone number fields completely, and even the children and spouse fields. I'm going to totally add a new field, PAN card number. This is the income tax number in India, and similarly I'll be adding EID number, which is Emirates ID number for United Arab Emirates. Unable to pass. That's because I hope I have an extra brace. Now the JSON is valid, and on saving, I'm saving my second document to the collection. Right click and clicking view documents. I got two documents. In table view, it will be very clear. So two documents are there. And in JSON view, you can see the real JSON content. So now we have successfully created a collection. Under that collection, we have inserted two different documents with totally different structure. That's why MongoDB is a NoSQL database. We have done with insert and view documents. Now next in our list is update, delete. Let's do that. To do update, I'm going to shift this to the tree view. Right click on the document, edit document is there. On clicking that, the document is shown. Now I wish to add a spouse and children.
Kate and the children are Johnson. Andrea. So we have altered the contents of the JSON now. On clicking valid, the JSON is valid. Now on saving, we must see the changes reflected here, or you can go to the JSON view to see the same. So these are the contents we added to the existing JSON. This is how update works. We haven't done through the query, we have done through the GUI using the table view, the tree view, and then we have right clicked there and did a edit. Now next, to delete the document, that's very easy. You can always use the delete document in the menu here. So let me delete the document. On clicking yes, it's going to delete the document. Let me execute to find the, let me right click on the collection to view the documents. So only one document we have, the other one we have deleted. So with this we have seen about update and delete document. The next in our list is copy collection, copy document, export collection, drop collection, drop database, and disconnect from the server. We don't have export collection in RoboMongo. We have to do that through command line. I don't want to do that now. So let me do the copy collection and then the copy document. Copy collection is very easy. Right click over here and clicking duplicate collection, it's going to create a copy. So we got a copy collection. That's very easy here. The next one is copy document. That's very easy. Right click on the document, click copy JSON, and then right click here, insert document, paste the JSON, just change the ID. I'll make it as 99, and then on clicking save, it must save the document. So we got two documents now. Next is export collection. As I said earlier, we don't have export collection. Now to drop the collection, drop the database, and disconnect from the server. That's very easy. To drop this, I just need to right click, drop collection, done. Then to drop the database, right click, drop the database, done. Database is gone. These are all old windows. Even if you execute this, you won't get anything because the database is non-existent as well as the collection. Now to disconnect, right click on the icon here, disconnect. That's it. We have done all the things in the list using RoboMongo software. Now to the second tool in our list, that is MongoCHEF. We are going to do the same steps what we have done with RoboMongo previously with a powerful tool, this time called MongoCHEF. Though MongoCHEF has all the advanced features, till it has a very cool feature called Query Builder. This Query Builder will save a lot of time, really a lot of time for experienced MongoDB professionals, and will surely make the learning curve easy for the newcomers. Let us start our CRUD operations using MongoCHEF now. These are the steps we are going to execute using MongoCHEF. The first three are the simplest one: connect to Mongo server, create a database, create a collection under the database. Let us finish these three steps first. So this is MongoCHEF. To connect to the database, click on this icon. It has a capability to automatically import the connection from the RoboMongo software. So it has already imported. Or if you want to do it explicitly, you can click import, Or if you want to create a new connection, click new connection. The parameters are simple as we have seen earlier. You just need to give the server name, the identification name here, and the default port or the port in which MongoDB is running. You can test the connection. I'm going to use the same one which it has automatically imported from RoboMongo. I'm clicking connect. It has connected successfully. You can see the list of databases in the left panel. Now to the first step, to create a database. So click add database. Terms are different here in RoboMongo. In RoboMongo, I think it is create database. Here it is add database. Let me give the database name demo_crud_db. We got the database without any collections. Right click, add collection, or collection_details. There are many options. We will see these options later. Now it's time just to create the collection. We got the collection here. The most important thing is the query builder, which we are going to cover in a separate video session. This will help you in dragging and dropping and building the query dynamically. We'll be seeing it separately. Prior to that, we just need to view the document. Right click here, click open collection view. It's going to show you all the documents. Currently, we don't have any documents, so it's empty. Now to the next steps. The important ones: create document, read document, update document, and delete document. To create document, it's easy. You just need to right click here and then click add document. The ID field is shown here. I'm going to copy the same document from the Wikipedia. On clicking add document, it has to add the document. So it has successfully added. Like in RoboMongo, here also we have the three views. Either you can go with the tree view like this, or you can go with the JSON view, which shows you the source. The ID field is added here. Now to add one more document, again I'll be clicking add document. This time I'm going to give the product details. On clicking add document, it's going to add the second document to our collection. So I am again iterating that this is schemaless, so you can save different documents with the different structures into a same collection. So we got two documents. You can see here in the table view to confirm the same. The structure is totally different. Now to the third one in the list, that is to update, and the fourth one is to delete the document. To update the document, right click here, edit JSON, available at Amazon, validate, and click update. Now we have added a new field available at Amazon, and it has successfully updated the existing document. You can confirm the same using JSON view. Now to delete it, let me go to the tree view, right click over here, click remove document. Document is gone. So we have seen the key steps: create document, read document, update document, delete document. Now to copy collection, copy document, export collection, drop database, and disconnect from server. To copy collection, it's very easy. Right click here, copy collection. So you just need to select the database. And then I just need to paste it. So I'm going to paste on the same thing. The name is going to be copy of collection details, copy collection. So I got two collections in the same database, or I can go to any other database and then paste it. For example, this database, I can paste the collection. It's as easy as that. We have done with copying collections. Now to the copy document. That's very easy. Right click here in the document, copy the document. Right click on the same collection or to a different collection. In this case, I'm going to click on a different collection. Right click here, click paste documents. It will prompt for import documents from clipboard. Click yes. And then if you want to refresh the view, click the view. So we got two documents almost with the same content. So in our list, copy collection is done, copy document is done. Now to export collection. Export collection is very, very easy. Right click on the database, go to export collections, select the collections you want to export. In my case, I want to export this collection details. I selected it and the target folder. So under my documents, I have a folder demo Mongo export. I'm going to export the contents there. I'm clicking export. The contents must be available there. It's under documents, demo Mongo export. It will be available as a JSON file. Now to the next one in our list, we have done with export collection. Drop the collection, drop the database and disconnect from the server. So to drop the collection, right click again, drop collection. Collection is gone. To drop the database, right click here, drop database. Database is gone. Now to disconnect, right click on the server, then disconnect. That's it. So we have done successfully these steps with the MongoCHEF tool easily.
CRUD using MongoDB. In our previous sections, we have seen how to do the same using RoboMongo software and then using MongoCHEF. Now we are going to see about how to do the same CRUD operations with MongoBooster. Every tool has its own unique way of operating. Let us explore how MongoDB does the same operations. Initially, we'll be doing a connection to Mongo server. We'll be creating a database. We'll be creating collection under that database. These are simple. Then we'll be creating documents. We'll be reading the documents. We'll be updating and deleting them. So let us do the first part. I mean all the 7 steps using MongoBooster. It's very, very simple. So the first step is to connect. You can create your own connection like this, and you can provide a name for your connection. If your server is running in a different port, you need to edit the port over here. Click save. So the connection will be saved like that, what it has been for my machine. Let me disconnect this. Already I have connected to that. The first step is to create a database. That's very easy. Right click over here, create database. Database is created. The next step is to create a collection. Right click on the database name, click create collection. Collection is created, but currently there are no documents in that collection. To insert a document, right click over here, click insert documents. This is different when compared to RoboMongo software, because in RoboMongo we have been presented with a window in which we can edit the JSON data directly. Here we have been presented with a query. Inside the curly braces, you need to feed in your JSON data. In our case, it will be a student data. student ID. Let me make this as a number. Let it be 12, comma 460. So this is the first set of data. Let me insert a few more. Here the ID is going to be 13, mark is going to be 470, ID is 16 or 15, mark is going to be 490. On clicking run in the toolbar, the data will get inserted. You can see in the results 3 records are inserted. Now to view the data, right click on the collection, click view documents. Similar to other clients, we have 3 views here: table view, JSON view, and the default tree view. You can set the default view in the options. That let me show it later. This is the table view of the data we have inserted. The next step is to update the data. Right click here, edit document. You can easily change the data over here and then run. So we got modified one, updated one existing records. Again, to view it, right click, click view documents in table view. The next step is to delete document. That you can easily do by right clicking here, remove document, or you can right click here and then click remove documents. You can give the selection criteria here. For example, I want to remove the student ID 13. This is the beauty of MongoBooster. The field names will be auto-populated. I mean, it appears in the IntelliSense. On clicking run, it must remove the data. Let us cross-check the same. Now we have only 2 documents. The IntelliSense support is very good in MongoBooster when compared to other softwares which I have worked. Moreover, there is a very cool feature, that is when you keep the cursor over the method, you want to see the definition, the API will be shown in a pop-up. The API shown also has an example of implementation. For example, in this case, you can find db.products.find quantity greater than 25 and less than 35 is an example given for this find method. So MongoBooster is a great tool for beginners as well as for advanced users and saves you a lot of time when compared to the other softwares, especially for editing the queries or creating new queries. With this, we have done the basic 7 steps, that is to create database. Then we have created a collection under that. Under the collection, we have inserted documents, deleted documents, viewed documents, and then updated documents. Now to the next set, that is to copy collection, copy document, export collection, drop database, and disconnect from the server. So these are very easy. Copying a collection is very easy. Right click on the collection name, click copy collection. Collection is copied. You can either paste to a database like this, or you can paste to the same database. 3 options will be presented. Either you want to append a collection, append to existing target collection, or replacing the existing target collection, or create a new target collection. These options we haven't seen in the other tools.
I'm going to create a new target collection. Copying started. So copy is successful. We got two documents like that of the source one. To copy documents, it's very easy. Prior to copying, I wish to edit the document. The total marks is 555. I'm going to change this as 444. And on executing, it must update it. Updated. Let me cross verify the same. Table view. So we got a document with total marks 444. I'm going to copy this document to calls student data collection. That's very easy. Right click on the document, copy document to the clipboard, and then select the collection, view documents, right click, paste. The issue will be the unique ID. Do remember that we just duplicated this collection here. So if I'm going to execute this, I'll be getting a unique error, a duplicate key error I got. So let me change this object ID to something like this. Yes, sorry, I need to remove this. Got executed. Let us view the documents. We got 3 documents. So this is how copy documents work. The next step is to export the collection. That's easy. Right click on the collection, give export collection. You can either use the built-in tool in MongoBooster, or you can use the Mongo export utility. Format as JSON. You can even select the CSV format. The fields required, delimiter, I'll be selecting comma delimiter. Yes, that's a default one, and the target file name. This tool is very friendly. You can see here, this is the CSV content what we have exported. So we have seen how to copy document, how to copy collection, how to export collection. Now to the destruction mode, that is to delete the collection and drop the database and then disconnect from the server. Delete collection is very easy. Right click here, drop collection. Done. Now drop database, right click on the database, click drop database. Done. Database gone. Now to disconnect, right click, disconnect. We have covered all. Copy collection we have done, copy document is done, export collection to CSV we have seen, drop collection we have done, drop database is done, and disconnect from the server is also done. So we have seen our demo using MongoBooster software. As I have mentioned earlier, MongoBooster is very friendly, very powerful, even for beginners as well as for the advanced users. We have seen CRUD using MongoBooster. The next one in our list was MongoWoo, but we'll be using a different tool this time that is called NOSQL Manager. It has many features like MongoWoo. So we are not going to see this one. We'll be using a different software called NoSQL Manager. This decision is made because, as you can see, the downloads page of MongoWoo, there are no updates after 2014. This is the MongoWoo software.
installed in my system. If you click the about, you can see the build date is on 2014. So there are no latest releases. So a decision to shift to NoSQL Manager is made, where the latest release is on July 18th, 2016. This has many features, and more importantly, it has two key features, that is IntelliSense, and the second one is import from external database, which was one of the good feature of MongoDB, whereas NoSQL Manager has also got the same feature. In addition to that, it has a good IntelliSense support. So NoSQL Manager, this is the NoSQL Manager software. Back to our presentation. So our fourth tool in our list is going to be NoSQL Manager. These are the demonstrations we have to see using NoSQL Manager, that is to connect to Mongo server, create a database, create collection under the database, and then the CRUD operation. So this is NoSQL Manager. You can click connect like this. You can specify the host and port, and it will connect to you the local host. These are the list of available databases. So the first step is to create a new database. Right click here, and then let us give a demo NoSQL DB. So this is going to be our demonstration database. Under this, we have to create a collection. By default, a dummy collection is created. We don't need that. Let me create a new collection, that is products. You have three different options. Either you can go for a capped collection where the size is limited, or auto indexed. This is default, so I'll be going with that one. So that's done. The next step is to do the CRUD operation. So right click here, click open products collection. Under data, you can directly add a document like this, or you can go for the shell. I prefer shell, so I'm going to use that one. So right click here, select shell. So you'll be landing on this window. To insert a document, db.products is our collection. Just see the IntelliSense, it's very useful feature. Insert. It's going to be the name of the product, Vivo Smart. The price is $199. Return. I'm going to do a few more inserts. Xbox, yes. Price is $299. Then we got the Fire TV. Price is $99. Then we got the Casio Wave Scepter model, which is around $60. All are inserted. Let us check the same. So we got 4 different records. You can shift to the view here. You can go for table view like this, which gives you a lot of clarity, or you can go for the text view. I mean the JSON view. So tree view, table view, text view. The next in our list is to do a find. That's very easy. db.products.find. Done. So if you want to filter a particular result, you can do this one. The name is Fire TV. Next in our list is to do an update. So db.products.update. The filter is price is $199. I'm going to change the price to $190. $set 190. So matched one. Let me cross check here. 190. Change is applied. Next one is to remove the document. Product.remove. Oops. Where the price is going to be 190. Let me check here. That's gone. So this is how the CRUD operation is done using NoSQL Manager. The next one in our list is to do a copy collection, copy document, export collection, drop database. So to do a copy collection, right click on the collection name. You can duplicate the collection, so it will be in the same database like this. Or you can copy to a different database by right clicking, click copy products in the context menu. To drop this one, right click here, click delete products collection. So this is going to take out the collection. Collection is gone. To export the collection, right click here, click export collection data. You get 4 different varieties of output. Export to Excel 2007 is a new one which we haven't seen in the other tools. So you can use this one to export the data. The next in our list is to do a copy document. That's very easy. Right click here, do a copy document to clipboard, and then you can do an insert here. Products.insert. Got inserted. This is a new one we inserted. So this is how we can do a copy document. We have seen about export collection, drop collection. We just need to do a drop database and disconnect from the server. So that's easy. Right click here, delete the database. Database is gone. Then right click, disconnect. We are disconnected from the local server. One of the cool feature of NoSQL Manager is that it can import data from MySQL and Microsoft SQL Server. That can be easily done. For instance, select a collection, go to the tools menu, import data from external database. This is going to present you with 2 options. Either you can select MS SQL Server or MySQL. With this, we have finished the demo using NoSQL Manager. So we have seen all in our list. We have seen how easy it is to do CRUD with MongoDB using the tools. Now to the final part of our stage 1, that is the last question, how to load test data in MongoDB. Test data for our MongoDB can be loaded from 4 different sources, either from a CSV format or from data generators like generatedata.com, and using JavaScript, and finally using JSON format data. We'll be using 2 simple test databases provided by the MongoDB team. The first one is restaurant data. As you can see over here, the test database is explained. It's a restaurants collection with some ranking here similar to Yelp service. So we'll be using this test data. The link for the JSON file is provided below. On clicking this, you'll be able to see the JSON file. So we'll be using this JSON file in our MongoDB to create a restaurants collection. Similarly, one more test database is provided by MongoDB team, that is places with zip details. This is the page where you can get that also. So place with some zip code is given here in the JSON format. So this JSON has city details. As you can see the data model over here. For this JSON, you can click this link available here. It gives you the zip codes JSON. So we'll be using these two JSON files in our MongoDB. So let me save them locally. And this is for restaurants. Now I'm going to use MongoBooster to get this JSON file inside. I'll be using the Mongo import utility. So prior to that, let me create a database first. The first one is from MongoDB team. Importing is very easy. Can do this visually. So the document started importing. So it has successfully imported. This is a huge collection with around 25k documents in that. You can see the details here. And similarly, on keeping the cursor over here, you can read the details about this collection also. It has around 27,000 documents. We'll be using these two, and we'll be also using the Northwind database. One more thing, do remember that we can do the same import using the import command provided by MongoDB. I'll be showing that also later for a CSV file. This is Mongo import. Can use the same, or you can do it easily through the visual interface provided by MongoBooster. Before proceeding further, let me view the contents. On table view, and on JSON view, and similarly for zips also. Table view, this is the one, and on JSON view also. We have successfully loaded the test data from MongoDB team, that is the restaurant and a zip JSON file, and we got two collections. Now we have to load the data in CSV format. This is from GitHub. Somebody has cleverly and usefully exported the data into CSV format so that it can be used in MongoDB, and they have even mentioned the steps very clearly. Northwind database is a famous DB design from Microsoft. It is very simple. This is being used by many tools to demo their work. This is the CodePlex page for Northwind database, and you can see the database diagram here. This is very simple order processing application database diagram. There are four important things in this database diagram. The first one is product and categories. Second one is order details and the shippers information. The third one is employees, employee territories and regions. And the fourth one is customers and their customer demographics information. So as I said earlier, this is useful for a simple order processing application. We are going to load this one to our MongoDB. The developer Tristan has did a great job in exporting this in CSV format, and even he has explained here how to do a Mongo import, but this is for a Linux machine. For Windows, we'll be using the Mongo import command line. So let me download the file. I have extracted the zip file. Let me open a CSV file and show you the contents. For example, this is the territories.csv. The first line has a column names followed by the data. So do remember that the first line has column name. So this needs to be filtered out while we are importing the data to MongoDB. If you don't want to use Mongo import utility or the command line, you can easily use an NOSQL Manager tool to import the CSV data. That can be easily done through Tools menu, Import Data from File. On clicking this, there will be two options, CSV and JSON. If you select CSV and give the file name, it will be imported to the database and a collection will be created. So you can use NoSQL Manager if you don't want to use a command line, but we are going to use command line Mongo import. Mongo import command line documentation is available here. It's a very simple command. We need a database to import as well as a collection to be populated. So we need to specify both here. So database is specified using DB option and collection is specified using the -- collection option. Then we have to specify the file which is going to be imported and the type of file, because JSON is also supported. So you need to specify the file type and the file path. So that has been did here. As you can see, -- type CSV. So this says that this is going to be a CSV data, and the complete file path is given using the -- file option. And you need this header line, as I have mentioned earlier. The first column is, the first row is going to be the column name. So that needs to be filtered using -- header line. Again, I am repeating this. Mongo import command is very simple. As you can see, there are the first two options are for the collections and the database name. The next two is for the file type and the file path. And if you have column names mentioned in the first row, you need to specify with header line. So let me do this one for all the files present here. I'm going to replace this with this path, etemp MongoDB test data. And on executing on the command line, so I have to call the Mongo import utility. So I'll be shifting to that directory. Server bin, and I'm pasting this. Yes, it has successfully imported 53 documents. Let me cross verify that. So totally 54, and the first one is having the column name details. So 53. So 53 has been successfully imported here for the territories. So I'll be repeating the same steps for the other CSV files. I faced issues while importing employees.csv because of the double quotes. So I removed them and the documents got successfully replaced. So just use Notepad++ to replace the double quotes with empty character. So on clicking replace all, this issue will get solved. Let me see the imported data. So this is the north wind which got imported through command line. Categories we got, orders we got, products we got. So let me check the regions. So table of structure. So 4 regions. I want to check the same whether it has imported properly or not. Yes. It seems the imports are successful. Now we have done with the JSON import as well as the CSV import. The next one is to use GenData to generate test data. I'll just show this one as well as how to use JavaScript to generate test data. Though there are many test data generators, I selected generate data because of its clear interface. It's free, though the online version has a restriction in the number of rows generated, but there is a free version which you can host on your local web server. We have been using this for more than our 7 projects, and it has a very cool feature that you can export to different programming languages also, like for example PHP. The data will get exported in array format. We are going to export the data in CSV format. So the first step is to set the dataset name. Country specific data. Let me select United States. This is not required. I just selected. I'm going to generate a personal details test data. Name is going to be of names, and the example is going to be the male name. Age is so number range, it's between 15 to 80. Phone, phone or fax. Let me select the UK format. And similarly company, the data type is going to be company here. I want to add a date column here. DOB. Date. The next step is to specify the delimiting character. I'm going for comma separated, and the file format is going to be JSON. Sorry, it's going to be CSV. I'm going to prompt it for download. I got the data generated. So this is the test data generated from DataGen, and as always I can easily import this data using NoSQL Manager. So I'll be using that now. Prior to that, I want to create a database. TestDB. This is from generate data. And I'm going to create a collection. Person. We are going to import data from file. It's a CSV file. It's under downloads. Next step. As you can see here, the data is listed here clearly in the NoSQL Manager tool. And on clicking next, the data type selection is given here. And on clicking next, either you can import to a new collection or you can go with the existing collection. I already created a collection named person. And let me execute this. So 100 documents imported. Let me check that. So db dot. There is a cool feature of IntelliSense. We are going to find all. Clicking execute. It's taking time. So this is the personal details collection we have created with 100 documents. Now we have seen how to generate data using generatedata.com. So the final one is to use a JavaScript. Let me create a test database for this. TestDB.js, and under the collection, dummy collection news. I got a dummy collection. Now using JavaScript, I'm going to insert some test data into this. That's quite easy. You just need to put a for loop over here and the insert statement under that. So in my case, it's I equal to 0, I less than 10,000, I plus plus. Here db dot dummy collection news dot insert. The semicolon here is optional. It's going to be title of the news is going to be Tesla 3 released. Come on. views for this is 89997. That's it. On executing this, you must get around 10,000 documents. Let me query this. As you can see here, we got test data populated from JavaScript. So what we have done is we made a for loop over the insert statement and then we have pressed execute. That's it. With this, we have seen all the 4 ways of populating data. We used JSON from the MongoDB team, zip and the restaurant details in JSON format. And for Northwind DB data, we got in CSV format from GitHub. Then we used generate data to generate around 100 rows. And finally, we have seen a simple example using JavaScript to populate test data. With this, we have successfully finished the stage 1 of our MongoDB learning. We have seen why MongoDB is important. We have seen the key features of MongoDB to focus it. We have seen how to install MongoDB. And we have seen what are the things in the installation package. Later we have seen about the core part of MongoDB, that is a JSON file format. Then we have seen about tools to learn MongoDB easily, MongoBooster, NOSQL Manager, RoboMongo. We have seen about the basic CRUD operation in MongoDB, how to find document, update document, insert document and delete documents. Then we have seen how to load test data in MongoDB. With this, we have successfully finished stage 1 of our learning. Now let us move to the next one that is going to be very interesting. Let us start with the queries. Really they are very lovely as they are organized well and they are very easy to learn. In the beginning, we will learn the easy and the vital ones. This diagram simplifies the understanding about MongoDB queries. This diagram has 4 sections as you can see here: comparison operators, logical operator, the useful methods, and details about the update statement. Let us start with the comparison operators. Like every other language, we have greater than operator, greater than equal to operator, less than equal to and not equal to operators. In, not in and all are used for arrays. We'll see it later. Now let us focus on greater than equal to, less than equal to and not equal to. After the comparison operators, we have logical operators. There are 4 main logical operators: and, not, or and nor. We'll be seeing about those. Then we'll be covering the useful methods: limit, sort, skip, and then we'll be seeing about insert one, insert many, find and modify, delete one and delete many. These methods functionalities can be easily understood from their name itself. We'll be seeing about them in detail. And finally, we'll be seeing about update. Set is used for setting a field, unset is for removing a field. Increment, multiplies, push, pull, pop, this is used for arrays. Rename a field, set a current date. Min and max are different. Min updates a specified field value if it is less than the specified value, and max updates a field value if it is greater than the specified field value. We'll be seeing all these things through examples. Now let us start with the find query, and we'll be using these operators over there. Let us start with find method. As you know the syntax for find method: find, query, and the fields to select. Query means query can be with conditions, and the fields to select. You can select certain fields meeting these conditions using find. Just remember the syntax. Find has 2 parts. The first part is for query and second part is for field to select. And one more thing, both are optional.
Either you can specify them or just leave them, so we will get all the values. Like in SQL, select star from a table without any condition, and it selects all the fields in the table in SQL. Similarly here, if you don't specify the query and the fields to select, it selects all the value. Let us see some examples using this so that we can understand it very clearly. And we are going to execute these queries against the Northwind database on the collection regions. So for this query exercises, we'll be using a regions collection which is under Northwind database. Before proceeding, just remember the syntax of find method. It has a query option and a fields to select option. We'll be using MongoBooster this time, and occasionally we may use RoboMongo also. MongoBooster is selected because, as you know, it has a great IntelliSense support as well as a good documentation support. I selected this collection because it has very less number of documents as well as has a very clear JSON syntax with only 2 fields. The ID field is auto-generated, that you know. If you click a JSON view, you'll be able to see it. It's a very simple document. So learning will be very easier. To find all, you just need to give the find command like this. If you want to know about the find command further, just keep your cursor on that. MongoBooster will display its details. So the first query is to select the northern region like this. So let me give the field name. This is the beauty of MongoBooster. You will get the field name through IntelliSense, and the value is going to be northern. Running this, we got one result. If we shift to JSON view, you'll be able to see it clearly. So we got a region ID and we got a region description which matches our query. So if I want to select by region ID further, I can give like this. I have given the value as 1, so it must not fetch any values for us. I mean any documents for us. So we haven't got any. So let me change this to 3 and we must see the document in the resultant. Yes, we got the same, where the region ID is 3 and the region description is northern. So in table view, it is like this. I want to filter this field out, so that's easy. Always remember the syntax, the query and the fields to select or filter out. Let me do that. I don't want the ID field to be present here. So 0. 0 stands for false. You can even type true or false. I don't like that personally. Now you can see in the result, the dash ID column is filtered out. I mean the underscore ID column, which is auto generated, is filtered out. You can even filter out the region ID column also. That's easy. So region ID is also filtered. So this is how you can filter out the fields from the resultant by giving false here. Same result will occur. We have seen about a query and how to filter out fields from the result. Now we are going to see 4 useful methods. That is count. This is for counting the number of documents in the result. Limit is for limiting the number of documents that's going to appear in the result. Skip is to skip the number of documents. And finally sort, this is used for sorting the documents in certain order. 1 you can give for ascending and -1 is for descending. So let us see how they work. I'm going to take off this spot. So this must return us 4 documents. Let me change to table view. So we got 4 documents. So count method, please see the API description here, must also give the same result to us. Here we got 4. The next one is limit. So I wish to limit the number of records to 2. So the result also has only 2 documents. Now let us see about skip. So see the API description over here. I'm going to skip 2 documents. So we got only 2 documents in the result out of 4. So without this we'll be getting 4. So this first 2 are skipped. Finally, to sort, I wish to sort the result in ascending order, that's in region ID's ascending order. That's very easy. Sort, and the sort field is going to be region ID and it's going to be in ascending order. So I have to give 1. So we got the result in ascending order. You can see over here, region ID, it's in ascending order. If you want in the opposite one, that's a descending order, you just need to give us -1. So we got the resultant documents in region ID's descending order. So with this we have seen these 4 important and useful methods. Now let us proceed to the next section. We have seen about the useful methods. Now we are going to focus on comparison operators and logical operators. Both are very, very interesting. For comparison operators, the syntax is different. As you can see here, you need to specify the field name first, followed by a colon and then the curly brace where the operator with the value will be specified. But for logical operator, it is totally different. You need to specify the operator first, followed by the colon, and then you'll be having an array of conditions which will be grouped under a square brace. We'll be seeing good examples of this to understand both of them. Now let us proceed to MongoBooster to see how these logical and comparison operators work. We'll start with comparison operators first. For this, we'll be using a different collection, that's a product collection which has some good information. Let's see the product collection first. In table view, it has around 77 docs. Let me limit by 1 to see the structure in JSON. As you can see, it has a product name, unit price, units in stock, units on order. So we'll be using these fields, unit price and units in stock, for our comparison and logical operators. To start with, I wish to find the unit price of items which are below 100 pounds, I hope. So unit price of items which is below 100 pounds. So I have to use less than operator. You can see in the IntelliSense it's going to be 100 here, and I don't want limit here, so I'll be just taking it off. On executing, you must see the items listed with unit price lesser than 100. So let's see the table view to confirm the same. So this is the unit price field or column. You can check those. We got only items which has unit price less than 100. So for greater than 100, you just need to put greater symbol like this, and you just need to run this. So only 2 items have their unit price greater than 100. To find exactly the value, you just need to specify with equal symbol, with equal operator, with the unit price 123.79. I'm going to specify the value exactly, and on running we'll be getting a single JSON document. So we got this. So this is how the comparison operators work. So we have seen about comparison operators. In, not in, and all will be handled while we are dealing with arrays. So now we are focusing only on this basic comparison operators. We are going to see about logical operators. Prior to that, I wish to mention one more thing. You can have multiple conditions here. For example, I want the unit price between 50 and 100. I can easily specify like this, whereas greater than 50 and less than 100. So on running this, you must see items with unit price between 50 and 100. Let's go to the table view. So these are the items or having unit price between 50 and 100. So this is the query we used for finding the same. Now let us start with the comparison operators. So I'm going to take off this. To start with comparison operators, I'm going to see the discontinued items first. So discontinued is 1. So I'm running this. There are around 8 discontinued items. And I want to make a condition that discontinued items whose unit price is greater than 100. So we must get this product name. It's an AND operator because we are having 2 conditions. Both of them must be met. To remember that, we need to have a square braces for the conditions. We have 2 conditions now. The product must be discontinued and its unit price has to be greater than 0. So you just need to specify here the unit price. So as we expected, we got a single result. Let me see it in table view. Exactly, we got a single document with the unit price greater than 100 and it is in discontinued state. So this is how the AND works. So just remember the syntax. You just need to put the logical operator in front, and then within the array braces you need to specify the conditions. I have 2 conditions, so I have specified both of them inside a curly brace separated by comma. So now to the OR condition, I wish to see items which are either discontinued or their units in stock is 0. So or here units in stock is equal to 0. Let me execute this. So we got the discontinued items as well as you can see here this item has 0 units in stock. So this is how the OR condition works. We have seen about OR and AND condition. This is the same for NOT and NOR condition.
With this, we are finishing queries. Now let us proceed to the next section.
We are going to see about update documents. Updating documents in MongoDB is way more simpler than finding and inserting documents. For updating, we'll be using the method under collection, that is the update method. The update method, as you can see here, takes 3 parameters. The first 2 are mandatory parameters, whereas the third one is an optional parameter. The first parameter query is for selecting the matching records. The second one contains the update values, and the third one is for setting the optional parameters. You need to remember 2 key things about this update method. Update method will update only a single document, and the second most important thing is you must use a set operator if you are going to update the field values, or else it's going to replace the entire document. If you're not going to use set operator in the update parameter, it will replace the entire document. In most cases, we'll be replacing the field values only, not the entire document. So always remember to use the set operator. Now let us proceed to our demo session. For this demo, I'll be using MongoBooster and our Northwind database. Under Northwind, I'll be using the shippers collection. As you can see, this collection has only 3 records and it is very simple. It has only 4 fields. One is the ID field, the other 3 are company name, phone and shipper ID. To start with, I'm going to make a duplicate of this collection so that the original remains untouched. Let me close this. So we got the shippers copy. Clicking view documents in table view. All the fields are present. The first step, I'm going to update this phone number of the first document. That is, the company name is United Package. To do this, I'm going to use the update method in the collection. Update syntax is very easy. As I mentioned earlier, it takes only 3 parameters. You can see in the screen, the first parameter is the query parameter, the second one is the updater, the third parameter is optional. Optional, we'll see it later. Now we are going to see only the query and updater for this query. I'm going to leave this one empty because I want to select all the records, all the documents. The second one is the update value. In that, I'm going to give the phone number. The phone number is 1234567. On executing this, it will update the first document but in a different way. That's a catch here. It has modified one. So let us do a find again to view all the records. So the first document got updated, but in a way that we haven't expected, that it has changed the whole structure of the first document. If you click view document, it has only 2 fields, whereas the other documents have 4 fields totally. This happened because we haven't used the set operator. So to use set operator, that's very easy. But this time I'm going to select this company name. So that we can see the difference. Let me view the document to copy the web. Oops. Company name is Speedy Express. Same thing I'm going to give in the selection query. We have to use the set operator. That's very easy. You just need to give $set and then cover it with curly braces. Now let me execute this. We got one modified, and let us view the documents in table view. As we expected, this update method has updated only the field which we expected to change, not like the previous one which has completely changed the structure of the document. So always remember to use set, because in most cases we'll be updating only the field value, not the complete document. So if you want to completely update the document, use this, and if you want to update only the field values, use this query with the set operator. Now to the next interesting topics in our list, that is multiple updates, update one, update many, and upsert. We are going to see all these four. It's very easy and simpler. Let me copy this one. To start with, we are going to see about multiple updates. So under multiple updates, I want to update all the phone numbers of these companies. This time I'm going to use a different phone number, XYZ123456 or 12345. If you see the syntax for update, in the third parameter after query and updater, we have upsert and multi. We are going to use multi option now, which is a Boolean value, or you can give a number. I have to set the third parameter now. I am going to use a multi option, multi true. On executing this, we must see multiple updates of the phone number which is matching this query. The query here is empty, so it's going to match all the documents. On executing this, we got 3 modified. Let me see the results again in table view. You can see here all the documents have got updated. This is because we have used a multi-true option. If you don't use this option, only a single document will get updated. That we have seen it here. So this is how we have to do multiple updates. There is another way of doing this, that is by using update many. Let me show that also. db.shipperscopy.update many. So to the syntax first, query, update object, and the options. Either you want to upsert or not. I'm going to use the same without multi-true option. I'm going to make it as ABC. So instead of update with multi-true option, I'm going to use update many method directly. Again, the modified count is 3. Let me see the documents in table view. You can see here we achieved the same result as that of the update with multi-true using update many. I personally prefer update many over multi-true option. Similar to update many, we have update one, which is going to update only the first document. This is the syntax. It's same as that of update many. Instead of ABC, I'm going to make it as EFG. This has to update only the first document, which is going to match this query. Matched count is 1. Let me do a find.
table view. So the first one got updated with EFG 1, 2, 3, 4, 5, whereas the other ones have ABC 1, 2, 3, 4, 5. This is how update 1 works. We have seen about update with multi-option, we have seen about update many, and then we have seen about update 1. Now to the most interesting one, that is upsert. Upsert is a combination of update and insert. You can easily understand from its name, it is going to search for the update query. If it is not going to match, it is going to insert a new record. To do that, I'll be using the old update method, or I think it is better to go with the update 1 itself. Let me copy this because it has also the upsert option. Syntax. If you watch the screen, you can see the upsert option in the third parameter. Let me do that. Upsert true. Here, instead of an empty query, I'm going to give the company name as company name as some company in Panama. This must create a new record because there is no matching company name for this query. On running this, we got no modified count. Let me do a find, and we must see a new record, the fourth record. On table view, this is the beauty of the upsert method. We got a new document created with this query parameter, what we have mentioned. It has no matching values, so it has created a new one. If it has matching value, it is just going to update this. That also I'll show you. I have used update 1, HIJ. On executing this query, we must see this phone number must get updated because we have the same query matching document over here. So modified count is 1, means we got a update. On table view, this is how it works. It has just updated since it has found a matching document for this query. So with the upsert true option, you can go for update, or if there is no matching document, it will create a new document for you. Deleting documents in MongoDB. Deleting documents can be done through these 3 simple methods. Either you can use delete 1 for deleting a single document, delete many for deleting multiple documents, or you can use remove method, which has a functionality of both of this. There is an option with remove method just 1. If you make it as true, it is going to delete only one document, or by default it will remove all the matching documents for the query provider. So let's see a practical example to understand how these 3 methods work. For this delete demo, I'll be using MongoBooster and our Northwind database, where I'll be using the customers collection. To start with, I'm going to duplicate this collection so that we can work on a separate copy. Del demo. So I made a duplicate collection from the customers collection. Let me click view documents. So as you can see here, a document has a field by name country. Let us see the unique values present in this field country. So I'll be using distinct db.customers del demo dot distinct. If you see the description or the syntax for distinct, you can easily find that it needs a field that will be the field name. Here it is country.
This must fetch us unique country names. That's good. Among the country names, if you can see here, we have XYZ and ABC. I'm going to use these two values for the delete demo. To start with, I'm going to do a delete 1 on this XYZ. Prior to that, let me search the number of documents with this country name XYZ. So we have 5 items in table view. This is the country name XYZ. We are going to delete 1 first. Again, see the method definition or syntax. So we need a query as a first parameter, and we have optional parameters. We are going to just use the first parameter, the mandatory one, that's a query, and the query is country is XYZ. So this must delete this first record or the first document which has a customer ID ANATR. Let me execute this. So deleted count is 1, and on again finding on this, we must see only 4 records. Yes, we got 4 records. Let us shift to the table view, and the customer ID is gone. This is opposite in case of delete many. It's going to delete all the records which is going to match this particular query. Delete many now. On executing this, we must see 4 matching records. Yes. And on finding, we must not see any records. So all are gone. This is how delete many works. Now let us see the last one in our list, that is a remove method. That's very easy. See the description again, I mean the syntax again. There is an optional field just one, if you can see in the line number 2 of the syntax. So if you are going to specify this as true, it's going to delete only 1 record. If you are going to specify this as false, or if you are not going to specify it, it's going to delete many records. XYZ is gone. So now I'm going to target on ABC. So we have 3 items matching on table view. So these countries are having text as ABC. I'll start with just one first. That's option. Just one is true. And I think this has to be capital letter. Country is ABC. This must delete this customer ID CACTU. Ocean and ranch must exist. Removed is 1. Let me query it again. Table view. It's gone. So we have ocean and ranch. So on deleting this option, just one is true, it's going to remove like delete many, or this query is going to return us empty values. On running this, 2 documents got removed, and on running this find query, we must see only empty. Yes, we got no records found. So this is how delete one, delete many, and remove works. They are very simple. Only thing to remember is that remove as an optional field where you can specify just one as true. If it is specified, it deletes only one record. If you don't specify it, by default it will delete many. We have successfully learned about queries, the different type of queries, interesting operators and useful methods. Now we are going to see about handling arrays. Arrays are integral part of JSON data. They are very crucial and critical data format. They make handling data very easier. And arrays will be covering these topics. These are very simple and very interesting. And you know there are two types of array data. One is a simple one, the other one is a very complex one. To demonstrate the same, I have created a students collection, and you can see here scores is a simplistic form of array, whereas the grades, which is also known as associative array, has a different structure. And also note that we can have arrays within arrays. Handling simplistic array is very easy. It's like other data types, whereas for this there is a little trick is involved. I'll show that now. Currently in this collection I have 3 documents. In JSON view this will be very clear. Now I want to select the document with score 66. In this 3 documents, only the first one is having the score with 66. So I'm going to select that. That's very easy. That's like our regular data types. The field name is scores. Equals 66. That's it. So we must get only one document now. Yes, we got only one document. And in table view, this is the way to select a simple array, whereas for associative array there is a little trick is involved. Among these 3 documents, only one is having a mean with value 99. So to select the same, it has to be like this. You need to select the grades first, then you need to go to the mean. Whereas for scores we selected directly, we just typed scores equal to 66 previously and we got the value. This is the document which got selected previously. Whereas in this case you just need to change the key. So the first one is grades, and IntelliSense works very fine here. So this is how we are going to select grade.mean and then the regular thing $equal, the value is 99. So on clicking run, we must see only one document in the result. Yes, we got the same. Just you need to remember that this key needs to be surrounded with the double quotes, whereas this is optional for other types. But for this, you need to specify grades.mean within double quotes, and then as usual, you need to specify the operator followed by the value. Whereas for a simplistic array, you just need to specify the key value like this. It's going to fetch you the corresponding document. Hope you understood this. Let me move to the next topic now. Now let us see how to add values to an array. We'll be using push, position, each, and add to set. So these 4 we'll be seeing now. They are very simple and interesting. So these are the 3 documents with scores we have. To add a value to this array, you just need to use the update method with the push operator. We'll be doing the same now. Students dot update method. The selection criteria, we don't have anything, so just I need to specify the push operator here. And I'm going to add a value to this one, and do remember that updates only one document unless until it is specified in the option as multi as true. So we are not going to specify the option now. So this update will update the first document. Update the first document. We got the result. Let me query it and see what is the thing happen. So we have successfully got 99 added to the first document, whereas the rest of the documents are not modified. So if you want to add for multiple documents, that's easy. We will follow the same way the update method works. That's the options. Let us specify as multi. True. We'll be seeing 299s in the first document because we are pushing the value, whereas the other documents will have single 99. Let's see the result. So modified is 3. And finding again. So as I mentioned, we got 299s in the first document because we did it twice for that, whereas the other documents also got 99. This is because we have used multi as true. To avoid duplicate values from being pushed into the array, you can easily use add to set. Read the documentation here. Returns the array of unique expression values for each group. So I have used add to set instead of push. So this must not do much difference. Matched 3, but none of them are modified. So if we query it again, we'll be seeing the same results. So assume I want to just change this to a non-existing number, that is 33. Oh, 33 is there already, so let me take it as 37. So this must update all the documents with the scores 37. Yes, you can see here modified because this is unique value. So on running this, you can see 37 in all the documents. We have given multi-true, so it has touched all the documents. If we don't give multi-true, it is going to just modify the first document. So this is how add to set works. So this is for uniqueness. Push is used when uniqueness is not required. So you can keep on adding values to arrays. If you are using push, I have done it many times now, so you can see duplicates here, whereas for add to set it allows only unique values. So that's the purpose of add to set and push. We have seen about push operator and add to set operator in update method. Now let us see two more interesting ones using push, and similarly position is to specify where the values are added in the array. So let us see both of them now. We have used push for adding a single value to the array and it added duplicate values that we know. So now let us see how to use each modifier so that we can add multiple values. To add each modifier to push, we just need to take out this single value and change that to a multiple one. So we have the each operator. I mean the each modifier. can see each described here. Can easily understand the syntax of that. So let me do the same now. Each, and then it's very easy. I'm going to specify here 11, 12 and 13. So this needs to be added to every array. Let's see the added values. So we got 11, 12, 13 added to every array, but this time we got 3 values added. Previously we added only 37 using push operator. Now using each modifier we are able to push in a set of values inside the array. If you notice a thing, you can see here that the values are just appended to the end of the array. So to change the positions of the value added, you can always use the position modifier. That's very easy. Just need to put a comma and specify the position modifier. And this is how the position modifier works. You can see the API sample here. Each is specified followed by the position. Let me execute this. You can see the new set of values 11, 12, 13 added to the position 0. That's the starting position. This is the same case for all the documents, that is because of multi-true. So if you change a position to position number 3 and with different values, 15, 16 and 17, you will see the new values added to a different position. This is the new position of the values. 14, 15, 16 is supposed to be added. That's fine. So this is how the position modifier works. Each modifier is for adding multiple values to the push operator. Just opposite to push, we have pull operator. Pull operator is just opposite to push operator. Push operator is for adding values to an array, whereas pull operator is for removing values. Let me demo the same. This is going to remove 37 from the first array. I haven't gone for the option of multi-true. So this will remove 37 from the first array. Let's see that. So matched and modified is 1. As you can see here, 37 is totally taken off from the first array. This is how pull works. Now let us see about pop. Pop is also used for removing, but it works in a different way. Pop is for removing the first element of the array or the last element of the array. We have seen about pull operator. The next one is pop operator. Pop operator works similar to pull operator. Only difference is it will be able to delete only the first element or the last element of the array. If you specify as -1, it removes the first element, whereas 1, it removes the last element of the array. Let me demo that. In our array, the first element is 11 and the last element is 13. So to remove 11 using pop operator, you just need to specify the value as 1. $pop, you can see here the API description removes the first or last element of an array. So pop in scores array, I want to remove the element, the first position, so that is -1. So modified is 1. So let me select it. So 11 has gone. Again, on executing this, 12 will be removed. Let's see that. So 12 is gone. So if you alter this to 1, it will remove the last element, that is 13. Thirteen is gone. Even if you want to remove the 12 at the end, on executing this again, it's going to remove the 12 value at the end. So 12 is gone. This is how pop works. So we have seen about push, pull, pop, add to set, in, not in, all, and the modifiers, position, each. Now we are going to see about element match operator. This is very simple. This will be used along with find method. This is used for searching an array with element, at least one element that will match the searching criteria provided by the element match. So it will look for the arrays with at least one element that will match the searching criteria provided in the element match. Syntax is very simple. So we'll be having a find query. Under that, we need to specify which is the column we are going to select. I mean the field we are going to select, followed by the element operator. So this is the element match operator. So read the API over here. Selects a document if element in the array field matches all the specified element match conditions. Example is given here. In my case, I'm going to select an element between 40 and 50. So it has to be greater than 40, comma, less than 50. So the brace matches, this one matches, this one matches. I think I have an extra brace over here. Let me take it out. Yes. So we got the result, and I wish to filter using this projection. So I'm going to add this one here. So that I'll be seeing only the arrays. This got selected because we got 44 over here. Whereas for the other documents, let's see what are the array values here. So we don't have anything between 40 to 50 here. Same case here also, we don't have anything between 40 to 50. Only here we have 44. So that's a document we got selected. Have filtered out using the projection specified here. So this is how element match works. Now let us see different operators with arrays. We'll be starting with in, not in, and all. From the name itself, you can understand its functionality. In is for checking inside an array, and this is for opposite to in, that is not in the array, and all is for the complete array checking. I'll be using the same students example so that we can understand the things easily. So let me see only the scores data first, and the ID value is 0. This is our query. So we can see only the scores field listed here. We are going to search in this scores field. Let me copy the same here. We're going to use the in operator first. So using in is as similar to other comparison operators. So you need to specify the key first, scores, and then in operator followed by a square brace. Because we are going to handle with arrays, I'm just going to select this 98 and 36. 98 comma 36. So let me execute this. I must get only this particular document. It's clear now. We got only this document. So let me take out this filtering and show which is the document has appeared. So this is how the in operator works. Not in is just opposite of that. You just need to specify any in over here. So we must get two other documents which don't have this value. So we got the other documents which doesn't have this value. So that is a purpose of not in, whereas in is totally opposite to this. If you want to see the API description, just keep your cursor over here and it displays the details. If you take the in case, there is one thing you need to note about, that is it fetches all the documents which has at least one of these values. So if I specify 66 over here, it must also get this document. So we got two documents, this has 66 and the other two values are present over here. But all works totally different. If you see here, type all and on executing, this must not return any document because all expects all the values needs to be present in a particular array. Whereas in is similar to an OR operator, it checks for any one of the value present in an array. Even if I add here the values which is not present, in will work. So we got the same result, but this is not the case for all. All needs the content to be exactly matching with the array. So for example, let me select this 78, 88 and 66. Oops, here I need to change this all. And clicking run, we got exactly the same array which matches this. Even adding a single value is not going to get you the document, whereas in is totally different, is what we have seen.
Now we are going to see a very interesting one and a very less known one, that is collection validation. So while creating a collection, you can restrict or validate the documents before they get inserted into the collection. So this is a very cool feature and it's a very, very useful one, especially if you're going to deal with transactions. So while creating a collection itself, you can specify the structure and the required fields for a document. So this is a documentation page for create collection method. As you can see here, we have three fields, that is validator, validation level and validation action. So these three are optional. We are going to see how to use them. This is the syntax for the create collection method. We got name and options. And options we are going to see about validations. For validation level, we have three status, that is off, strict, strict is the default one, and moderate. And similarly for validation action, we have error. It will throw an error when you are going to insert a document with a different structure. And similarly we have warn. Assume a special offer in Amazon which is valid to the customers whose total purchases is greater than $10,000 And similarly, the customers have to be from these three countries, that is US, UK, and Brazil. This is the validation we need to do before we insert a document to this collection, that is Amazon special offer customers. So this we are going to implement while we are going to create a collection. So let us see how to do that. I'm going to use a Robo3D client, which is well known as RoboMongo client for this, because they have given a simple wizard to do the same. The step one is to create a collection. I'm going to use a wizard here, right click and create collection. Yes. So on clicking this advanced, you can see a validator tab here. You have two options, that is validation level drop down, and we have validation action drop down. Let me go with the default. So the validation level is going to be strict and the validation action is going to be error. Now we have two conditions, right? So I'll be using the AND operator. The first one is going to be the total purchases has to be greater than or equal to 10,000. So it is the GT operator and 10,000. Done. The second one is the customers from these three countries are eligible, that is US, UK, and Brazil. So I'll be using a in for that. Done successfully. Let me validate this JSON. Yes, it's valid. Now I'm going to save this one. Before saving, let us recollect what we have done. We have created a collection and we have used the wizard which is provided by RoboMongo client. We have given the condition for validation here. We had two conditions, that is the customer's total purchases must be greater than or equal to 10,000, as well as the customers must be from these three countries. So I have used the AND operator, and for this 10,000 I have used greater than equal to. For checking the countries I have used the in operator. So done successfully. Now it's time to test. So let me insert a valid document first. Yes, successfully inserted. Now it's time to check whether it's working fine or not. So for an invalid document, it must throw an error. Yes, as expected, we got document failed validation error. So the document hasn't got inserted. Only the valid ones gets inserted. So if you view the collection, you'll be having only two records which satisfies the validation condition, whereas all other documents have been marked as error. So this is how document validation can be done in a collection.
We are going to see about one of the useful feature as well as widely used feature of MongoDB, that is full text search. Do remember that MongoDB is a document oriented database, so websites or applications for news, listing or blog based systems uses full text search heavily, and similarly analysis systems and reporting systems also use full text search. Without full text search, a similar result can also be obtained using regular expressions in MongoDB or by using like in SQL, but full text search will be very accurate, faster, and has intelligence embedded because there will be a separate engine for processing these full text searches, which uses specific algorithms to get the right results. Some of the features of a full text search engine are listed here. Among this, word breakers or tokenization and stemming are the most important ones. Tokenization is for splitting a text or sentences into meaningful words, whereas stemming, for example, if you are going to search for a word important, the search results will have the word importance also included. And similarly, if you are going to search for queries, the word queries, the search result will have query also included. Ranking, every search result has a score. That's what is referred as ranking. And similarly, stop word skipping is for skipping common words like and, the, etc. Soundex, this feature currently we don't have in MongoDB. This is used for searching related words having similar phonetics. There are many advantages of full text search, especially for searching logs, blogs, and other website text content. There is a well-known disadvantage also because the index size is going to be huge. That is a known factor. That's what a lot of cloud service providers doesn't support full text search. In MongoDB, doing a text search is very easy and simple. The syntax is very clear, as you can see. The first term is the search string. The all other three are optional. The language specification, currently MongoDB supports only 15 languages. I hope later they will add more. Then whether the search is case sensitive or not, and finally whether you want to do a diacritic search or not. The only prerequisite is that we have to create a text index on the field we are going to search. We'll be covering these topics and they are very easy. Let us proceed to the demo now. To demonstrate about full text index, we'll be using a collection by name articles. In that I have created a text index already. I'll be removing that and we'll be seeing what will happen when we don't have a text index. As you can see here, there are two indexes are available on this articles collection. So the first one is a regular one that is on the underscore ID field, and the second one is on the subject text field. So if we query the documents in tabular view, as you can see here, we have 4 fields. One is the ID auto-generated field, subject field, author field, and views field. We are going to do a text search on this field, and I'm going to search on that. Removing an index is very easy. Let me do that. Collections dot remove drop index. The name of the index is subject underscore text. Let me drop that. Let me confirm it by querying again. So we have only one index. There is no text index. Now let us see the syntax for text search. This is the syntax. You just need to specify the search string. And in view documents, let me get the search string for this. So I will be searching for the word coffee. db.articles.find $text search and the search text. So if you do this search on this, you'll be getting an error message. So the error message is text index record for the text query. This is the error message we will be getting if you haven't done a text index, because we dropped the existing text index on this field which I have created already. So creating a text index is very simple. Create a text index here. db.articles.create index we have. You can create multiple index also. I'll be using only one now. And for the field name is subject. And the type of index is text. This must create a text index on this field. The field name is subject, type must be text. So number of indexes before was 1, that was on the ID field, and the number of indexes after is 2. So let me confirm it again by using get indexes. So we got the index on this field. Now let us execute the same query now. So this is the result. This is a text search result. You can see coffee is there, and even the capital letter coffee is also included. So in table view, this will be very clear. Coffee, coffee and cream, and coffee shopping is there. Let us see a cool feature about full text search. In this collection, if you see the documents here, we have in the subject field, we have something called importance in the subject, and similarly we have query in the subject. Let me show how it can be selected in full text search. That's very easy. Articles dot find, it's going to be a text search with the search term search term is going to be, we have seen query, I'm going to give here as queries. Oops, I've forgotten to put a circular bracket. So this is the interesting thing about full text search, that if you search for queries, you'll be getting the result for query. So it automatically finds these two are related and it is listed in the result. And the same thing happens for importance also. Importance. If I search for importance, I'll be getting for importance, but even if I search for important, the search result will have this. So this is the interesting thing about the full text search. It has an algorithm or the database to match words by their relevance. So the next one we are going to see about this one, stop words will be skipped. So in case if I'm going to give the search again with the words and or the result will be same. As you can see here, this and this will get the same result, even with the. So these are the stop words that will be skipped. The next one we are going to see about exclude content in the search text. That's very easy. Similar to Google search, you just need to put a negation mark. So in the above search, if I'm going to mention that I don't want cream in the result, it will list only 2. So that's negation. It's similar to Google search. So this is for negation. Now for multiple search, that's very easy. I wish to have these three words to be listed in the search result. On firing this query, we must see the search result has the new words also included, importance and query. So this is how multiple search works. The next important thing is case sensitive search. That's very easy. As you can see in the syntax, case sensitive search, we just need to specify Boolean value. So we are going to use the same one, but this time this will have a different result, because as you can see here, one of the result is having a capital letter word in the beginning. That's coffee shopping is having a capital letter C in the beginning. So this will get filtered out from the search result if you are going to make a case sensitive search. Let's see that. That's very easy. Case sensitive is true. So the results will be 4 now. As we expected, the result is 4. That's how case sensitive works. Now let us search the exact phrase. Again, this is also very easy. I'm going to take this one. So these are the stop words that will be skipped. The next one, we are going to see about exclude content in the search text. That's very easy. Similar to Google search, you just need to put a negation mark. So in the above search, if I'm going to mention that I don't want cream in the result, it will list only 2. So that's negation. It's similar to Google search. So this is for negation. Now for multiple search, that's very easy. I wish to have these 3 words to be listed in the search result. On firing this query, we must see the search result has the new words also included, importance and query. So this is how multiple search works. The next important thing is case sensitive search. That's very easy. As you can see in the syntax, case sensitive search, we just need to specify Boolean value. So we are going to use the same one, but this time this will have a different result, because as you can see here, one of the result is having a capital letter word in the beginning. That's coffee shopping is having a capital letter C in the beginning. So this will get filtered out from the search result if you are going to make a case sensitive search. Let's see that. That's very easy. Case sensitive is true. So the results will be 4 now. As we expected, the result is 4. That's how case sensitive works. Now let us search the exact phrase. Again, this is also very easy. I'm going to take this one. I'm going to paste this one here. Coffee and cream. But this is not an exact phrase. This will list all the ones with coffee and cream. So to make an exact phrase search, you just need to add this one here as well as at the end. So this will get you the exact phrase like this. So this is how the phrase searching works. The next interesting thing is the diacritic search. If you see the syntax here, there is an option for diacritic sensitive search. So you just need to specify a Boolean value for this. So in our collection data, if you can see here, in this field subject, there are two values, cafe con leche. I think this is in Spanish. Similarly, there is the same text is repeated here, but in this one you can see a diacritic mock over here. That's the apostrophe. So if you make this one diacritic sensitive, it must only fetch exactly the same text if you are going to specify this in the search text. Let us see how this is going to work. Instead of case sensitive, we are going to give diacritic sensitive as true, and here this is going to be this search text. View document. Let me copy this one and paste it here. So we have the apostrophe mock here. On execution, you must see only the exact text searched here. That is because we have specified this as diacritic sensitive. In the previous versions of MongoDB, diacritic sensitive was by default true, but in the later editions they have made this as false. So if you're going to make this one as false, you must see two rows here. I mean two documents selected, because diacritic sensitive is false. So the one without apostrophe mock is also got selected. But when we make this one as true, we must see exactly one document which has a matching apostrophe mock as specified in the search query. The next key thing we'll be learning is about the text score. The text operator automatically assigns scores to each document in the search results based on its relevance. So we're going to display it. For that, we'll be using the meta projection operator. So it's a projection operator, so it comes in the second part of the find query. The syntax is very simple, as you can see here. So let me copy this. This must display the scores associated with the search results. I'm just going to replace this query with a text operator. So this is the one, and the collection name is going to be articles. On execution, we must see the documents listed along with their meta score. I mean the text score. So this is the score for the documents. To sort the results, it's very easy. Just you need to specify the same inside the sort method. think I made a mistake here. Braces is missing. Let me add that. So the documents got ordered by the scope. That's what the sort method does.
So with this, we are successfully finishing about full text search. Now let us move to the next chapter.
JavaScript in MongoDB server. For sure, we all know that MongoDB is JavaScript capable. Though MongoDB has many commands and many inbuilt methods, without you able to create your own JavaScript code that will run on or run against MongoDB, it is like repairing without a toolbox. JavaScript powers anyone who wants to work efficiently with MongoDB. JavaScript's main application in MongoDB is in admin jobs. In addition to that, JavaScript plays a key role in data analysis and manipulation also, so that there is no need for you to pull the entire data to the server side to do analysis. You can directly embed a JavaScript code and run it on the server itself using eval with query. Previously, there was a method by name db.eval which has been deprecated from MongoDB version 3. It was very useful so that you can write your own function within a eval method and execute it against the database. But unlikely this has been deprecated, I hope mainly due to the security reasons. The third feature of JavaScript is that the MongoDB shell is REPL capable. So you can just use like that, like any JavaScript parser. To understand and see how JavaScript is very useful in MongoDB, we'll be using these 6 simple demos. To start with, we'll be using JavaScript in the shell. Then we'll be comparing JavaScript methods with their command equivalents. After that, we'll be doing a simple demo on cursor. Then eval method. Eval is deprecated, but till now it is very useful. Then we have the interesting one, though it is not a recommended practice. We'll be saving the JavaScript itself on the server directly using system.js. Then finally, we'll be seeing how to run an external JS file through the Mongo command line. So these are the 6 simple demos we are going to see now. Let's start with JavaScript in shell. I'll be using RoboMongo. To start with, I'll create a database. JS demo DB, and in this I'm going to create a collection JS. Let me open a shell for this one. We got a shell now. To start with, I'm going to insert some documents with random numbers in that. I can use the JavaScript loop here easily. The shell can be used just like a JavaScript REPL. I'm going to do an insert here, db.collection.js.insert. I'll be selecting a simple document. Let me name the field as a random number, and the value is going to be math.random. I'm going to insert random numbers between 1 to 100. You can easily access JavaScript native functions from here. So to insert, we'll be using *100 plus 1. This will create random numbers from 1 till 100. So you can see here I have used the JavaScript library. Let me execute this. Braces are closed.
On execution, I must see records getting inserted. View the documents in table view. Can see random numbers being inserted in the document. So what we have seen is we have just used JavaScript functions to create this random number. Now let me show how to use a JavaScript variable to filter the same. Filter max equal to 50. I'm going to do a find query to filter all the values whichever is greater than 50. Find the field name is random number. Let me copy this one. Random number greater than 50. Let me cover this with braces. So braces are there everywhere. On execution, we must see only the random numbers with values greater than 50 got listed here. So instead of having this value, you can also use the variable here. That's very easy. The result will be the same. Okay, I haven't executed this one, so I need to execute this so the variable get initialized. Then I'm going to execute this. So we got the same result as that of the previous. You can use JavaScript variable inside your queries easily like this. And similarly, you can access JavaScript functions inside your queries like this. So this shows us how we can use MongoDB shell to use JavaScript. We have seen about JavaScript in shell. Next, we are going to learn about MongoDB JavaScript methods and command relation. For this, you need to visit to this link, that is write scripts for the Mongo shell. This is under the manual. In this page, there is a subtopic differences between interactive and scripted Mongo. Click on this. A table showing the shells with corresponding JavaScript equivalents are listed here. For example, you can use this command show databases in the shell to list all the databases available. Or you can use the JavaScript equivalent like this, db.admin command list databases. This is also going to fetch the same results. Similarly, for collections, you can either use a shell one, that is show collections, or you can use the db.get collection names. This is in JavaScript. And finally, we have cursors. So cursors are generally used along with the find method, which is going to return a set of documents and then you can loop through it. So let us see that. Cursor is a handle or pointer to a set of documents which are returned by a query. For example, if you see the definition for the find method, it returns a cursor to the resultant. A cursor to the documents that match the query criteria. This is the return type of a find method. Using cursor is very, very easy. I'll be using this collection over here. If you view the documents in the collection, these are the documents in table view. It has a field by name random number which has numeric values. So the same using cursor works like this. The return type is a cursor. So the results are saved here. I mean the handle to the results are saved here. The next step is to loop through the cursor. So loop through the cursor. That's easy. We'll be using the while loop here. Cursor has next method. One more thing I have forgotten is in the documentation you can check about the methods available in a cursor. Under reference Mongo shell methods, cursor methods.
you can see the methods available for a cursor. So here the definition for has next is given, returns true if the cursor has documents to be iterated. So that's what we are checking while cursor.hasNext. The next one is the next method, which returns the next document in the cursor. We'll be using both of these methods here. Print JSON cursor return dot next. On running this, we must see the documents in JSON format. We got the result in JSON format. If you want the field value of random number, you can easily do this, and then on executing you will be seeing only the random number values here. One more thing is, I am going to insert the cursor values into a new collection, that is test collection copy. db dot collection days dot insert. Sorry, this is test collection JS. Copy dot insert these values dot next. So on running this, we must see this new collection populated with the same values of this collection. So prior to that, let me show the values in this collection. It's empty. After running this, let me check the collection again. The values got copied to this. Here we used cursors for this. So cursors completely give you control over the return result. You can play with that. Now let us move to the next topic, that is using eval. The next interesting and useful thing is the eval method. The command equivalent for the eval method is the eval command. As you can see here, this is available in the documentation page. It's under query write operation commands eval. Similarly, the JavaScript equivalent for eval is db.eval. The only sad thing about this is it is deprecated since version 3, but it's very useful, very handy. This is the syntax for that. Let us see an example of how to use that db.eval for JavaScript. Let me copy the syntax. So this is the syntax. Let me make a simple method first, add method. I mean the add function, add, which will take two parameters x, y, and it is going to return x plus y. Now the next is the argument. So I have created the function here. Function is here. So the arguments I'm going to specify as 100, 200. Let me execute this. So you can see the warning here, db eval is deprecated, but the result also has appeared. It's 300. This is the syntax of db.eval. A function is taken as a first parameter and the method arguments for this. For a complex example, let me show the values in this document first. In tabular view, it has a random number field with numbers. We are going to use eval to find the sum of all the random numbers here. We'll be using cursor for this. The first step is to have a find one here for this. Let me copy this. The result is going to be saved in a cursor. The next step is to loop the cursor. Create one more variable here. Cursor.next. The column name is random number. I hope, let me cross check it again. Random number, or let me view it. The final step is to return this addition value. So we have a simple eval function, which is a sum which operates on cursor. It has to return the total sum of all the random numbers in the collection. So we got the result, that is 5135. That's the sum of all the random numbers in the collection. This is the use of eval method, but sadly it has been deprecated from version 3. Now let us move to the next topic, that is using system.js. This is also not a recommended practice, but to know that, it is good. Using system.js. So under documentation of MongoDB, if you can navigate to store a JavaScript function on the server, there is a note is given here clearly that do not store application logic in the database. This is mainly due to performance limitations. But in few conditions, we may need to save JavaScript function on the server side. So for this, there is a special collection by name system.js where you can use a save method to save a function like this, where id is the name of the function and value is the function content. Do remember in the previous section we have seen about db.eval, in which we have used a function sum to do a sum of all the random numbers here in this collection. I'm going to use the same, but there is a minor change that this will be saved in a different database. So you need to get the database reference here. db.get siblings. So you can see the method here, db.get sibling db. This will get you the database. So in our case it is JS demo db. JS demo db. Let me copy this one. We got the database, and on this database we are getting a collection, and on the collection we are performing a find, and using cursor we are adding all the random values that is present in the collection. So it will take a sum of all these random values. I'm going to copy this to the db.system.save. db.system.js.save method is the one we are looking at. The first argument is going to be the id for this, and the second one is going to be the method. So for the id, we'll be calling this as sum of random, and the value is going to be the function. We don't need any arguments here. We got id and the value. I just need to close this brace. Yes. So on executing this, expect token in line number 3. Yes, I missed a circular brace here as well as a circular brace here. So now this must work. So a new record has been created. We have a function by name sum of random. If you refer to the documentation, before executing the function, we just need to call the load server scripts. So let me call that one first. The next step is to call the sum of random. On calling this, we got the output. So this is how it works. Let me recollect what we have done now. We have created a function by name sum of random and we have saved in the database using db.system.js.save. In the function, for the value part, we got the reference to the database, then we got the collection, then using cursor we are doing a sum of all the random numbers and returning it. Before calling the function, we have called load server scripts and then we have executed the function which resulted in this output. This is how to save a server-side JavaScript function which is similar to a stored procedure in the SQL world.
GridFS, this is one of the interesting and important feature of MongoDB. Using GridFS, you can save files of size more than 16 MB directly into Mongo database. GridFS is widely popular in saving audio, video file formats, PDF documents, scanned images, etc. Learning GridFS is very simple. You can learn it in less than 10 minutes of time. Companies like McAfee and Pearson are using GridFS in their live environment. For example, McAfee is using GridFS for pushing updates and Pearson is using for saving students' data. As I mentioned earlier, there is a 16 MB file limit for a BSON document, which can be easily overcome by using GridFS. GridFS is similar to blob, that is a binary large objects data type in our traditional database, but the architecture is completely different. GridFS supports partial retrieval as well as distributed storage. We'll be seeing how GridFS works using MongoBooster software. This is very easy and you can learn it in minutes. GridFS is very useful while development and in testing applications. Let us see more details about GridFS. The first step in GridFS is to add a bucket. We'll be using Mongo files command for that. A bucket is nothing but a virtual namespace which in turn has two collections. One is for saving the file chunks, the other one is for saving the file's metadata. So when a file is uploaded or added to a bucket, it will be splitted into file chunks. The file chunks will be of size 255 KB. The details about the file chunks will be kept under a different collection called FS files as metadata. We'll be seeing more details about GridFS in the MongoDB documentation page, and there is a very useful use case documentation is also given in the documentation page. We'll be seeing an overview of that also. This is the GridFS documentation page. The most important thing is when to use GridFS. There are 3 use cases given. GridFS itself acts like a file system. So when your operating system file system has a limit on the number of files listed in a directory, you can use GridFS. And similarly, the most important thing is GridFS supports partial retrieval. And finally, it mentions about the geographical distribution of the data. So these are the 3 main use cases for GridFS. Out of these 3, these 2 are very useful. The next one is about using GridFS. As I mentioned earlier, we'll be using Mongo files command line. And about GridFS collections, we have 2 collections. One is for holding the file chunks and another one is for saving the metadata. Actually, the names might have been better. This one might have been made as meta rather than as files. In the additional resources section in the bottom of the GridFS documentation page, there are two links. These links provide a greater insight and very good use cases for using GridFS. For example, on clicking the first link, that is for building MongoDB applications with binary files using GridFS, part 1. There are three main portions of informations. The first one discusses about the basics of GridFS. Then a short brief about how GridFS is practically used in McAfee and in Pearson is given here in the second portion. The third section discusses about the advantages of using GridFS for a medical system or a healthcare system. In healthcare systems, the patient's records are saved in X-rays or in MRI images. An average healthcare system can have data around 50 to 100 terabytes. The advantages of using GridFS for healthcare system are listed here. The first advantage is about simplified, centralized, and unified interface. The second one discusses about retrieval of the chunks, the files using MongoDB query language. The third one points about high availability of replica sets. The fourth one is about security model, and the fifth one mentions about how to use GridFS system as a replacement for your file system. Because by using GridFS, you can easily overcome the limitations of file systems, such as how many documents can be there in a directory, as well as the strict file naming rules. The part 2 of the article provides us with two very useful informations. The top portion discusses about how GridFS works. This diagram can easily give you a good idea about GridFS. For example, this JPG file gets uploaded to the bucket system of MongoDB using a MongoDB driver, which in turn is saved into two collections, files and chunks. Files will have the metadata about the JPEG file which we have uploaded, and the real data is saved in the chunks. Following this, there is a very useful and practical example of how to save video files and images to a GridFS system. The author of this article has used Perl language for explaining this. Though it is in Perl, it is very easily understandable. This has quite a good information about GridFS. Please go through this as well as the top portion which explains how GridFS works. So totally there are 5 informations we can gather from the part 1 and part 2 of this article. Now we are going to see a simple demo using MongoBooster, which will just take less than 5 minutes, and you can easily understand how GridFS works. We are in MongoBooster now. I'm going to create a separate database for our GridFS demo. Note that in real life scenarios, there is no need of a separate database for GridFS. Create database. Let me name it as a db underscore GridFS underscore 1 underscore demo. So this is our database. It got created. The next step is to add a GridFS bucket. Note that we are not adding a collection. We are going to create a GridFS bucket. Once you click create GridFS bucket, it will be prompted for bucket name. The default name is FS, that you know. I'm going to give a different name here, that is personal videos. On clicking OK, you'll be seeing a personal videos bucket got created. Under that, you can watch there are 2 collections. One is a files collection and another one is a chunks collection. The files collection has metadata about this chunks collection. Under this chunks collections, the real data will be saved.
that we have seen already. So let us see that practically. To start with, I'm going to view the documents under files collection. Right click here, view documents. Initially it has to be empty. It is empty now since it's a fresh bucket. The next step is to add files to the bucket. That's very easy. Click on this plus symbol here. One more thing, there are two options here. Either you can add a file or a folder. I'll be going with files now. I'm uploading a AVI file. Once you have selected the file, you'll be prompted with a confirmation prompt to add with full path or without path. Option without path. Upload started. File got uploaded successfully. The file size is around 24 MB, so it is greater than the 16 MB limit which is imposed by MongoDB. The interesting and the important thing to note here is the chunks. We know that it will be saved in chunks of size 255 KB. Click view documents. So these are the chunks. If you want to see in JSON view, it's running on my PC, so it's taking a long time. This is the JSON view. So binary data is like this, saved in 255 KB. You can also play from here by clicking view file. Since it's a AVI file, I'm saying you can easily play here. So the AVI file got open. This is from MongoDB, not from my local machine.
Oh, hi.
One more thing, let us view the details. That's a metadata, JSON view. Chunk size is given and the file size is given here. Content type. So this demos us how GridFS works. So this data is saved in chunks, whereas the files will have the metadata about that. We have used MongoBooster's tool for this GridFS demo. I'll be showing the same through command line also. In our previous demo, we have seen how easy GridFS is while using MongoBooster. It was just like attaching a file in your email. This section will be seeing about Mongo files command, which is similar to the Mongo dump or the Mongo executable files present in the bin directory of your MongoDB installation. Mongo files command is very simple. As you can see here, it just takes 3 parameters. The first one is options. Here we'll be specifying the database collection host username password. The second one is the commands. This is for the CRUD operation, that is list, put, get and delete will be coming under this command session. And the third one is the file which we are going to act on. So let us see a demo section using Mongo files. I personally don't recommend using Mongo files because it doesn't have the option of creating your own bucket. So by default, it will save in the default bucket name, that is FS. That is the restriction with Mongo files command, which we don't have with the other clients like MongoBooster or MongoCHEF. This is the bin directory of MongoDB. You can see Mongo files under this. It's here. This is along with the MongoDB, Mongo executable files. We are going to use this one, Mongo files, for our GridFS. This is the Mongo files documentation page. The syntax of the command is given here, followed by the options. Various options are listed here. Then the commands. Examples are given. Now let us work with the Mongo files command. Mongo files is the application name. Let me type that here, Mongo files. Then the option D stands for database. Our database name is db gridfs1 underscore demo. db gridfs underscore 1 underscore demo. The operation what we are going to do is put. So put is the command name and then the file name. The file name is Google Drive. So this is the file name. Yeah, that is because of the space here. Successfully added the file. The next step is to list the files present in the grid. So instead of put, we'll be using list command here. Perfectly listed. The issue with Mongo files, as I have said earlier, is that it will be adding the files to the default bucket name, that is fs. Let us cross check the same here. As you can see here, Mongo files command has created a default bucket name, that is fs. There is no option currently available with Mongo files command to create your own bucket name. This shows us how Mongo files command works. We have used the put for adding the file and we have used list for listing the files. There are other commands that you can try by yourself. Basically, this demo is to understand how Mongo files works and what is the limitation of Mongo files. As I mentioned earlier, Mongo files don't have the option to create your own bucket name. For example, we have created the personal videos bucket name by using MongoBooster, but in Mongo files, we don't have that option. We are in one of the important topic of MongoDB, that's aggregation. Next to queries like find, insert, update and delete, aggregation is the most frequently used feature of MongoDB. There are three types of aggregation. Aggregation pipeline, this is the most frequently used recommended way of doing aggregation. The second well-known way is called Mapreduce. This is used in big data systems, as you know. The third one is single purpose operations, which has only three methods, that is count, distinct and group. My personal favorite was Mapreduce, but recent days I started using aggregation pipeline because this one is very less error prone and faster when compared to Mapreduce. But do remember that Mapreduce gives you a complete freedom when compared to aggregation pipeline. Let us see the MongoDB documentation which explains about aggregation. Really, it is one of the very good place to learn about aggregation. They have given a good set of diagrams to explain how aggregation pipeline works, how Mapreduce works. With the diagrams, you can easily understand about aggregation pipeline and Mapreduce. This is the documentation page for aggregation. As you can see here, aggregation pipeline is listed, Mapreduce is listed, single purpose aggregation operations are listed. To start with, let us start with the aggregation pipeline. From the name itself, you can infer that it will have multiple stages. So one of the well-known stages are match, project and group. This diagram can give you a good understanding about aggregation pipeline, how it works. 4 documents are given here, each have the same structure, customer ID, amount and status. In the first stage, they have used match to filter the documents with only status A. So out of 4, 3 documents have status A. So those have been filtered here using the match stage. The next stage is a group stage where the records are grouped based on their customer ID. For instance, in our case, we have 2 customer IDs matching A123, A123. So they are grouped into a single result and the total is calculated using their amount. In our case, it is 500 and 250. So it will be 750. And for the second record, it is a single record. So B212 is placed here with the total amount of 200. So this is the result of this aggregation operation. So from an input of 4 records, we got a result of 2 records or 2 documents. like a match and group stage here. We have around 15 pipeline stages, but we'll be using only 6 of them frequently. We'll be detailing about this 6 and we'll be seeing with examples in the upcoming sessions. Now we have seen about aggregation pipeline. The next one is about Mapreduce. In the same page, Mapreduce is listed. On clicking this, a diagram explaining Mapreduce can be found. Mapreduce is very simple. You may need to write your own JavaScript functions for map and reduce operations. The same data which we have used for the aggregate pipeline is used here, and the steps are explained using Mapreduce. So the first step to filter out the records is called query. The same one what we have used for aggregation pipeline, it's called match, where we have matched the records or the documents with status A. So in this case, this one is done by the query. The query filters the records first. So that's done. The next step is to map using the customer ID. So for that, you have to write your own JavaScript function. So the columns are selected here in map, and in reduce will be summing the amount. The same way we did in the group stage. Group sum we did the same way it has been done. I'll be explaining about this clearly in the upcoming videos, so you can easily master the things. It's very simple. So let me recollect what we have seen. In aggregate, we have many stages, around 15 stages, out of which 6 will be using quite frequently. In the example given here, the match and group stages are used. And in case of Mapreduce, map and reduce are used. In this case, you have to write your own JavaScript function. It's very easy. The result is going to be the same. The final one is a single purpose aggregation operation. It's very simple. It has very limited functionality. As you can see, we have only 3 functions mentioned under this. I mean 3 methods. The first one is count, the second one is group, and the third one is distinct. You can easily understand their meaning from the name itself. Count is for counting the records, group is for grouping the records, distinct is to find the unique values. It is suggested not to use a group which is under single purpose aggregation operation. So if you click on this group method, in the documentation it is highlighted that the group uses JavaScript. It is subject to number of performance limitations. So they have suggested to use a group operator in the aggregation pipeline. So let us start with the single purpose aggregation operations. We won't be covering group initially, we'll cover it later. Initially we'll be seeing about the count method and the distinct method. Then we'll be starting with the pipeline operators. I mean the aggregation pipeline operators. It's very easy and interesting and one of the most essential feature of MongoDB. For the aggregation demo, I'll be creating a separate database. That is db_aggregation demo1. Database is created. The next step is to create collection. The collection name is WebRank. It will have the list of websites and their total visits. The document structure is very simple. As you can see here, it has 3 fields: site, visits, and the category. Site is a site name, visits has a total number of user visits, and category has several categories such as search, video, social, portal, etc. On executing this, we must see a new collection created, that is WebRank, executed successfully. In WebRank, there are around 45 documents. Let us cross-check them. Table view. So we have website name, the number of visits, and category fields. We have the data now. The next step is to learn about the single purpose aggregation operations. Single purpose aggregation operations is simple because it has only three methods: count, distinct, and group. In the MongoDB documentation page for aggregation, as I have mentioned in the previous videos, there is a link for single purpose aggregation operations. On clicking this, you'll be taken to the single purpose aggregation operations document section. As you can see here, single purpose aggregation operations has only three methods: count, group, and distinct. We know about count as we have seen in our previous videos. About distinct is similar to the SQL distinct. It's going to select only the distinct values of a particular field from the set of documents. A simple example through a diagram is explained here. In the orders collection, they have made a distinct for this particular field customer ID. So the result is going to be the distinct values of this customer ID. We have four documents: customer ID A123, customer ID A123, customer ID B212, and customer ID A123. So we have four different documents but with only two distinct values. So on executing the distinct method on this documents or on this collection for this field value customer ID, it's going to return only two customer IDs, that is A123 and B212. Recording the group method, it is not suggested to use a group method. You can see here in the MongoDB documentation, as a group method uses JavaScript, it is subject to number of performance limitations. For most cases, the group operator in the aggregation pipelines provides a suitable alternative with fewer restrictions. So under single purpose aggregation operations, we'll be starting with count and distinct method. Later, after seeing about aggregation pipeline operators, we'll be coming back to this group method of single purpose aggregation operations. So we have three methods: count, distinct, and group. Let me start with count first. db.webrank.count. This is the method. There is an option, as you can see here, query is an option. On running this, we must get the total number of documents under this WebRank. It must be equal to 45. So we got 45 records. The next step is to have a query inside the count method. There are two possible parameters for the count method. It's query and options. Query, as we know, will be filtering the values. For options, we have fields such as a limit, skip, and hint. So let us start with query first. Table view. Let me make table view as a default one. Default view mode as table. So from now onwards, the result will be displayed in table view by default. I'm going to select this category search. This is the beauty of MongoBooster, the IntelliSense. We got 3 as a result. So there are 3 documents with category search. Let me confirm the same using find. Instead of count, it's going to be find. These are the 3 documents with category search. So we have seen about count. The next step is to learn about the distinct method. Rank.distinct. It's going to be the category field. On executing this, we must get the distinct categories in the 45 documents. So these are the distinct categories. So we have around 12 categories. This is how distinct works. Now we have seen about count and distinct method and a single purpose aggregation operations. The next step is to learn about aggregation pipeline. This is very important. And the aggregation pipeline, as I mentioned in my previous video, that there are many pipeline operators. So let us see the key ones. We'll be focusing on these 4 initially. That is a group operator, match operator, sort operator, and limit operator. So these 4 will be using initially under aggregation pipeline. Learning well about aggregation pipeline is very important. So let us see how it works. We'll be using the aggregate method for aggregation in MongoDB. This is the method signature db.collection.aggregate. It takes 2 parameters, pipeline and options. In the pipeline, you'll be specifying the pipeline operators. There are around 16 pipeline operators. Few of them are very important, such as group, match, project, limit, skip, sort, etc. We'll be starting with a group operator first. So group operator. The syntax for using the group operator is somewhat different when compared to your previous MongoDB queries. So you'll be specifying the group operators first, and this field, ID field, is must for a group operator. So it's specified here. The ID field is mandatory. However, you can specify a null value to the ID field. That's different. But this ID field needs to be present for a group operator. Then you need to give the expression. Followed by that, you can specify the field name with the accumulator sets, accumulator with expression. It's very simple to understand about expressions. Let me open the documentation page for expressions. Expressions can include field paths and system variables. To make it simple, just understand this particular section of the documentation. You can access the field names using the dollar symbol before the field name. For example, if the field name is user, you can access the field by using $user for an expression. Similarly, for an embedded document, in case user with name field, you can access that using $user.name, whereas the field path to that is user.name. Let me repeat this. So for instance, if your field name is user, in expression you can use $user to access it, and in the case of an field in an embedded document, for instance for user.name, you can access the field by using $user.name. It's as simple as that. So this expression you'll be using for a group operator. Now let us proceed to MongoBooster. The method name is aggregate, that we have seen db dot.
the collection name is webrank.aggregate method. So we got all the auto suggestions here. We're not going to use this one. In our document, let us do a find to see different document types. .find. We got different categories. To start with, let us count the number of websites under each category. That is very easy. We'll be using the sum for that. Let me show about sum here under group operator. So we know the syntax for the group operator. The first field is ID, expression is required. The second one is field, and you'll be specifying the accumulator with expression. And for accumulator, below are the options. You can use sum, average, first, last, max, min, all those. Initially we'll be using sum. Let me take to the next line so that it will be very clear. $group. The IntelliSense is showing the API of $group. The ID field, that's a must one. I'm going to specify the category. The expression is going to be the category. So $category, you know about this already. We have seen it in the expressions. Then the total number. Total number colon. We are going to use a sum. It's going to be 1. Braces are closed. Here also it's closed. Initially, understanding aggregation will be a bit challenging, but if you start doing samples, you'll be getting used with it. It's very easy and it adds a lot of clarity to your query also. So the grouping field name is total number. That's what the syntax is. This is a field 1. The accumulator we used is sum and the expression is 1. Let me execute this. This is the result. Under search we got 3, under social we got 4, under info we got 9 websites. For example, if you want to check that, you can check this using the find query. Category info, so these are the 9 websites. .count, it must give us a count 9. So the results are matching. Oops. The results are matching. Under info we got 9 websites. Under search we got 3 and social we got 4. This total number is from the sum accumulator operator. We have grouped using category. We have successfully done our first exercise using group operator. The next step is to use the sort operator. That's very easy. Group ends here. I'm going to use a sort operator. Come on. Curly braces. $sort. You can see the syntax of sort here. Sort, the field name and the order by which it is going to be sorted out. If it is -1, it is going to be in descending order. If it is 1, it is going to be in ascending order. I want to do this one in descending order.
on the total number field. Total number, which we have used here, it's going to be descending order, so -1. That's it. On executing this, we must see the results in descending order. Yes, it's successfully done. So we got the top category, that is business, with 11 websites under that, info with 9. So the results are in descending order. If I make this as 1, it's going to be in ascending order. So we got the results listed in ascending order. This is how sort works. So second is done. The next step is to calculate the average number of visits to the website. Instead of sum, I'll be using average. Let me change this into average visits. Average visits. I'm going to use the same here in the sorting, but in descending order. Instead of sum, I'll be using the average operator. You can see how average works here. Next is expression. For expression, I'll be giving the field name. The field is visits. This must give a result of average visits in descending order. On executing this, we got the result ordered in descending order. We got more visits to the category video, then to search, then to social. So this is how average works. The next step is to use a limit operator. That's very easy. $limit. So this is an example for limit. You just need to specify the number of documents required. Let me make it as 5. I think I need to extend this. So we have group, sort and limit. So in the result, instead of 12, we got only 5, which is limited by this limit operator. Similar to limit, you can use a skip operator. That's very easy. Skip. This is the example for skip operator. So it's going to skip the top 5. So we got from news, business. So the top 5 is skipped. The next interesting thing is the match operator. For that, let me open a separate shell. The syntax for match operator is very simple. It's not as complex as that of the group operator. As you can see here, it's match and a matching query. For optimization, it's suggested to use the match as early as possible because match is going to filter the documents based on the queries. So let's see how match works. I'm going to select only the documents with category blog. Match category is going to be blog. So we got all the websites which are under blog category. So this is how match works. Now let me take the top 2 websites which have maximum visits. That can be easily done using the sort operator and the limit operator. I missed a comma here. Sort using visits -1 and the curly brace. Oops. And let me limit the results by 2. $limit 2. So this will give me the top 2 websites with more visits under the blog category. We got WordPress and Blogger. They have the most visits. We used match, sort and limit for this. The next step is going to be very interesting. We'll be mixing both the match operator with the group operator. I'll be doing it in a separate shell. I'm going to filter the category based on the total number of visits. For this, I'm going to use both the group and the match operator. db.webrank.aggregate is a method. Group ID, it's going to be based on the category. This is the expression for that. And then the total visits is the new field. And for total visits, I'm going to use a sum of the visits. The expression is $visits. Now we have done with group. The next step is to filter the total visits by 1 million. For that, I'll be using match total visits. It's going to be greater than 1 million, greater than 1,000 into 1,000. So that's 1 million. Group is done, match is done. So we have listed all the websites with more than 1 million visit. Let me make it as 100 million. So these are the categories with total visits more than 100 million. We have did using match operator and the group operator. It's very easy. With group operator, we have calculated the total number of visits for the ID category. Then using match operator, we use the same field name here to filter out the categories with less than 100 million. So we have only the categories with more than 100 million listed here. So this is how match and group works together. Now let us move to an interesting operator, that is the project operator.
Under aggregation, we have seen about group operator, match operator. We have used limit, skip, sum and average operators. Now we are going to see about project operator. Following that, we'll be again revisiting the important queries. So let us start with the project operator now.
Let me select all the columns using an empty aggregate function. Let us select only 2 columns using project operator. So the result is clear. We have only 2 fields, site and visits. Following that, let me suppress the ID. So now we have clearly 2 fields selected. ID is suppressed. Following that, I'm going to do a substring of sites. So let me select that. So as you can see here, the site field has only 4 characters. That is because of the substring function which we have done over here. Please note that we have 2 site. One is a site variable and another one is a site field. So now we are going to do an aggregate using a group and match. Using a group first, we are going to take the category field and then we are going to calculate the average visits using the average property. So this is using group operator. So let me select this, and on executing this, we're going to see the average visits for every category. Let us find the top 2 categories. So we'll be using ID, visits, sum, and then we'll be limiting by 2. That's because we have top 2 categories for this query. So on executing this, we'll be seeing the top 2 category with most number of visits. So that's business and portal category. In this query, we are going to use the group and match operator. We are going to query based on the ID, and we are going to list the categories which have visits greater than 100 million. So this is a similar one we have seen previously. Now we are going to see the top 2 categories in the blog category. We are going to reverse the sort and then we are going to limit by 2. Let me execute this. On executing this, you can see the sites wordpress.com and blogger.com in the blog category has maximum number of visits. So this query, we are going to project the columns, site, visits and category, and ID is suppressed. We are going to sort by visits in descending order. So this is the result. As you can see here, we have the same fields matching in the result. This is how project works as we have seen it previously. ID is suppressed. The visits is in the descending order. Now we are going to do the same sort using category. So as you can see here, we have a category listed here in ascending order and visits in descending order. This is how project and sort works.
So under aggregation, we have seen about group operator, match operator, project operator, and we have used limit, skip, sum and average operators. With this, we are finishing aggregation section. Let us move to the next topic now. Sharding or horizontal scaling is one of the key features of MongoDB and other NoSQL databases. In this section, we are going to learn about sharding, and I will be showing how to do sharding in simple 6 steps. Though learning sharding may not be important for developers, personally I love it as it is interesting and very simple to do. Sharding architecture is very simple. You can easily understand from this diagram. So we have 3 main components for sharding. The first one is the routers or the Mongos. Then we have a config server. Then we have shards. So shards are for horizontal scaling. So the real data will be in the shards. The routers will be communicating with the application, whereas the data about the shards will be kept in the config server. So the config server holds the metadata, whereas router is for redirecting the queries to the particular shards, and shards hold the real data. So a collection will be partitioned and it will be distributed across the shards using a particular shard key. So we have shard key for partitioning a particular collection and distributing across the shards. So these are the simple 6 steps we'll be seeing in the course to demonstrate about sharding. Prior seeing the demonstration, let me take you to the MongoDB documentation page for sharding. Sharding is clearly explained here. As I mentioned earlier, we have 3 main components: shard, Mongos, and the config servers. So router will redirect the requests to the shards and it will be using the config servers for that. As I mentioned, shard keys will be used for distributing the data. We'll be using the test architecture, which is given under this title, Shared Cluster Test Architecture, under MongoDB documentation. So I'll be using 1 config server, at least 1 shard server. We'll be using 3 shard servers in our case. But for the test architecture, we need 1 config server, 1 or more shards, and 1 router. So we'll be using this test architecture for our demonstration section. Let us proceed to the demonstration now.
For our practice session, I'll be using the test architecture, which is provided in the MongoDB documentation that we have seen previously. This is under Shard Cluster Test Architecture in the MongoDB documentation. We'll be using a single Mongos, that is a router, a single config server, and 3 shards in our case. So a single router, single config server, and 3 shards. So totally 5 servers are involved in our test architecture. Sharding can be done in very simple 6 steps. The prerequisite is that we must have a data directories for the 4 servers. I mean the 3 shard servers and 1 config server. So the step 1 is to create instances of sharding servers which will be listening in different ports. Step 2 is to create config server. Step 3 is to create a query router and link to this config server. If you see our diagram which I have explained previously, the query router gets the data from config server, I mean the metadata from the config server about the data in the shards. So query router collects data from the config server about the shards. Then we'll be using the admin database to add these instances as shard instances, and we'll be enabling sharding on our database and the collection which is involved. Then we'll be using Mongos to insert data. Finally, we'll be validating the data among the shard instances. So the same steps are given in list format here. Create data directories for 3 shard servers and 1 config server. Start the shard servers on different ports. Start the config server. Using Mongos, start the query router for the config server and specify the chunk size. Connect to the router. Use admin database. Add shards. Enable sharding on the database and in collection. Populate the data on the DB. Insert the test data and validate the test data. So the same thing is mentioned here. In simple format, create directories, start sharding servers, start config server, start router server, add shards, enable sharding in the DB and collection. So the preview of the commands which we are going to execute is here. We'll be using mkdir to create directories. Then we'll be using MongoD command to start Mongo instances, I mean the sharding instances in 3 different ports. You can see here. Then we'll be starting this config server. Note that we will be using the same MongoD for the config server also. Just the option is different here and here. Here we mentioned this as shard server. Here we mentioned this as config server. And we'll be giving the DB path for that. The next step is to start the router. Router will be linked with this config server. So you can see the config server port used here, as well as the router will run in an independent port, that is 200,001. We'll be specifying the chunk size, data just chunk size. I'll be explaining this while we are in this step in detail. Then we'll be using the admin database, adding the shards, and we'll be enabling sharding in the database as well as in the collection. And finally, in the database, we'll be inserting the test data. The first step, that is to create the directories. Let me do that one by one. Now we have created the directories. We are going to start the shard servers. Shard servers will be using the directories which we have created previously. As I mentioned earlier, we'll be starting only 2 shards initially. Yes, it has started. It started listening to the port 30,001. Now then, second shard. This will be listening on port 30,002. Waiting for connections on port 30,002. So that's done. The next step is to start the config server in port 40,001 in this directory. Waiting for connections in 40,001. Following the config server, we need to start the query router. Query router will be in port number 40,005. Started. The next step is to connect to the query router using RoboMongo. This is the query router port. We have the configuration database here, and we have the shards collection. Let me query on that. Currently it will be empty because we haven't added any shards there. To add the shards, it's very simple. The steps are given here. Actually, there is one more parameter we can give, that is a name parameter which can be used to identify the shard. Let me provide that. I missed a step because it can run against only the admin DB. I missed this one. Let me open a new shell. Use admin. So switch to DB admin. Let me confirm this again by issuing DB command. Admin database is active. I'm going to execute this add shard commands in the admin database. Successful. We got a reply from the server. Let me confirm it by viewing the documents in the shards collection, which is under config.db. So we got 2 shards. Following this, we are going to enable sharding in the database and the collection involved. Note that this collection and database will be created dynamically. First step is to enable sharding in the database. Done, successful. The next step is to enable sharding in the details collection, where the key field is name. We copy this. Yes, successful. Now we must see a new database here. We got the new database created. Under that, we must have a collection, details collection. Details collection is there. With this, we have done all the configuration steps for the sharding. The next step is to populate test data into the database. Let me do that. On this database, we are under person shard DB. I'm going to insert the test data. It's a simple test data. The collection name is referred here. It's an insert statement where the field name is the shard key. It will insert around 50,000 documents with 3 field names. One is a name, second one is ID, the third one is annual income. The test data is very simple. It will insert into this collection's details collection with 3 fields, name, ID and annual income, whereas the value of I will be from the outer loop. On executing this, it's going to take some time. It must spread the data across 2 shards which we have active now. Insertion is successful. It took some time because I ran it on my local PC. Now to the critical part. We need to see how the data is distributed across the shards. That is very easy. By executing a simple method, you will be able to find how the data is spread across the shards. Collection.get shard distribution. That's it. This simple command is going to give you complete details about the data distribution. So we got 21,000 documents in the first shard and 28,000 documents in the second shard. So the distribution rate is 56 to 43. The next step is to add the third shard. You can even confirm this one by connecting to this shard instance. I'll demo it using RoboMongo. New connection. The port is 30,001. Instead of find, I'm going to give here count. $21,798, and here also it will be 21,798. So the counts of documents are matching. Do remember that we inserted around 50,000 documents. The next step is to add the shard. We'll be starting our third shard here. Prior to that, let me copy this command, paste it. Shard will be running in 30,003. It will be named as shard 3 demo. Just preparing the commands. I'm not going to execute it. Prior executing, I need to start the third shard server. It will be running in port number 30,003. Waiting for connections on port 30,003, so the server is started. Next step is to add the third shard server. Let me confirm the database.
It's admin. Yes, it's done. Let us reconfirm by querying the shards collection. We must see 3. In JSON view. So we got 3 shards. I'm going to insert the test data again. This time it will be from 50,000 to 100,000. Yes. It's going to take some time, maybe around 5 minutes. The insert is over. Now by issuing this simple method, we'll be able to see how the data is split across the servers. We have inserted around 100,000 records, 100,000 documents. We have new documents in the third shard. The percentage of distribution of the data is given here, around 45% on the first server, 14% on the third one, and around 40% on the second one. We have around 13,000 odd documents in the third server. Let me confirm it by connecting RoboMongo to that. %shardDB details collection, view documents. I'm going to count the number of documents here. This count must match. The count is matching with the get shard distribution command. You can also get more details about sharding by connecting to the config database. Let me do it in a separate Mongo instance. Separate RoboMongo instance. So under this collection, if you query in the chunks collection, the key is distributed among the servers. Key is splitted across the servers from min and max. The key value started from 3538 to 41,506. This is in shard 3. Similarly, you can query and find the data in shard 1 also. For example, in shard 1, the min and max values are from 8966 and 9999. This is for a particular chunk. And similarly, you can see the databases that has been sharded under this. And for Mongos, you can get the details about Mongos here. And for shards, you know that you have to query in the shards collection. Created data directories. We started sharding servers in different ports. Then we have started config server on a different port. We have linked the config server with the query router, which we started also in a different port with a predefined chunk size. Later, by connecting to the query router and changing to the admin database, we have executed these commands for adding the shard servers and for enabling sharding in the collection. Do remember that these collections are dynamically created. Then we have populated the %shardDB with test data. Later again we added the third shard and we repeated the same step again.
Replication in MongoDB. This is a very simple and interesting one. You can do a simple replication demo in less than 2 to 3 minutes of your time. Replication is the #1 reason for the uptime of our internet-based web services, either it is YouTube, Yahoo or Gmail. Replication is the #1 reason for their uptime. learning the basics of replication is necessary. Developers may find this topic of replication a bit unnecessary, but my suggestion is just by spending 5 minutes of your time, you can easily understand how replication works in MongoDB. So please just watch a simple demo to understand how replication works. Before starting with our demo, let me take to you the MongoDB replication page where there are 3 simple diagrams so that you can easily understand how replication works. So this is the replication page in the documentation. As you can see here, there are diagrams which explain about how replication works. To start with, let us go to the common architecture. So this is a commonly used architecture for replication where read and writes will be happening to the primary. The dataset will get replicated to the secondaries. Secondaries will be reading the op log to get the dataset from the primary. The next architecture is as similar as the first one, but there will be a heartbeat connection between the secondaries so that the secondaries will get elected. In the third architecture, we'll be using a separate arbiter which will not hold any dataset. Arbiter's purpose is for just voting the primary or secondary. Based on arbiter's vote, the primary or secondary will be selected. So if you read this line, you'll be understanding about the arbiter's function easily. An arbiter will always be an arbiter, whereas primary may step down and become a secondary, and a secondary may become primary during the election. So arbiter's purpose is just to elect the primary or secondary. Let us start with the first architecture where there will be primary and a secondary. Replication is just a very simple 2-step procedure where you'll be starting MongoDB instances belonging to a particular replica set. So this replica set name has to be the same for the MongoDB instances. So assume you have 2 servers running at different ports in a same machine in a different DB paths, but the replica set names has to be the same. In the second step, you will be adding the replica sets using this command, that is rs.add. So let us do the first step, that is to start 2 MongoDB instances with different ports, different DB paths, but with the same replica set name. So there will be 2 MongoDB instances with the same replica set name. So that's a step 1. Prior to that, let me create the data directories. mkdir directory is created. Then to start the MongoDB instance, we know that the default port is 27017. So let me make it as 27020 for the primary. And similarly for the DB path, it is C data or EPL1 DB. That's done. The next one is very important. This is case sensitive. So make sure that you have a capital letter S over here. So dash RPL set. PL set. I'll give an identifier name as REPL1 demo or REPL1 underscore demo. So waiting for connections on port 27020. Primary is started. Let me confirm that using RoboMongo. Connected. It has only the local database. It doesn't have any other thing. The next step is to start the second MongoDB instance, that is for the secondary. First step is to create the data directory for the secondary data. In the one we have used REPL1 underscore DB. Here it will be a REPL2 underscore DB. Data directory is created. Next step is to start the MongoDB process. Port, for the previous one we have used 27020. Let me use 27021 for this. The DB path, here we have the DB path data / REPL 2DB. Then comes the important one, that is a replica set name, REPL set. So do remember that this is a capital letter, S is a capital letter. So if you miss that, this command will show an error. REPL1 underscore demo, REPL underscore 1 underscore demo. So the secondary is also started. It's in port number 27021. So RoboMongo. Prior to that, let me do the second step also, that is to add the secondary to the primary. ors.add host and the port. So we are connected to the primary. Open the shell. Let me do a ors.initiate first. So there is no configuration specified, so it is going to use the default one. You can see in the JSON view. This is very important. My machine name is AMA50 and the port is 27020. This will be using while adding the secondary. Let me check the status. So this one I'll be copying and using. Next step is to add the secondary, because we have already started the secondary in 27021. Successful. Now I am going to create a database and a collection in the primary, and on connecting to the secondary we must see the same database and the collection in the secondary also. So create database, demo replication DB. Database is done. Under collections, create collections, student DB. Oh, it has to be student collection. Collection is done. I'm going to insert some dummy documents. Aldrin, save. So we got one document here, that is with student name Aldrin. The next step is to connect to the secondary. Again, I'll use a RoboMongo. The port is 27021, right? Edit 27021. Connected, save, connect. So as we expected, you can see the collections got replicated. So this is in the second one. You can check the host info by right clicking here, go for host info. It will say which is the machine you have been connected to.
I mean the instance. So we are connected this one to 27021, that is the secondary. Or status. This is important, syncing to the primary server. This is a primary server port, right? And our current one is 27021. This is the primary server port, that is 27020. So this demos us how replication works in MongoDB. Let me insert few more documents in the primary. Insert documents. So the name is Phillips. Refresh. View documents. We got 2. The same one in this. We got 2 here. So this is how replication works. It's very simple, as you have seen. It's just a 2-step procedure. We created 2 instances of MongoDB, but with the same replica set name. Then we added the secondary to the primary. That's it.
Mapreduce. This is an important topic to learn in MongoDB. Though it has been replaced by aggregation, Mapreduce gives you independence so that you can use your own JavaScript function to condense the data. For Mapreduce, we have 2 types of demonstrations. Initially, we'll be using RoboMongo software to demonstrate. Then we'll be using MongoCHEF. MongoCHEF has some inbuilt wizards to ease up the process. So we'll be using both RoboMongo and then MongoCHEF to demonstrate how Mapreduce works. Mapreduce has simple 3 steps: query, map, and reduce. So in the query stage, it will be selecting the related documents, which will be fed to a map stage, where the map will act on each document and it will emit key value pairs. For those keys which has multiple values, the reduce function is applied, which condenses the output to an aggregated data. Generally, aggregation pipeline gives you a better performance when compared to Mapreduce. But as I mentioned earlier, Mapreduce gives you complete independence, so you can play with the data. This is the Mapreduce documentation page in MongoDB. As we have seen this before, we have 2 stages, map and reduce stages, and we have a query and output stage. As the diagram explains here, we have a query stage where we'll be applying a query, which will be given to a map phase where the document is mapped, and then key value pairs are emitted. If it has multiple values, then the reduce will be operating on that to give the desired aggregated value. So this is very simple. Let me recollect again. We'll be applying query first to get set of input documents to the map stage, and the map stage will be acting on the individual document to give key value pairs. If there are multiple values, then reduce operation will be reducing it. So finally, we'll be getting a condensed aggregated data. We'll be using RoboMongo to demonstrate about Mapreduce. Then we'll be using MongoCHEF in our upcoming demo.
For Mapreduce, we'll be using db.collection.mapreduce method. The method syntax is given here. As you can see, the parameters map, reduce, and the optional parameters out and finalize. To understand it simple, have mentioned the steps here. The first step is to query. The second step is to map, where you'll be filtering or sorting the records. The third step is to reduce it, that is to summarize the result which we got from map. The fourth step is to finalize, that is for beautifications. This is an optional field. Initially we won't be using it. And the final one is going to be the out, where we'll be saving the output to a collection or to a file. So this is also an optional field. Let us see how to use Mapreduce method in our MongoDB collection. I'm going to use a collection called students. Let me create that collection first. I'll be using RoboMongo for this demo. The first step is to create a database for Mapreduce demo. Database is there. Next, a collection. I've created a collection. Next step is to insert documents into this collection. I'm going to create a simple document having some students' details. So this is going to be our structure of the documents in our collection. We'll be having student ID field, student name field, total marks, and the year. Our current collection doesn't have any records now. I'm going to insert a set of student records using the insert many method. I think it's in table view. It got inserted. Let me execute the find query again. In table view. From the documents inserted, you can observe that we have data for 3 years, that is 2010, 2011 and 2012. For 4 students, that is Arun, Kamal, Charles and Mary. We are going to use Mapreduce to find their average total marks for this 3 sets of data. I mean for the year 2010, 2011 and 2012. Before proceeding further, let us check the method API. The method takes 2 parameters, I think mandatory parameters, that is map and reduce, and in the optional we have other fields. Map is a JavaScript function, reduce is a JavaScript function. Then we'll be using out for this example. Let us see the description of out. It's a string or document, specify the location of the result of the Mapreduce operation. You can output to your collection, output to your collection with an action, or output inline. So we have 3 different options. Currently we'll be outputting to a collection. So the first step is to create a map function. The second step is to create a reduce function. And the third step is to have a out where the results will be saved. New shell. Create a map function. That's very easy. Map function equal to, it's a JavaScript function. The function is just going to do emit. This refers to the record. We'll be using only 2 columns. One is the student ID and another one is the total marks. The student underscore ID, comma this dot total marks. Let me view this in JSON view to select the exact text. So with map, we have selected the fields which we are going to work on. The second step is to create a reduce function. That's very easy. The reduce function is going to take two parameters which we have selected here. The first one is going to be the student ID and second one is going to be the total marks. In reduce function we are just going to calculate the average, so let us return that. The average of total marks, right? Array dot sum of this total marks in divided by total marks dot length. So we got the sum and the average. So with this we have created our map function and reduce function. Map function selects a field, reduce function reduces it to a single field. The third step is to call the Mapreduce db dot the collection name dot Mapreduce method. We know that the first argument is the map function, the second one is the reduce function, the third one is going to be out the collection name, result underscore map produce. This is very simple. I'm going to execute this one first. Done. This. Done. Now the third one. Let us refresh the collections. We got the result, view documents, in table view. So we got the average value calculated. So f, x, y, z, 1, 2, 3. I changed the map function to use a student name field for result clarity. So got the same result. The next step is to use MongoCHEF instead of RoboMongo. MongoCHEF has inbuilt set of tools for Mapreduce. You can easily learn Mapreduce using MongoCHEF. So we are in MongoCHEF. I'm going to demo how easy it is to do a Mapreduce job using MongoCHEF. So the first step is to create a database. For our demonstration, DemoDB underscore Mapreduce underscore 1. Database is created. The next step is to create a collection with some test data. For this, I'm going to import a JSON file so that it will create a collection. Import collections. Import source files. Add the source file. Customer underscore test data dot JSON is a file. This file has list of orders and customer details. So 8 documents are imported and the collection must be created. Our database name is DemoDB underscore MPRed underscore 1. So under this we must see the collection. Yes, we got the collection, that is customer underscore test data. Let us see the values in the collection. So the document has 5 fields: ID field, customer ID, status, price and items. In JSON view, customer ID field, status field, price and items is a array which has both quantity and price. In the documents, as you can see, the cust ID is repeated. For example, in this case and in this case. We are going to use Mapreduce to calculate the total purchases by each customer. So we'll be using customer ID field and the price field. The next step is to click the Mapreduce in the toolbar. On clicking this, we are presented with a form. the collection on which the Mapreduce is going to work on, that is the customer test data. In the form, you can see many tabs. The first tab is the options tab, which specifies where the output has to be. Under output action, we have 4 options: inline, replace, merge and reduce. We'll be using replace. Replace is for creating a new collection or replacing an existing collection. To see what are the other options, click on this icon: inline, replace, merge and reduce. Replace is what we are going to use. Replaces the contents of the output collection if it exists. If it is not, then it will create a new collection. So I selected the replace option. The next step is to create the output collection. The output collection name is going to be customer reports. The output database is our same database. The next step is to filter the input data. Here you can specify the query. Currently we don't have any query to filter out the data. Let me give a dummy condition: price greater than 0. Price is greater than 0. Next one is map. This is the auto-generated function for map. It emits key and value. In our case, as I discussed previously, we are going to select customer ID and the price field. So instead of key, I'm going to specify this dot customer ID, and for value it is this dot price. Now we have finished map. Let us move to reduce. In the auto-generated code, if you can see here, it takes 2 parameters, key and values, and we have some auto-generated code. I'm not going to use this, so let me take it out. Array dot sum of the values. Values is the price. And we are returning the reduced value. We are just adding all the price and then returning it. Next step is to beautify the output. So for that we have finalize. The first step is to select this checkbox, that is to use finalize. Similar to reduce, finalize takes 2 parameters, key and reduced value. I'm going to replace this one. The customer with ID, key value plus has made a total purchase of this is going to be the reduced value which we got from the reduce method. So we are done with finalize. Global we are not going to use now. Now we are going to run the Mapreduce process. So on clicking this icon here, it's going to run the Mapreduce process. It successfully finished it. So 8 documents. We have 6 results here. As we have seen previously, ACD is repeated twice and UUU123 is repeated twice. So we got 6 results, 6 records. Let us see the collection, refresh all. We got customer reports collection, open collection view. The customer with ID ABC123 has made a total purchase of 25. Our Mapreduce job has successfully added the price for every customer and it has inserted into a separate collection. So using MongoCHEF for MapReduce takes less time. It will add more clarity to your work. So I personally and strongly recommend to use MongoCHEF for your MapReduce operations. We know that Regex has become a core platform feature of any software platform. Using them in database is going to enhance your querying skills and saves you tons and tons of your time. MongoDB team has cleverly and consciously integrated Regex with MongoDB. Regex can be used in MongoDB in two ways. The first one is the simple way, that is, you can have the field name, pattern and options directly like this. There is no need of a regex operator. The second way is to use the regex operator, where you can use in either one of these types. Note that all the four types are for the single purpose. So either you can go with this first format or with the second one or the third one or easily with the fourth one. So there are four ways of doing the same thing. So let us see the documentation of this regex operator to understand it furthermore. This is the documentation page for regex. This is available under evaluation query operators in the MongoDB documentation. Regex is Perl compatible. It's mentioned here in the definition, as you can see. And these are the four different ways you can use regular expression pattern in your queries. Either you can use regex operator or you can use a pattern directly. So there are some restrictions about when to use regex and when to use pattern. We'll see it in the page down. For options, we have four different kinds of options. The first one is I. I stands for case insensitivity. So if we specify I, the search will be case insensitive. M is for multi-line search. X is for extended search. So it will ignore the white spaces and the commenting portions in the regular expression. S is for allowing dot character. So it will match all the characters, including the new line character in the search data. Before seeing regular expression in action, just remember these two ways of using regular expression in your queries. Either you can use the regular expression pattern directly like this, or you can use the regex operator for that. I'll be using MongoDB for this demo. So to start with, I'm going to create a database, regex demo DB. Under this regex demo DB, I'm going to create a collection. The collection name is a demo book. And on executing this insert statement, I must see documents inserted into this collection. Let me refresh this. This is the collection we created. So these are the documents in this collection demo book. And these are all the data of New York Times bestsellers. In the next step, I'm going to search for this particular text using our regular find method. Let me copy this one. And on executing, I must find these two records which exactly matches to the find query. This is our regular search. Now to do the same with regular expression, that's very easy. Just I need to replace this double quotes with a front slash before and after the search text, and there is no need of giving the complete search text because regular expression works similar to our like in SQL search. Now clicking run, the same results are fetched. If you want to check, I'll select both. The down one is the result from the regular expression. So on table view, the results are same. Now to the next step, that is, I'm going to search for the word John. The results are same because we have a John Sanford mentioned in the document. The next step, I'm going to make this John word in uppercase. of course it won't fetch any result because the search is in uppercase. So for this we have an option I to specify the search is in case sensitive. So on placing I after the search text, now we must see the result same as that of the previous one. So results are same. So this is how you are going to add an option for the regular expression search. To do the same with regex operator, it's very easy. You just need to cover this text with a curly brace like this, and then you need to specify regex here. And instead of I like this, we need to specify this as a separate parameter that is called options. So options needs to be specified like this, and it's going to be covered with double quotes. So let me run this one. I got error. I hope I missed a brace. Yes, so curly brace is missing. Let me give that. So we got the same result as that of the previous one. So if you want to specify a regex operator, do remember for the curly brace, it's as similar to all other operators over there. So you need to give the $regex symbol here. Then you need to give the search text. And options can't be given like this directly. You just need to specify a separate options parameter, and then you have to cover the options in quotes. So this is how regex operator works. Seems to be little complicated than our regular expression search using the find method. Now to the next step. One more thing is to note is that even if you replace this front slashes with quotes, the result is going to be the same. Let me select both. And we got the same results as you can see here. In the next step, I'm going to search John or a word girl in the documents. This is very easy. You just need to specify a pipe operator like our programming languages. So the resultant documents have John or a girl. To search for a single letter is very easy. You just need to have like this with the square braces. So this will fetch you the documents with J in them. And similarly, you can also specify the range easily here like this. This will fetch you the documents with letters J, K, L, M. Just remember the square braces here. So this is for searching for a letter range. Like letter range, you can even search for digit range also. That's very easy. You just need to specify the digits between the square braces. The resultant will have digits in that. To search for text that starts with a certain word, it's very easy. Search for starting text. It's very easy. You just need to use a caret symbol, and then you can specify the word. On executing, we will get the result like this because we know that this one is starting with the word what we are expecting, 15 here. To understand better, I'll do it again. So for example, if you want to search for the text which is going to start with a grit, you just need to specify here grit. Do remember the caret symbol over here. So the resultant document has the word grit in the beginning. Similarly, to see the documents which ends with a certain word, that's also very easy. For example, to get this text, we need to specify this field is going to end with the word Kalanidhi. That's similar to the one what we have done previously. We used caret symbol to search for starting with, to search for ending with. You need to specify this. Let me view the document first. The symbol here for this is the dollar symbol. If you specify the dollar symbol, it's going to search inside this field where the text ends with this particular word. We got the search result exactly as we expected. In addition to the caret symbol and the dollar symbol, we have few more symbols. Their meaning needs to be understood. Dot character is used for any character match except new line, and the question mark symbol that matches 0 or 1 times, plus symbol that matches 1 or more times, and the star symbol, which is quite frequently used, matches 0 or more times the search text. So with this we have seen about regular expressions. Now let us move to the next chapter. We are going to see about indexing in MongoDB. Generally, those who have database knowledge before know the importance of indexing. Like relations in traditional database, indexing also plays a key role. In MongoDB, indexing holds a very high value as MongoDB is mostly used in a non-transactional environment. By default, MongoDB generates an index on the ID field of every document in a collection. Let us see indexes in MongoDB in detail. Indexes are primarily for improving the performance of your find queries, but the reverse effect is that it will reduce the performance of your insert and update operations. Without indexes, MongoDB is going to search in all the available documents in that collection. So if you have indexes, the particular field will be cached and kept separately. So the search will be performed on that field only, and it will be very faster since most of the indexes will be loaded to the memory. By default, MongoDB creates an index on the ID field and you can't delete that. This is important to be notified. There are many types of indexes. I have listed few here. The primary one is the single field index. As you can understand from the name itself, it is going to index only a particular field. And the second one is a compound index. It's going to create an index on multiple fields. The third one is a multi-key index. This is for indexing fields with array type. The fourth one is a text indexing. We have seen about this for text search. And the final one is the geospatial indexes. For indexes, it's very simple. You just need to remember these 4 methods. First one is a get indexes, is going to list all the indexes available in your collection. Create index or the ensure index is going to create a new index on a particular field or a group of fields. The third one is drop index or drop indexes. This is for removing the index. And the final one, which the database administrators used to do quite often, that is re-indexing or rebuilding the indexes. So to start with, we are going to see how index is going to improve your performance for a find query. We'll be using get indexes, explain method, create index or ensure index. This is the list of key topics we are going to cover for MongoDB indexing. Initially, we'll be seeing these three. We'll be seeing how to list all the indexes in a collection. Then we'll be searching without indexing, followed by we'll be searching with indexing. Then we'll be comparing the query performance in both cases. So let us start with this three first. For this demonstration, I'm going to use MongoBooster Northwind database. Under Northwind, we have a collection by name orders, which has around 830 documents. So I'll be using that for this. The contents of orders collection is listed here. These are the list of documents present in orders collection. You can see quite a lot of fields over here. To start with, let me check the indexes under this collection orders. That's easy. db.orders.getIndexes. So this method is going to list all the indexes available for this orders collection. Let me execute that. So there is only one field which is indexed, that is the ID field, which is by default is going to be indexed. So there is no additional index on this orders collection. Let me do a find again. Now I'm going to search for a customer ID, that is Vinet. This is in the top of the list. Do remember that this customer ID is not indexed. So the find query is db.orders.find. The field name is customer ID and the value is going to be minute. Let me execute this one. So we have around 5 documents matching it. In the next step, I'm going to measure the query performance of this particular query. That's very easy. Under MongoDB documentation, analyze query performance tutorial is given. So in that, in the beginning, if you can see here, there is a description about the explain method with the argument execution status. This is going to give the statistics of the performance of a query. So I'll be using the same method here on this query. So this must give us the performance details about this query. Let me see the result in JSON. The key thing we have to watch is this one. The total documents examined for this query. It's 830, which is absolutely equal to the total number of documents in the orders collection. This means that MongoDB has scanned all the documents under this collection to find a result for this query. This is a poor performance. This is not appreciable. So let me create an index on this particular field, that is customer ID. So to create index, it's very easy. Just use a create index method. db.orders.createIndex. On this field, customer ID. On executing this, it must create an additional index on this field customer ID. Do remember that we have an index on underscore ID field by default. Let me run this one. So the number of indexes after is 2, before is 1. So our index is successfully created. To cross check this, let me use the getIndexes method again. We have 2 indexes now. In table view, it will be very clear. One is on ID field, the another one is on customer ID field. So now let me do the same execution stats to see how many total documents have been scanned after indexing. In JSON view. So the total documents examined in this case is 5. Do remember that we have only 5 matching documents for this particular query. The query has scanned only those 5 documents which are necessary, not the all 830 documents. So this shows us the importance of indexing We have seen all the 3 items in this list all the indexes in a collection. We used get indexes, then searched without indexing, and we have searched with indexing, and we have seen the performance. Now to check the default ID index and then to drop index. We'll do this two together. We know that MongoDB by default will create an index on the ID field. Let us cross check that. For that, I'm going to create a new collection, test ID index. This is the empty collection. Under that, I'm going to insert a document, a plain simple document with a single field. Now we have a document under this collection. The next step is to find the indexes created. Must be a single index on the ID field. So we have an index by default created by MongoDB on the ID field. So this proves us that MongoDB creates a default ID index on a collection. Now to the next one, to drop the index. You can't drop this ID index. Let us create an index on this name field and then drop that. Creating index syntax, you know already. That's very easy. Create index and then the field name. I hope we got 2 indexes now. Now we got 2 indexes. To drop an index, it's very easy. You just need to do the same. Instead of create index, you have to just give the drop index. So the index was previously 2, now it is 1. Let me cross check it again. We have only one single index now. Drop index worked successfully. We are going to see one of the key thing in database administration job, that is database backup and database restoration. In MongoDB, MongoDump command is for backing up the database in binary format, whereas MongoRestore command is for restoring the binary format back to the server. Bison dump, I'm not comfortable with the name. This has to be called as Bison viewer. This is for viewing the backed up database. So it presents the binary format in human readable format. I mean from Bison format to JSON format. So you can examine the backed up data. The MongoDump command options are very simple. As you can see, you need to provide server details, database name, and of course the output file name. You can even specify a zzip if you want to compress the output file. And also you can specify the collection name or the query so that you can filter out the backed up data. OPlog, this gives you an exact database snapshot. While running MongoDump command, this also records the oplog entries. So later these entries can be restored using MongoRestore command. So you'll get an exact perfect snapshot of MongoDB. And finally, we have noIndexRestore for MongoRestore command. This you can easily understand its meaning from the name itself. This prevents from building the index after restoration. So let us see the documentation first before proceeding to the demo. So let us see the MongoDump documentation. So this is for MongoDump and the synopsis is given clearly. Export of the content of a database. And for oplog, so oplog creates a separate file named oplog.bsn. This is for creating effective point-in-time snapshot and can be restored using MongoRestore oplog replay. Now next to MongoRestore, for MongoRestore command, so writes data from binary database dump created by MongoDump to a MongoDB instance. And for noIndex option, this is the one. So prevents MongoRestore from restoring and building indexes as specified in the corresponding MongoDump output. And finally to Bison dump, this is the Bison dump documentation page. It converts the Bison files into human readable formats including JSON. So this is useful for reading the output files generated by MongoDump. So that's the purpose of BSON dump. We are going to see about MongoDump, MongoRestore and BSON dump in the upcoming demo session. MongoDump and MongoRestore can be easily done through the GUI tools. Just by clicking on the menu item, you'll be prompted with a window with many command options. And similarly for NoSQL Manager also, you just need to click this one and a window appears with all the options. So you can do things graphically easily. We'll be seeing this later. So we'll start with the command prompt first. We'll be demoing MongoDump and MongoRestore using the command prompt first, and then later we'll be doing the same through the GUI tools. In the MongoDump, I'm going to dump this collection which is under Learn MongoDB. So articles collection will be dumped to a file and then will be restored to a different database. So this is what I'm going to do through the command line now. The DB is Learn MongoDB. So --db learn MongoDB, and the collection name is articles. So that's easy. That's just collection articles. Now the output file is going to be out to E drive temp articles collection. So done dumping of this Learn MongoDB articles is the output. 17 documents. So let me check that. Yes, it's 17 documents. Let me view the content also here. This is the one newly created, and you'll be able to see the BSON file under this. This is the metadata file. This BSON file can be easily viewed through BSON dump command. Let me do that. BSON dump, and the path to this file, this one is located. This must show us the JSON content of the BSON file articles.bson. Yes, this is the content shown. So let me verify the content here also. Contents are similar here. Through BSON dump, we were able to verify or see the contents in the packed up articles.bson file. Now the next step is going to be MongoRestore. I'm going to restore this articles.bson to a new database. I need to change to the path where the backup has been taken. So I have changed to the path. So now my path is eTemp articles collection. Next, I have to run the MongoRestore utility. I haven't set in the class path. So I'll be using the complete path to run the MongoRestore utility. Let me copy this one. MongoRestore. Now I have the option from which database to which database. The database is Learn MongoDB. I'm going to make it as 2 and the source is Learn MongoDB. Oops, I just need to cover this within quotes. This is because we have a space between program and files path. So as you can see here, building a list of collections to restore from Learn MongoDB directory, reading the metadata, and then it has successfully restored to MongoDB2. This is a new database which it has been dynamically created using MongoRestore command. So 17 documents. Let me check this through the GUI. In the GUI tool, a new database is created and the count in the collection is matching with the command line option. As you can see here, 17 documents. Here also we have 17 documents. So Mongo restore has happened successfully. In the next step, we are going to use NoSQL Manager tool to do the Mongo dump and Mongo restore activity. So we'll be using these two icons here in the NoSQL Manager tool. I'm an NoSQL Manager for MongoDB. So the first step is to do the Mongo dump utility. So I'll click this icon. On clicking this, you can see here articles collection is selected already. And you need to specify the output directory. I'll specify as original. This DB path option is no longer valid. Similarly, directory DB option is also removed from latest versions. To run a repair, you can have a repair option. This will write only the valid data to the output and force MongoDB to scan data store directly. This is usable when you are going to have your customized ID rather than the auto-generated ID. The final option is DB dump users and roles. We don't have anything here. So I'll be just going with only output directory mentioned, and on clicking the run tool icon here, we must see the articles got dumped to this path. So let me open this one to verify the same. I got the articles.bson backup of this articles collection here. The next step is to use a Mongo restore utility. Doing a Mongo restore is very easy. Just you need to click this icon which is next to the Mongo dump utility. On clicking this, you'll be seeing the options here. The first one is the path to the database dump. You need to specify the entire path till the bson file. So in my case, it's articles.bson, so I have specified it. As I mentioned earlier, DB path option is no more valid. I have to specify the database name here. I'm going to create a new one. I'll be giving a new name here. Resto _ NoSQL dump. This option obj check is by default checked. This will prevent inserting invalid documents while we are doing Mongo restore. No index restore. This prevents creating indexes or building indexes while we are doing Mongo restore. This filter JSON option is no more valid in the newer editions of MongoDB. And on finally clicking the run tool here, we must see a new database created with the articles.bson content. Let me do that now. So we got the new database with articles. Let me double click this to open. And under data section, I'll be able to check whether the number of documents restored are 17. Yes, it's 17. So we have successfully used the restore tool in NoSQL Manager to restore the dumped data which we have done through Mongo dump tool here. With this, we have successfully done Mongo dump and Mongo restore using command line option previously like this, and by using NoSQL Manager. It's similar with MongoBooster also. It's also wizard based. So on clicking Mongo restore in the menu option, we'll be getting almost a similar form where you need to specify the path or the bson file for restoring. Let me move to the next section now. We have successfully finished with Mongo dump and Mongo restore. We are going to see one of the reasons why MongoDB is so successful and interesting, because they have customized their product based on the requirements. In addition to the regular collection, they have added two more type of collections. One is limited by size and another one is limited by time. We are going to see about the one which is limited by size, that is called capped collections. These are designed for high throughput. So let us see more details about this interesting capped collections. As I have mentioned earlier, capped collections or fixed size collections. So while creating the collection, you'll be specifying the size, and also note that there is an optional parameter where you can specify the maximum number of documents that can present in that collection. So this is the syntax for creating a capped collection. It's as similar to the regular collection. The difference are these three parameters. The first one is you need to specify capped as true. The second one is you need to specify the size. The third one is optional one, where you can specify the maximum number of documents that can be present in that capped collection. You can easily convert an existing collection to a capped collection. One more interesting thing about capped collection is that it maintains the insertion order. So when it reaches the data cap, I mean the maximum size allowed, the old documents will be removed and the new documents will be inserted. Since it maintains the insertion order, there is no query index is present, and thus it has a high throughput. So they are mainly used for logging and in caching data. Irrespective of these advantages, there are a few disadvantages also. You can't delete documents, you have to drop the entire collection. And similarly, when you want to update a capped collection, you need to create a separate index for that. And finally, we don't have sharding support for capped collection. This is one of the important things. So you need to handle your data carefully. Now let us see a demo session to understand it very clearly. So let me demonstrate about capped collection using RoboMongo software. It's very easy. So the first step, I'm going to create a database for this. Capped demo DB. I'm going to create two collections here. One will be capped, the other one will be uncapped, I mean the regular collection. So that we'll be learning the differences quite easily. Let me open the shell first. Create a regular collection. That's easy. You know that a db dot create collection, and just you need to give the name of the collection. This is a regular collection. I just named as regular. Successfully created. The second one is going to be the capped collection. It's capped. The only difference is the arguments we are going to pass in the option field. Syntax is this. You need to specify capped as true. Size you need to specify, and optionally you can specify the maximum number of documents. So the first thing is capped is true. Second one, then the next option is size. Let me specify as 1024. And finally, max documents, I'm going to specify as 5. Created. And these are the two collections we got. Now I'm going to populate values into these collections using a simple for loop. The documents are going to be very simple. So for I less than 100, I plus plus. Here I'm going to insert it. Collection name is capped dot insert. The document format is going to be simple so that understanding will be easier. A name is X plus I, and the age is I plus 10. On executing, oops, I missed a brace here. Let me execute it again. So we got records inserted. Let me do the same with the non-capped one. That's a regular collection. Inserted successfully. Let's view the contents. This is the specialty of capped collection. There will be only 5 documents irrespective of the insert count. Only 5 we got. If you see in table view, it will be very clear. In the capped collection result, you need to observe 2 things. One is we have only 5 documents. That is because we have restricted the max number of documents to 5, as well as all the old documents got replaced by the new ones. That's what we have specified as FIFO, first in first out. So whichever got inserted first got removed first. Let us check the regular collection now, because we have inserted 100 into regular collection also. We got many documents. Let me do a count of this to confirm the same. It's 100. We inserted 100, we got 100. But in case of capped collection, though we have inserted 100, we got only 5. So this demos us how capped collection works. The next key topic is we need to see how deletion happens in a capped collection and in a regular collection, because we can't delete documents in a capped collection. So let's check that. db.capped.delete. I'm going to take the name from this, copy value. And similarly, let me make a find command after that to check the same. I executed this, and on finding there is no deletion happened, and you can see the values here. So the result remains the same. But in case of the regular collection, it will be different. First, let me select that. So the value is there. This is in regular collection. Now I'm going to delete this. Done. And on selecting, there is no records. So this is how the regular collection works. Delete is easy. You can do that. But in capped collection, you can't delete. And if you need to delete it, you need to just drop this collection. So this is one of the main difference between capped collection and the regular collection.
Since MongoDB is schemaless, there is always a design decision needs to be made either to go with embedded documents for your data structure or for related documents. In case of embedded documents, we'll be having a main document under which the subdocument content will be embedded inside. For related documents, it's totally different. We'll be having different documents. They can reside either in the same collection or in a different collection like this. But all these documents will be related by using a key, like our relational databases. For a simpler data structure, embedded documents are preferred, and for complex one and for large data sets, related documents are preferred for manageability. There are many blog posts recording this decision, either to go for embedded documents or related documents. This post under blog.mongodb.org explains you the 6 rules of thumb for MongoDB schema design as very good information. This is from the lead technical support engineer. The other blog is this one, that is under openmind.net, which has a very good presentation which can help you in deciding either to go for embedded documents or for relational documents. The conclusion is that when your document structure is going to be smaller or very fewer, go for embedded documents. For other case, you can go for the related documents. We are going to focus about embedded documents in this section. For our demonstration, I'm going to create a separate collection. operating systems. Under this, I'm going to insert multiple documents. The first one is OS, or it will be the ID column. ID is 100, yay, and the version is XP. The year of release is 1998. Done. I'm going to insert 3 more values. This one will be B and this one will be C. The next one is Vista. I think the year is 2007. This one is 2009. That is 7. Done. So we got 3 different documents. Now the main document. These are the related documents. Now the main document will have this ID related to them. So let me have one more insert. Take out this. OS, Windows, company is Microsoft, versions. Here we are going to give the ID of these documents. Done. So view documents. In JSON view. As you can see here, the documents are related using their ID number in the main document. For embedded documents, this will be different. These document contents will be directly embedded inside the main document. Let us see that. So the content is going to be the same. I'm going to create a new document just to demonstrate how embedded documents work. ID needs to be different. So for embedded documents, we don't need any ID. This is going to be Vista. Here is 2007, 2009. There is 7. Inserted. View documents. Then view in JSON view. As you can see the document structure here, this is the difference between the related documents and the embedded documents. Embedded documents, we have embedded the contents directly here, but for us, for related documents, we'll be having a ID field which is referring to the related documents. These related documents can be present in the same collection like we did, or in a different collection. So this is the main difference between embedded and related documents. For embedded documents, we have the content embedded inside the main document itself. One of the coolest, simplest and very useful feature of MongoDB is TTL indexes. TTL stands for time to live.
So when a collection has TTL indexes, all the documents will be automatically removed after certain seconds. This TTL index feature shows how flexible MongoDB is when compared to the traditional databases like SQL Server or Oracle. Though there are many use cases for this TTL indexes like session, cache, log management. We use TTL indexes for log management in our company. We have around 6 different types of collections with TTL indexes. The syntax for TTL indexes is very simple. You just need to specify the field name and the expiry after seconds. So just note that this is not milliseconds, it's in seconds. You can't use compound indexes on TTL indexes. You can't use TTL indexes on capped collections because you know that capped collections can't be deleted until all the documents are removed. And you can't use TTL indexes on ID field.
Now let us see a simple, easy demo using TTL indexes in MongoDB. To demonstrate, I'm going to create an index under log events collection on the field created at, which is going to expire after 100 seconds, which is roughly equal to 1.5 minutes. I'm going to insert test data. So let me do the first step first. On executing this, as you can see here, it has created a collection, number of indexes before is 1 and after is 2. Now I'm going to insert test data into that. I'm going to execute this multiple times so that we get a lot of data in the collection. Refresh it. View documents. As you can see here, we have multiple data under the collection log events, which is going to expire after 100 seconds. So let me check it. It is there. Yeah, now it has gone. As you can see here, there are 0 records and the time is 12:10 now. We started at 12:08. Let me recollect what we have done. We have created index and we have set expire after seconds to 100 and then we did a find. So after the seconds expired, the data has gone. So this is how TTL index works. It's very easy, but very useful.
In MongoDB, we have 2 methods, save and insert, almost doing the same, but there is a little difference in both of them. So that's what we are going to see here. When you are going to use save, it will do upsert, means if the document is not found, it's going to create a new document. If the document is pre-existing, it's going to update or replace the document. This is where insert differs. Insert, if it finds ID predefined there, it's going to throw error that this particular ID already exists, or else it is going to insert a new document. This is how save and insert works and differs. Let's see practically to understand their differences. I'm in MongoBooster. I'll be using this product DB. Collection name is call_products for this save and insert demo. As you can see here, there are 4 documents in this collection. I'm going to start with insert first. I'm going to insert a pre-existing ID. View document. db.callProducts.insert. This is the document. The value is already present here, so we must get a duplication error. As we expected, we got a duplicate key error. I'm going to do the same using save method. And one more small change I'm going to do is, instead of 999, I'm going to make it as 1, 2, 3, 4, 5. On executing save with a duplicate key here, it will update the document successfully. Matched, modified. Let me find it again. in table view. So we got the document whose value is updated. This is the main difference between the insert and the save method. Insert doesn't allow duplicate keys, whereas save overwrites it. So it has overwritten this document. To make this insert successful, you know that either you can remove this ID field so that MongoDB will auto-generate, or you can give your own ID field. So in my case, I'm going to give my own. It's 88. And then executing this will make this successful. Inserted is 1. In table view, let me find it before that. So in table view, the insert is successful. Save does the same when you're going to take off the ID field or you're going to give a new ID field. In this case, I'm just taking off the ID field. And this value I'm going to change as 555. And on executing, save will also insert a new record. Table view, we got a new record like that of the insert. The only difference is whenever a duplicate key is found, insert stops executing, whereas save updates the document. That is the main difference. That's what we have discussed previously here.
We are going to see how to use Java with MongoDB. It's very easy and simple because the API is very clean. It must not take more than 15 minutes for a Java developer with MongoDB experience to get things done with MongoDB. The setup process is very easy when compared to other languages such as PHP, C# and Node.js. The API is very clean and very simple, as I mentioned earlier. The important point to note is that the version 3.x that we'll be using has a different API when compared to the previous versions, that is 2.x. We'll be using the latest version, that is 3.3, to demonstrate the features of the MongoDB Java driver. These are the 5 steps you need to do in your MongoDB project using Java. The first step is to create a Maven project using Eclipse. The second step is to install the MongoDB driver using Maven's pom.xml file. In the step 3, you'll be making a database connection. Then you'll be connecting to a database and to a collection in that database. After connecting to a database and then to a collection, we'll be doing actions such as projection, CRUD, GridFS, etc. And finally, the important step is to close the connection which you have opened in step number 3. So don't forget to close the connection. These are the key classes and methods we'll be using. From the name itself, you can understand their functionality. For instance, Mongo client represents the client which you are going to connect. Mongo database, Mongo credential, Mongo collection. Document has a different name. It is not Mongo document, it is just document. And Mongo cursor is used for looping through the records. There is an important package called model. Under this, we have key classes such as filters, sorts, projections, and aggregates. These classes provides beautiful static methods which can be used in your code. In the Mongo collection class, we have key methods such as delete many, update many, bulk write, etc. So this class, that is Mongo collection, plays an important role in your coding. Then we have 2 other important packages, that is GridFS and then async. GridFS is used for GridFS functionality and async is for asynchronous operation using the MongoDB driver. In our Java demonstration, we'll be doing the following steps. The first one is we'll be listing databases, then we'll be listing collections and its contents. In the third step, we'll be creating a new collection, inserting a single record, multiple record, finding records with query. We'll be sorting the records, we'll be filtering it, and we'll be using projections to filter the column selected. And similarly, we'll be using update, delete many, drop collection, and drop database. These 3 are very important, that is bulk write, This you'll be using quite often. Run command, this is a simple method but very powerful. It allows you to execute the MongoDB command against the database easily. GridFS, for GridFS we'll be uploading a video or image to a MongoDB collection using Java MongoDB driver. Before proceeding with the lab session, let us see the MongoDB documentation page for the Java driver. This is the documentation page for the Java driver, and you can see here various versions are listed. To install, we need to add this dependency to the POM file of Maven. Let us see the reference for the release 3.3.0. Under this reference, click on the MongoDB driver link and you can see here get started. On clicking this, it has 3 sections under this: installation, quick tour and admin quick tour. On clicking installation, it mentions about the dependency that needs to be added to the pom.xml file. The quick tour is important and very clearly organized. How to make a connection is explained here using the Mongo client class. To insert a document, the steps are mentioned here, and similarly to add multiple documents, the steps are mentioned. For querying a collection, how to use a find method is mentioned here, and similarly to find all the documents in a collection, we'll be using the cursor, Mongo cursor, and that's also mentioned in the quick tour session. And finally, it mentions about the bulk operations. In the admin quick tour session, it explains about the admin activities, that is how to list the database, how to drop a database, drop a collection, create an index. All those admin related activities are clearly mentioned with a sample. The important one among this is run command method, which is in the bottom of the admin quick tour session. It helps you to run any command against MongoDB. On clicking this link command, it takes you to the MongoDB commands list. This link has a problem because, as you can see here, there is a double front slash. On removing this, you must be able to see the available commands for the MongoDB. These are the commands you can run through the run command function mentioned here. Now let us start with the Eclipse. The first step is to create a Maven project. Let me create some dummy artifact and group IDs. So we got the Maven project created. The next step is to add the dependency. This is the pom.xml. Under installation section, let me copy the dependency part and paste in my pom.xml. On clicking save, you can see here the workspace is building. Under Maven dependencies, you can see here we have MongoDB driver, bison jar file which is required, and the driver core. So these are the 3 new jar files which has been added. Now let us start with the demonstration list. The first one is to list the databases available in the Mongo server. Step 1 is to get the connection. Oops. We'll be using Mongo client class for this.
Here you can mention the server address and the port, or you can go with the default option. In our case it is 127.0.0.1 and the default port is 27017. We got the connection. Step 2 is to list the databases. Client dot list database names. As you can see here, it returns a Mongo iterable class. So let me do that here. It's going to give me the database names, Mongo iterable. The result is going to be string. The next step is to loop through this Mongo iterable interface. If you see the documentation for a Mongo iterable interface, it's given here, and under this interface there is a method for each which will loop through the contents, which in turn uses a block class. This block interface, if you can see here, used for some logic against the given parameter. We are going to use this one and we are going to override this apply method of block. Back to our code. We are going to iterate through this using the for each. It's going to be new block, string class, and then this. System out, the string here. The string here is going to be the DB name. On running this, we got 3 databases listed: DB demo, demo, and local. Let me cross check using MongoBooster here. It's the same. You can see here DB demo database is there, demo is there, local is here. One more important thing I missed is to close the connection. So I need to close it after using this one. Connection is closed. Now we are done with the first one, that is to list all the available databases. The next step is to list the collections and its contents. The next step is to list all the contents in a collection. That's easy. We need to get the database first. DB equal to the client dot get database. The database name is DB underscore demo. Now we have to get the Mongo collection. The collection name is tbl underscore login. Let me cross verify the same. DB demo tbl underscore login. It has around 40 documents. Now we'll be using the same iterator to loop through this collection. Mongo iterable
it's going to be a document. Collection is equal to collection dot find next step is similar to the previous one which we have done. Instead of string, it's going to be the document because we are looping through a collection. And then here also doc contents. I'm going to print the doc contents to JSON. This is because of this. What we have done is we got the database first, then we got the collection from the database. We created an iterator, then we are looping through the iterator to print the document contents. Let me run this. So we got the document contents listed. The next one in the list is to create a new collection. That's very easy. So on the same code, I'm going to create a collection. db dot. It's create collection. Collections underscore user details. It's returning void. On running this, we must see the new collection created. So we got the collection without any document in that. The next one in the list is to insert single and insert many. Let me create a new Java class for this. Demo inserts. The preliminary steps are same. That is to connect using Mongo client. And then get a handle to the database and then get the collection. So instead of this TBL login collection, we'll be using the user details collection, COLS user details. To insert, we need to create a new document. That's very easy. Document. Append string and object value is there. Username, admin, and then one more append to give the password. Admin 1, 2, 3. So we have created a new document. This document needs to be inserted. That's very easy. Collection dot insert 1 and the doc name. And finally, we need to close the connection. Let's run the program. Refresh here. We got one document. Right click view documents. Admin 1, 2, 3. So we inserted the same. Username is admin and the password is admin 1, 2, 3. Username, password. If you want to see it, you can see it in JSON view. Now let me create multiple documents and do a multiple insert. That's the next step. Insert many. The next step is to insert many documents. So for this, I'm going to create an array list of documents. Now to this, I'm going to add multiple documents. Document 1, document 2. This is going to be admin 1, admin 2, admin 3. Let's go 1. Let's go 3. Here we are going to use insert many, and then we are going to give this list of documents to the insert many function. I mean insert many method. On running this, we must see these 3 new documents added to the existing list of 1. It's done. Let me click view documents. So we got 3 more added to the existing one. So we got 4 documents. These 3 are from the insert many. It's very simple and the API is very clear. Now let us proceed to the next one in the list. That is to use find and to do find with query. We have seen about insert and insert many. The next step, we are going to learn about filtering, sorting and projections using the find. So let me create a class demo find. And for this class, I'll be using the same connection properties and the same collection. So I'll be copying this code block from here to here. The next step is to loop through this collection and then print all the documents. For that, we have the find method of collection.find. Just note that find method returns a find iterable interface. The result is going to be the document. The next step is to loop through this iterator to print all those. So that's very easy. We'll be using the for each method of that. It has to be a block type.
this is going to be of a document. We need to override the methods, add implemented methods, and then in the body of the method I'm just going to print the document in JSON format. On running this, we must see all the documents in the collection. So we got all. So let me move this to a separate block, separate code session. There's a print block. And I'm just going to use this here. On running this, we must get the same result. Now the code is readable. In the next step, we are going to see how to sort the documents. For that, as I mentioned earlier, we'll be using the model package com.mongodb.client.model. Under this, we'll be using the sorts class. For sorting the result, I'll be using the sorts and then the sorts class. Under this, we have ascending and descending. I'll be using the descending, and the field name is going to be username. On running this, the result is in descending order. So this is how sorts works. Descending is a static method. So as you know that, we can do an import static. Sorts.stop. We can take it out. The code is now readable. The next step, we are going to see how to filter the result. I'm going to use the equals method that is available under filter class. So the same, instead of sorts, I'll be using filters. Filters dot equal. The field name is username, and the value is going to be admin3. Filters can be removed because it's a static import. That's done. On running this, you must see a single result because admin3 we have filtered. You can also do an AND condition here. I'm going to do a not equal to. That is NE. Here also NE. That's not equal to 1 and not equal to admin3. So we'll be getting the other two. Admin and admin2. I have used the AND condition and I'm using two filters, that is not equal to, not equal to. So as we expected, admin and admin2 is listed. It is in reverse order because we have sorted the result. So this is how filters and sorts work. It's very, very easy to do that. Now let us see how to do projections.
We have seen how easy it is to do sorting and filtering using the driver. Now let us see about how to do projections. Projections are used for listing only the required fields and leaving out the other ones, similar to the select star in our regular SQL query, where we'll be selecting the columns necessary and filtering out the unnecessary ones. For that, similar to filters and sorts, we have projections under model package. So this is the one. A static import has been made on projections class. So let me do the projections here. Dot projections. We have include and exclude method in projections. So include the field names. In my case, I'm going to include the username only, and I'm going to exclude the ID column. I mean the ID field. So that's it. Now let us run the program. As you can see here, we got only the password and the username field listed here, whereas the ID is filtered. What we have done is we have used the projection method, and then we have used the include and exclude from the projections class. You can even exclude ID using the exclude ID method, and you can add additional columns here like this, password. So the result will be the same. So this is how projection works. In our listing, we have seen about sort, filters, and projections. Now to the next one, that is update. After update, we'll be seeing about run command and GridFS, and finally we'll be seeing about bulk write. So let us proceed with update. I'm going to do it here itself rather than going for a separate class for update, because it's very, very simple. So collection dot update one will be doing first, then we'll be going for update many. The first one we need to filter. I'm going to change the password of this one, where the username is admin. Update where the username is admin, and I'm going to set the value of password as admin 0. And set the password. The set method is available under model.updates class. So updates.star like this. Update is going to happen for a document with username as admin, and we are going to change the password to admin 0. Done. Let's check here. They have successfully changed the password to admin 0. The next step is to demo multiple updates, that is updates many. So instead of update 1, it's going to be update many, and instead of equal, I'm going to take as greater than the ID field is greater than 0, or I'll take not equal to 0. I'm going to introduce a new column, user ID. Instead of set, I'm going to increment here, user ID as 1. So let's see what's happening. Again here in table format. So we got the user ID. This is the functionality of update many. Previously we did with update 1. Now update many is done. The next items in our list are bulk write, run command, and GridFS. Before seeing these three, let us see the delete and delete many, and drop collection and the drop database. Because these four are easy when compared to this one. Now to delete. Delete is similar to the insert. So collection dot delete one. I'm going to use the same. So this is going to delete when the username is going to be admin. Prior to that, let me check the current documents here. So this must get deleted. So that's gone. Next is delete many. That's very similar to the delete one. Open to your code format. Prior to this, I'm going to insert some values into the collection. I mean some documents into the collection. db dot call user details dot insert username, it's going to be admin, come on, password is going to be adminx. I'm running it many times so that I'll be getting quite some records. To do delete many, in table view, 1 2 3 4 5 6, so 6 records I got with the username admin. So on using delete many here, it must delete all the usernames with admin. Prior to that, let me show delete one first. Delete one will delete only the first matching document. So we got 5. Initially we got 6. Now we have 5. So delete one deletes only one, whereas delete many, it's going to wipe out all the documents matching this criteria. So this is how delete many works. So we have seen about update one, update many, delete one, and delete many. Note that for update we have used set and inc method. These methods are from the updates class, which is available under this model. It's a static import. So we have seen delete many. Now to see drop collection and drop database, let me create a temporary database. I don't want to touch this one. Test DB is a database name, and under this I'm going to create a collection, demo users. So collection is done. Under this collection, I'm just going to insert some dummy data. So under this collection, we have around 5 records. We are going to drop the collection first, then we'll be doing a drop database. So let me create a new class for this. Drop a demo. I'll be using some code from the existing ones. The database here is different, that is temp_test_db, temp_test_db, and the collection is going to be demo_users. We're just going to drop this collection.drop. So this must take off the collection. Let's refresh here. Collection is gone. We have called the drop method. Now let us drop the database because collection is no more. Drop. This must take out the database. So database is gone. We just called the drop method in the DB, and similarly we have called the drop method in the collection. We have seen delete many, drop collection and drop database. Next we are going to see about run command. Then we'll see about bulk write and GridFS. This is run command demo. I'll be using this portion of the code. Now we are going to see how to execute commands against MongoDB. For command reference, please visit this section, that is database commands under reference. To start with, I'm going to use a simple command, that is to get the server status. Run method, it's going to return a document which we are going to print. And then the print. To JSON. On running this, we must get the server details. So we got the server info, put the host details, all those details here. Similar to this, you can get the database status also, that is DB stats, I hope. Yes, we got the DB stats. Similarly, we can get the collection status. The command for that is coll states. This is the one we are going to use. So coll states, and then the collection name. The details of the collection is presented here. The There are many interesting operations you can do with this. For instance, you can shut down the server, you can copy the database. Try by yourself. This is a very useful method for doing such operations. We have seen about how to execute commands against MongoDB. The next one in our list is how to use GridFS. Using GridFS is very simple. Need to create a bucket equal to the first buckets dot create. I'm going to create a bucket first to save a file. The DB is this one, that's DB demo, and the bucket name is equal to demo temp bucket. I'm just going to save a file in this bucket.upload stream. This is the one we are going to use, upload from string. The first argument is a string argument. That's going to be the file name, line stats, and then here it's new file, input stream, new file. This is the file. It's ctemp langs.jpg. This must create a bucket for us, that is demo temp bucket, and then langstats is a one we'll be using for this file. So let me run this using MongoBooster. Refresh. So we got the bucket. On double clicking this, the file is revealed. On clicking view file and selecting the appropriate application, this is the file we saved using GridFS bucket, upload from stream. So this is how GridFS works. Similar to upload, you can even download from the GridFS easily. So now we have seen about how to execute commands against MongoDB, and then we have seen how to use GridFS. The last one is bulk write. I'm going to create a separate class for that. Let me use the same code block. We are going to see how to do a bulk write using MongoDB Java driver. This is a bit challenging when compared to the previous topics what we have seen for this MongoDB Java driver usage. We'll be using the bulk write method in collection class. If you check the API here, it mentions about bulk write, and then a list which extends the write model. Write model has many subclasses such as delete many model, delete one model, insert one, replace one, update many, and update one. So if you are going to use delete one, you need to use this model, and if your document is for updating, you have to use this model and add that to the list which is shown in the API. Now let us see how it works. So in a batch operation, I mean the bulk operation, I'm going to do 2 inserts, update and a delete. So for clarity, let me create the documents first. Doc insert 1 is equal to new document, which is going to take username insert 1, and I'm going to append the password. PWD insert 1. Similarly for insert 2 also, I'll be doing the same. Insert 2, and the password is going to be insert 2. Now for update, we just need to set the value for the update. This is for doc update. The original document, it's going to have the username. Let me get the username from here. The username is going to be admin2. The updated one, I mean the new one, is going to have a username admin to modified, and the command execution for setting this is going to be different here. Update command, new document, we have to provide the set operator here, and then the document name. You might have already known about this set operator. Now we did an update. Just to recall what I have did, I have created an original document. This will match the query, and the new document which is going to replace this. But do remember that we need to use a set, or it is going to just change the structure of the document with the new one. So I have used a set operator. It has to go in the form of document. So I'm going to do 2 inserts, update and a delete. So for clarity, let me create the documents first. Doc insert 1 is equal to new document, which is going to take username insert 1, and I'm going to append the password. PWD insert 1. Similarly for insert 2 also, I'll be doing the same. Insert 2, and the password is going to be insert 2. Now for update, we just need to set the value for the update. This is for doc update. The original document, it's going to have the username. Let me get the username from here. The username is going to be admin2. The updated one, I mean the new one, is going to have a username admin2 modified, and the command execution for setting this is going to be different here. Update command, new document, we have to provide the set operator here, and then the document name. You might have already known about this, a set operator. Now we did an update. Just to recall what I have did, I have created an original document. This will match the query, and the new document which is going to replace this. But do remember that we need to use a set, or it is going to just change the structure of the document with the new one. So I have used a set operator. It has to go in the form of document. So one more document I have created here, and then provided the new one to this. And finally delete. Delete is going to be very easy. I'm going to delete this one, that is with admin3. Document delete. I'm going to delete this admin3. So we got two inserts, a single update and a delete in a bulk write. Now it's time to create a list. Array.as list. This is the one we are going to use. The complex part is going to be here. New insert one model and the document. The document is doc insert. So the next one, it's going to be doc insert 2. We are going to send this list as a bulk write. Third one is little complex because we'll be using the update one model. Update one model, the filter and the update. The filter is the original document. The update is going to be the update command that will have the new document with the set command. Now we have done two inserts. I mean, we have prepared the list for two inserts and one update. New delete one model, and this is going to be docdel. So let us see it again. We have created a list with two insert models, one update model and one delete model. For update model, this is the filter query, that's the original document which admin2. I'm going to replace that with admin2 mode without changing the structure, so I have used set. Now to the key method, that is collection.bulkwrite, and this is the list we are going to write.
list of data. Let us check the collection status before and after. This is the status before bulk write. The status after bulk write, it's going to be different. So we got 2 inserts, 1 update and 1 delete. Admin 3 has gone, which we have deleted using delete model, delete 1 model. This shows how bulk write happens. So let me walk through this again. For bulk write, we need to create a list of models. For that, we have prepared the documents initially. For update, we have a original document which will be acting as filter. The second one is a command with the set operator, which is going to replace the original one with the new document. The third one is for deleting. For that, we have used delete 1 model. We created a list and then we have passed the list as a parameter to the bulk write method in collection class. So this has changed our existing data in the collection successfully. So this is how bulk write works. With this, we have seen all the demonstration topics. We have listed the databases. We have looped through a collection to display its documents. We created a new collection. We did insert single, insert many, and similarly delete and delete many. We dropped a collection, we dropped databases. We used find and we have used classes under the model package, filters, sorts, and projections. We did update. We have seen about run command. We have seen how to upload a document using GridFS. Finally, we have seen about bulk write. With this, we have seen the demonstration of using Mongo Java driver with MongoDB. C# with MongoDB. This is a fairly easy process. The API is very clear and concise. These are the key steps involved. The first step is to install the package, that is the MongoDB driver, using the NuGet in Visual Studio. The second step is to use the Mongo client class. This is used for connection. The third step is to use one of these classes, models collection based on document filters, to do the CRUD operation. As you know, there are 2 ways to install NuGet packages. Either you can take command line options or you can do visually using the context menu. For our demonstration, we'll be seeing these. We'll be listing databases, listing collection contents, we'll be creating new collections, we'll be inserting, we'll be finding, we'll be updating, deleting, we'll be limiting, sorting, filters, and we'll be doing the projections. And finally, the important ones, bulk write, run command, and GridFS. The link mentioned here, that is the GitHub link, has complete details about the C# driver. Let us visit that first. Search for MongoDB C# GitHub. This is the link. This page has all the releases, references, and APIs for the C# driver. Google for MongoDB C# GitHub. Click on the search result. Click here further. This page has details about the various releases of this C# driver, details about the packages involved. On clicking reference, it has a great tutorial about how to get started. Installation steps are given here. Under quick tour section, you can see details about the common operations
and the CRUD operations. For instance, details about making a connection, getting a database, getting a collection, inserting a document, finding a document, all those details are available here. Under admin quick tour section, details about the admin operations are available, such as how to create a database, how to drop a database, how to create a collection, drop a collection. All those details are available under admin quick tour. In our demonstration list, we are going to start with the first three, that is list databases, list collection contents, create a new collection. These three we are going to see now. Under Visual Studio, right click here to install the necessary driver. Click Manage NuGet Packages. Search for MongoDB. It lists you two drivers, MongoDB driver and the old one. Click on this. Click Download. So there will be three packages installed. Let us cross verify here. MongoDB driver, Mongo driver core, and MongoDB JSON. So all three are same. Clicking OK. We must see the drivers in our references. You can see here in the references, MongoDB JSON is available, MongoDB driver is available, and MongoDB core is available. This is the easiest way to install a NuGet package, or you can take the command line option as mentioned in the slide. We are going to see our first set of demonstration, that is to list databases, list collection contents, and then to create a new collection. I'll be using a separate class for this. The key packages needs to be imported first. That's MongoDB.driver and using MongoDB.bison. First step is to create a Mongo client, which is going to connect to the local host. Next step is to list the databases. Client.list databases, that to array list, to list. Now we have the list of databases. The next step is easy. We just need to loop through this one to get the available databases in the local host. In the main program, I'll be calling this one, that is demo set1 dot main. On running this, we must see the list of available databases. These are the databases available: DB demo, PHP, DB local, test C#. Let me refresh this one. So we have done our first sample. So list database is over. The second one in our list is to list the collection contents. That's very easy. Let me client dot get database. I'm going to use this one, demo PHP-DB. Under this, I have a products collection. Get collection. Name is products. Yes. So here it needs to be a JSON document type. Now let us convert this zone into a document list. That's easy. Doc list equal to collection dot find new JSON document dot to list. Doc list. Let me run the code now. We got the complete collection contents over here. What we have done is, using client, we got the database and we got the collection of type JSON document. Then on that collection, we have done an empty search that's using find method. We converted the result to a list and we looped through the list to get our collection contents. Let me cross verify this one. So GoPro. So the results are similar. 9 objects we got. Let me cross check the result. We got 9 documents here. And here too we got 9 documents. We have successfully finished our second assignment, that is to list collection contents. The third step is to create a new collection. Let me create a database as well as a collection. That's very, very easy. So this is what we did is for showing collection contents. The next one is for creating new DB and a new collection. Let me copy the same code. Client.get database. The database name is going to be C# demo DB dot create collection. Please note that this database doesn't exist. So when you use get database for a database which is not existing, it's going to create a new one. The collection name is going to be products. So we have done. Let me run the code. Now we must see a new database and a collection created. Clicking refresh. C# demo DB is created. C# demo DB. Under that we must see a collection by name products. Yes, we got. So this is how we can create a new database as well as a new collection. We have successfully seen the top 3 in our demonstration list. Next we are going to do a insert single and insert many. To demonstrate insert, I'll be using a separate class. So let me create that here. Insert demo. I'll take some code part from our existing example. I'll be using some existing code portions. Mongo client, then the connection to the database and the collection. In our case, do remember that we created a database by name C# demo DB. I'll be connecting to that, then to the products collection under that. The next step is to insert one. For that, we need to create a JSON document first. Add the fields, category, string value is going to be electronics, then again I'm going to add few more fields, key value pairs, the name of the product, it's going to be the Amazon Echo Speaker, price, it's going to be around $180. Now we have created a JSON document. The next step is to call insert one function in the collection, insert one, and then the document name. Now let me call this main function in our main program. On running this, we must see a new record inserted. Refresh. Yes, we got one record. Let's see the records. We have 3 fields now: category, name, and price. A single insert has been done. That's what it's called as insert one. The next step is to do multiple inserts. For that, we need multiple documents in a list form. and then we'll be calling the insert many like this. Insert many. Okay. 1, that's 2, that's 3. Category is electronics. Price is going to be $32 or $33. It's command 37. The next one is mechanic kit. Price is around $90. And finally it's kitchen timer. Price is around $10. Let me add all this to a list. The list of docs is going to be new. List of based on documents. List of docs dot add doc1 doc2 doc3. Just need to change the same here. doc1 this is doc2, oops, doc2 and doc3 followed by doc3. It's going to be list docs. This will do multiple inserts for a single method call. Let me run this one. We must see multiple records now. Yes, we got all the records what we have done as a batch operation in insert many. So this is how insert one and insert many works. The next in our list is find and find with query. We'll be knowing more about find with query when we are going to use that with limit, sort, filters and projections. So now let us see a simple demo using find and find with query. First up, I'm going to create a separate class for find. I'll be using the code portions from the previous examples. We are going to search in this database and in this collection. Now on this collection, I'm going to do a find query. It's going to take an argument of a document, that's based on document. Initially, I'm going to give an empty document so that I'll be getting all the records there. To list is the simplest way, or you can use cursor also. I'll go with list currently.
code formatting. Oops, I haven't called this in the program. Now we got all the documents in that collection. Now let me introduce a condition so that it's going to filter based on price. Let me give the value as 90. Price 90. On running this, we must find items with only price 90 is listed. This is how find with query works. We'll be seeing more about this while we are going to see about limit, sort, filters and projections using builders. So our next topic is going to be on this flow. Let us start with limiting first. It's very easy. You just need to call the limit method here, and the number of rows, the number of documents need to be displayed. In my case, I'll be getting 3. Oops. Prior to that, I want to take out this condition. So we got 3 listed here. So this is how limit works. The next step is to have sorting. For sorting, we'll be using builders. That's very easy. So builder equal to builders. It's going to be here. bzone document dot sort. That's it. Variable sorting is equal to, on this builder we are going to call the ascending method or the descending method. We have ascending. I want to list the prices in ascending order. I will take the column, the field name here as price. So this must give us the result in ascending order. So we must pause this sorting, call the sort, and then pause this. That's it. So we must get the top 3 least priced products. This is the result. This is how it is in the DB. So 10 is there, 10 is there, and 33 is there. And more 33 is there, but we have limited the results by 3. So we got it. Sorting works fine. The next step is to have projection, because as you can see currently you get the ID field. I want to filter this ID field and the category field. I just want only the name and the price. It's a different builder. So builder projection is builders. Builders bzone document type dot projection. That's done. Now the next step is to do the projection configuration is going to be builder underscore project dot. We got include and exclude. I'll be including the price and the name. I'll be excluding the ID column. So we got a new projection. Let me take out this sorting now.
want to do a projection. So we got project method. I'll be pausing projection config. On running this, we must see only the required columns get displayed here. So name column we got and the price column. We have excluded the category and the ID column. So this is how sort, projection and limit works. Now let us move to the next one. In our demonstration list, we have seen about limit, sort and projections. Now let me show about filters. Filters is very easy, similar to projection and sort. Let me copy this line. Filter, and here it's going to be filter. Filter query is equal to. You can see different methods are listed here: greater than, less than, equal to, all those things. And for this demo, I'm going to use a greater than. You just need to give the field name first. Field name is price, and I want to get products with price greater than 50. So instead of project, it's going to be filter and this filter query. So our find method will use this build filter to filter the documents which have price greater than 50. I'm running this. We got 3 products which have price greater than 50. Let us cross check that. 1, 2 and 3. Yes, that's right. So this is how filter works. The only difference is filter needs to be given in the find method, whereas for project and sort we have separate methods. Now next topic is update one, update many, delete one, delete many, drop collection and drop database. These are very easy. Let us do that. Let me create a separate class for that. Let me copy some code portions from the insert demo. So basic setup is ready. We are getting the collection using the Mongo client, and the collection name is products. Now the demo is update one. So let me create a separate class for this. Update delete a demo. And I'll take some code portions to speed up.
So we got the collection now. Now we are going to see about update 1. It's very easy. You just need to create a filter and then you need to set the value. So create a filter and set a value. That's it. So you know about creating a filter. We have seen about builders. So it's builders based on document. So I'll be changing the value of this 33 to 40. So that I'm going to do here. The filter is going to be on price, 33. So to update it, it's very easy. Builder underscore update. It's the same. Update will be called here and the set method. Prices 40. Now it's simple. We just need to call the respective method. That's it. So on this collection dot update 1 takes 2 parameters. The first one is filter and the second is the update statement. I'm going to change this. Run it. So I need to see the changes here. Yes, as you can see, the 33 got updated into 40 in one document, not in multiple documents. So in case if you're going to use update many, it is going to update multiple documents. For instance, I have 2 documents with price 90. I'm going to change that as 95. The difference is here I'm going to use update many. So we must see multiple documents must get updated now. 1, 2 we got. So we got both the documents updated. So this is how update many works. It's very simple. Just remember to call the filter and then the update set. Now to the delete. Delete, it's going to be the same, only the thing is it takes a single argument instead of 2. So I'm going to delete 1 where the price is 10. Same filter, but this one is for delete, price is 10. Next up is collection dot delete 1, the condition. Let me comment this portion. We have 2 documents. After this we must see only 1 document. Done. Yes, one is gone. Oops. Yeah, right, it's right, because it hasn't deleted 2 documents, because I mistaken that it has deleted 2 documents, because I have given here only delete 1. So in case if I am going to give delete many, it's going to delete both the documents. So let's do that also.
delete many, prices 95. After this, we must not see price with 95. Gone. This is how update and delete works. We have seen about delete many, update and update many. So for update, just remember that you need to call update and then set. For delete, it's very straightforward. You just need to give the filter. That's it. The next one in our list is to do a drop collection and drop database. This is very easy. Let me create a separate class for this. The API is very well organized, so things are very easy. Let me paste some code portions from the previous examples. To drop a collection, you just need a tilde the database. So you got the database and then do a drop collection on that. db.drop collection. Our collection name is products. Let me cross verify it. It's products with 4 records. On running this, we must see the collection vanished. Here it is, drop demo. Refresh here. Collection is gone. Now to the drop database. That's very easy. We just need till client only, the layer above the database. So drop database. That's it. Let me take out this. Running this, we must see the database dropped. So database is gone. This is how drop collection and drop database works. For a drop collection, you just need to call the drop collection method in the database, whereas for dropping a database, you must call the drop database in the client. The next one in our list is bulk write, run command and GridFS. Let us start with bulk write. It's very interesting. So a new class to do that. Bulk write demo. Let me copy the code base from here. Oops. If you see the API for the bulk write method, it takes write model as a parameter. So let's create an array of write models, and for a write model, this is the API of that. and you can see the inheritance hierarchy. There are many models under this. So if you take insert one model, we can add a insert one model to a write model array, and then we can feed that to the collection.bulk write method. So the first step is to create insert models, then we will create update models, then finally we will create delete models. So this document is good for insert model. Let me take down this here. So this is doc1 and this is doc2. This is going to be some dash prices $2, where insert model 1 is equal to insert one model. The document is bsum document. It's going to be doc1. Let me create the second one. So this is model 2, it's going to be doc2. So we created 2 insert models and 1 update model. I'll be using the same. Update action, this is going to take the doc update here and the set. Now let us create a update model. It's going to take the filter parameter. Come on, this update action. Oops. Done. So we have created a update model. Let me add one more product here so that deletion can be done easily. Top 3. It's going to be Casio Wave Scepter. Prices $59. There is stock 3 here. Insert model is 3. So for delete model, I'll be using the same to delete it. So bsum doc3 filter for delete prices 59, which will be matching the Casio Wave Scepter. And where delete one model is equal to new delete one model bsum document. The document name is doc3 underscore filter delete. So we got all the models now, totally 1, 2, 3, 4 and 5 models. The next step is to add that to an array. That's very easy, where write models is equal to new write model. It's going to be of bsum document. It's an array. Here we'll be giving all the models insert 1, insert 2, insert 3, model 1, insert model 2, insert model 3, update model, delete one model. The next step is to call the collection.bulkwrite, right? Bulkwrite, and we need to pass this as a parameter here. So let me recollect what I have done till now. We created 3 JSON documents for insert models. So all 3 are linked here. Then we created an update model. Update model was a little bit complex because we need 3 documents for that. One for filtering, one having the update value, and the third one having the set. So that's done. And again we used filter delete to create a delete model. So this is BWrite demo. So let me run this one now. So we must see the new collection created, database created. Yes, we got view documents. Perfect. So we did 3 inserts, so out of which one is deleted because we have given in delete one model to delete the wave septor, that is cashew wave septor. This might have got deleted. This is deleted. Because of this price 59 we are deleting, and we got an update. The price was 2, we are updating by 1, so we got an update successful. Similarly the inserts are also successful. This is how bulk write works. Let me recollect what we have done. It may seem a little bit complex, but it's very easy. In the first step you just need to create the necessary documents, JSON documents. Once that is done, select the model which you are going to do. For instance, you can select insert model, update one model, or update many model, or delete one or delete many models. Then using the documents you have, create these models. Update model is little bit challenging because you need to create 3 documents. The first one is for filtering, the second one is the real update, and the third one will have the set operator with this update document. So once update model is done, similarly you can use delete model, which is very easier because you just need the filter condition, so you need a single document. Once this is done, create a write model array. All the models have been inserted, and just simply call the bulk write method. It will write all the models whichever you have done here. This is very useful when you are going to do a batch operation, and you can reduce a network overload. The next in our list is to do a run command. This is very easy. We have seen about bulk write that is used for batch operations. Now we are going to see about run command. This is a very simple but a very handy method for executing database commands against the database. If you search for MongoDB commands, you'll be finding this link, database commands MongoDB manual. Under this commands page, the commands are grouped under 4 different categories. We are going to use this command to see the storage utilization of our collection. We are going to call the db.run command. The command has to be in command format. As you can see here, the syntax is in command format. We can create a JSON and then we can cast to that.
In the command, on clicking that, you'll be able to see how the syntax works. We'll be giving the command and the string. So we'll be doing the same. So this is call stats command. The name of the collection in our case is products collection. We're going to give here based on so let me do a cast here, command of type console.writeLine, or let me write it to JSON. So what we have done is we created a JSON document with the command and the collection name. Then we have casted that to a command object and we have executed using the run command method. On running this, the details are here. This storage size is important, which is given over here, and this is our collection name. So this is how run command works. You can use this for variety of purposes, for database monitoring, all those stuffs. The next one in our list is a GridFS, which is one of the interesting among all this. So this helps us to save images or videos to our database. Let's do a sample on that. For GridFS, you need to install a package. Just Google for MongoDB GridFS or just GridFS. So this is the one you need to install. It's already there. So once this is done, you'll be able to see the namespace using MongoDB .driver.gridfs. This namespace will be available only after doing the installation. Now let me copy some code portions. And similarly for this. One of the key classes we'll be using is GridFS bucket. So this is the API of that class. This zone we are going to use. So where is equal to new GridFS bucket. As you can see here, the first argument is a database, so we can easily give our database name here. The second one is a GridFS bucket options. Let us do it later. Now we got the bucket. In bucket we got two upload methods. One is upload from bytes and upload from stream. If your file size is huge, go for upload from stream. If your file size is normal and within your RAM limits, because this one is going to load the entire content into your program memory, so you can go for upload from bytes. So I'll be using the first one, upload from bytes. The first parameter is the file name which is going to be saved in the database, and the byte source. So to get the byte source, let me use a file class.
that's under system.io.file.read all text. Temp. Let me locate the file first. It's langs.jpg. Langs.jpg. Yeah. So this is going to save in a byte array. The file name, in my case, I'm going to give a name like langs info. Source is this. Sorry. Read text. Read all bytes. Yes. So the issue is fixed now. What we have done is we created a GridFS bucket class. We have read the file contents, and then we have used upload from bytes method, not the upload from stream method. We have used upload from bytes because it's a small file, and then I'm passing the parameters. Let me run it again. Done. Let us cross verify in the database. Refresh. We got the files. Langs info is the file name we have given. View file. I'm using it from view for this. So we got the langsinfo.jpg file uploaded in the database using GridFS. So similarly, you can use find and download methods to download from the database. So this is how GridFS works. It's very, very simple but very useful. With this, we have seen all the topics in our demonstration. The important ones are bulk write, run command, GridFS. PHP and MongoDB. It is very easy to work with PHP and MongoDB. The only challenge currently is that PHP has 3 different paths. The first one is PHP 5.x, the second one is HHVM, and the third one is the newly released PHP 7. As you all know that PHP 5.x has a wider adoption and it is live in many production systems, though it lags in performance. Mainly due to the performance reasons, the PHP community adopted to HHVM faster, and there has been many migrations to HHVM. But please note that PHP 7 has performance as similar to that of HHVM in all the areas except in WordPress PHP. But I hope in next iterations they will be catching up HHVM in that also. So we have 3 different installations to be done for 3 different paths. We'll be sticking with the most widely used, that is PHP 5.x, because as you all know that PHP 5.x is compatible with PHP 7. We'll be using PHP 5.x for our demonstration since PHP 5.x is widely used and migration to PHP 7 is very easy from PHP 5.x. There are 2 different types of drivers available in PHP.NET for MongoDB. The first one is the legacy driver, the not recommended one, that is Mongo driver. It's very simple to work with Mongo driver, but it is not recommended. So we'll be using the latest one, that is a MongoDB extension, PHP mongodb.dll. In addition to that, we'll be using a MongoDB library to make our work easier. MongoDB library is a higher level of abstraction over this MongoDB extension. So you need to install these 2 things in your system. For the installation, you need to use PCL or direct download from PHP.NET website.
And for the MongoDB library, we'll be using Composer. It's very easy. We'll be seeing more about the installation process in our demonstration. We'll be doing the following steps for the PHP MongoDB demonstration. The first one is we'll be installing the MongoDB extension from php.net. Either you can use a PECL or you can directly download the DLL from php.net. In the second step, I hope you must be all having this one, either XAMPP, WAMP or MAMP in your systems. In the third step, we'll be configuring the extension in the PHP ini file so that this PHP MongoDB.dll is in the extension list. In the fourth step, we'll be installing Composer and we'll be using Composer to install the MongoDB library. And in the fifth and sixth steps, we'll be locating the autoloader.php and we will be including the path in our PHP scripts. So these are the 6 simple steps we are going to do for the installation and configuration. It's very, very easy.
Under Getting Started section, 2 installation steps are given. The first one will be using PECL for installing. This is for the installation of MongoDB extension. For the second one, you need to use Composer. You can use PECL or you can directly download from php.net. So visit php.net, search for MongoDB. So this will take you to the extension page. As you can see, database extensions, vendor specific extensions, MongoDB. Click on the installing configuring section. As mentioned earlier, you can use PECL for installing this extension or you can directly download the DLL. Click on this. There is a mistake here, that is this extension has to be PHP MongoDB.dll, not this one, because this DLL refers to the legacy driver. So for extension, we'll be having PHP MongoDB.dll. Click on this. On clicking the DLL, will be listed with thread and non-thread safe options. Click on the thread safe x86. In the zip file, you'll be able to see the PHP MongoDB.dll. This has to be kept under the extension directory and this entry needs to be added to the php.ini file.
In our demonstration list, the first task is to list the database. So let's do that. The first step is to add the autoload.php of Composer. In my machine, it is located under C user Sorgo vendor. Sorgo is a username. So let me copy this path. The next step is to use the manager. For manager, it's very easy. You just need to import this one or use this package driver. So under this, we can get the manager class. Manager is used for connection. New manager. Here we have to give the server URL. We have a MongoDB instance running in port number 27017. Now manager is done. The next step is to issue a command. To check the API for this command, you can search for MongoDB driver command. PHP.NET reference will be listed. So here you can see the examples and the syntax for command. So it's an array. Here we'll be giving the MongoDB command. To learn about MongoDB commands, just Google for MongoDB commands. Here 4 sets of commands are given. We are going to see about listing databases. So list databases is the command we are going to use here. That's done. The next step is to execute the command. For this, we are going to use the execute command method in the manager. Execute command. The first parameter is the database name. So that's admin database. The second parameter is a command. Let's see about the syntax of this. This is the API for execute command method, which is going to return a cursor. It's going to take 2 parameters, that's a string and then a command. String will have the database name. It's going to return a cursor. Let's dump this cursor to see what it has. I have copied the result to a separate file. We have to extract this one. For each cursor result, and again one more for each. This is for result. We have databases. Let me cross check that. Yes. Yes. DB name. It's going to be DB name. Come on. So let me comment this one out and do a code formatting. On running this, we must see the databases names. Class SDD class cannot be converted to a. I need to check this output here. Yeah, this is name. I missed it. Let me add this one. Now we must get the database names listed. Yes, these are the 4 databases currently available in the local server. Let us cross check the same. DB demo, demo local, and PHP MongoDB. So all 4 are there. This is how to list the available databases. Let me recall what I have done. In the first step, I have included the autoload.php. In the step 2, I have used manager and command class under MongoDB driver package. Using manager, I have connected to the localhost. And in the command, I have issued list databases command. For the command syntax, please do Google for MongoDB commands. It will take you to the reference of all the commands, where the commands are grouped into 4 separate sections. Then I have called the execute method in manager to execute this command against the admin database. And then I have just looped through the cursor to get the database names. Next one in our demonstration is to list the collection contents and then to create a new collection. So we'll be doing these two together, list collection contents and then to create a new collection. Let me create a new PHP file for that. The steps are going to be same. Contents. To list the collection contents, let me take the code part from here. So we have manager now. I'm going to use the database class, which is going to be under use MongoDB database. It's going to be mgmr. mngr, comma, the database name. Let me get the database name. It's db_demo. Now we have the database. The next step is to have the collection. So $db. The collection name is call user details. I'm going to do a find in this collection. Currently without any queries, so it's going to list us all the elements in that particular collection, which is in turn is going to return a cursor. We got the cursor, then for each $curs as $doc. What's going to be there? Let me get the fields. That's username. I'm going to list here. So that's it. We must get the usernames. Yeah, I need to run this one. We got the username Bob. This is the only one document in this collection. If you want to change a collection, you just need to give the collection name. It's a user ID here. I just changed the collection name. To list a collection under different database, you just need to give the database name over here. For instance, demos the database name. The collection name is tbl_login. And the field name is user ID. So instead of username, I'll be giving user ID. The results are matching. Let us recall the steps what we have done for listing the collection contents. We use the manager class to connect to the server, database class to select the database, and then we have selected the particular collection in the database instance. And finally, we have used the find method to list all the contents of the collection. So it's pretty simple. Let us move to the next one in our list, that is to create a new collection. Let me do it here itself. This is for listing collection contents. I'm going to create a new database, that is demo_php db. Under this database, I'm going to create a collection. Create collection, the collection name is going to be products. Let me do a var dump of this. It's a simple one-step procedure where we have connected to a database which is not existing, and then we have called the create collection. Now let me run this one. It's okay, it's created. Let me check in MongoBooster. Yes, database is created, and then it has a products empty collection. We have just seen how to create a new collection. We have created a new database, demo PHP DB. Under that, we have created a collection by name products. Now the next step is to do a insert single and insert many. Let me create a new PHP file for this. The first step is to have the require. Let me copy this from here. In the second step, I'm going to use the manager. So let me copy this particular code. Manager is same, database is same. We are not going to create collection. We are going to just select the collection. The collection name is products. Now we got the collection. The next step is to insert in this collection. Prior to that, let me check the data in the collection, I mean the documents in the collection. So we don't have any data in the products collection. So let me insert a few documents here. Let's insert one. I'm going to give an array. It's going to be the product name. Name is going to be drone parrot. And price is going to be $300. We can even get the result here like this, and then put a var dump of the result. We don't need command. Let me delete this one. Let me run this. We got the insert ID 2 here. So it's successfully inserted. The next step is to do an insert many. That's going to be very easy. Let me comment out this one. Instead of insert one, I'm going to use insert many. The product list here, the name is GoPro Hero, price is $215, PHP Storm ID, price is 19. I just need to add one more square braces. Just remember that this is the main difference. For insert one, we'll be having a single square brace at the beginning and end. Here it is array within array, so we'll be having 2 square braces. On running this, we must see 2 new values. Yes, so insert many is successful. The next step is to do a find with query and a plain find. Let's do that. Let me copy the common portions. Now we have the collection. We just need to do a find in this collection. It's going to return a cursor. The next step is to loop through the cursor. On running this, we must see the names. We need to run the find demo. So drone parrot, GoPro, PHP Storm ID, GoPro, and PHP Storm ID. That's because I ran insert demo twice, so the duplicate values are here. Results are same. The next step is to filter the result. That's easy. The find query, we are going to filter using the product name. It's going to be a document, so array brace is required. Name, it's going to be PHP Storm ID.
Let me run this one. I need price. Running this, it must list the price. Yeah, it's 1919. This is how we'll be filtering. The next step is to see about sorting, filtering, and projections. That's very easy. So for this, I have created a test data. Here introduced a new category by name IDE in our products collection. The IDEs with their price. And similarly, I have updated the PHP Storm IDE's values. I have added a category IDE field here. Executed this one. Currently, my collection looks like this. It has a category called IDE with price, and different IDs are listed here. So we'll be using this simple collection with minimal records. First, let me select the category. And run this. Let me list both the name and price. This is the one. Next step is to limit the number of records shown. That's very easy. You just need to call the limit here, and then let me make it as 3. So we got only 3 results. For sorting, that's very easy. Just sort here and add another array. The field name is going to be the price, and the sorting order is -1. On running this, we must get the top 3 priced IDs. So Zen Studio, it's 189, PHP Designer is 99, and Rapid PHP is 59. So this is how sorting and limiting works. Now let us see about projections. Projections are very easy. Let me use the same array like this. You just need to say the projection and then the columns you need. In my case, the fields I need is the name only. It has to be 1. Square braces is ending here. We have added projection. It's going to throw an error because price is filtered out. If you take this out and then execute this, it's going to give you both the columns, I mean the name and price. If you include the projection, it's going to throw an error because price is filtered out. We need only the name column here. Let me run it again. Okay. So that's how we got undefined index price.
We got the names listed as you can see here: Zen Studio, PHP Designer and Rapid PHP. So name got listed and not the field price. Let me comment out this and show you how the var dump looks. Var dump of the doc. We have only the name in the var dump. If we are going to take this one out, it's going to show all the fields. So we got name, price, category, all the three fields. If I'm going to introduce projection, it's going to have only the name field. This is how projection works. Now let us see about update and delete many. Separate PHP file. Update demo. So till this it's common. Let me copy this portion over here. In this collection we are going to call the update one method, which in turn is going to take two arrays as a parameter. The first array is for filtering the values and the second array is to set the values. For filtering values, instead of VStudio, I am going to change the name as Visual Studio. VStudio is the name. The name is VStudio and I'm going to set the value here using the set operator. The name is Visual Studio. So that's it. If you want to save the result, you can get the result here and then do a dump of that. On running this, we must see the record updated. It's true. View documents. Yes, previously it was VStudio, now it became Visual Studio. That's how update one works. Let's do the update many here. The name is going to be PHP Storm IDE. I'm going to change the name as JetBrains PHP Storm IDE. Instead of update one, it's going to be update many. That's it. Let me comment this one out. So it's true. Let's check in the database. You can see multiple documents got updated. JetBrains PHP Storm IDE here too. We have seen about update one and update many. Now let us start with the delete one and delete many. Create a PHP file for that. Delete demo. The code is similar to update code, so I'll be copying this portion. Let me comment out this one, that is update many. I want to have this update one. Now I'm going to replace update 1 with delete 1. It just has a condition. The condition is name is Visual Studio. Let me cross check it here. We have a document with name field as Visual Studio. So that's what delete 1 is going to do. It's done. Let me check it again. It's gone. Now let us see about delete many. Instead of update many, it's going to be delete many. The query criteria name is PHP Storm IDE. Yeah, there is a spelling mistake. Let me correct that. It's delete many. Successful. I'm running this. Yes, the records, the documents having name, JetBrains, PHP, Storm ID is gone. So this is how delete and delete many works. We have seen about delete 1 and delete many. Now let us see about how to drop a collection and drop a database. That's very easy. I'm going to use a code which we have used previously for creating a collection and a database, because here I want to create a new database and a new collection. We know that this is going to create a new database and new collection. I'm going to just change the database name as demo drop. On running this, we must see a new database there. Let me refresh this one. We got the new database with the collection products. The next step is to drop the collection. So $db. The collection name is products. Yeah, products. $call drop. So this will drop the collection. Let me run this one. Refresh here. The products collection is gone. Now to drop the database, that's easy. Again, you just need to call the drop method, but on the DB. Done. Refresh. It's gone. So this is how a drop for the collection and drop for the database works. With this, we have seen about all in the list except a bulk write, run command, and GridFS. Let me start with bulk write. New file. It's very easy. I'll be using the code portion from our existing examples. We'll be using the bulk write class, use MongoDB driver slash bulk write. Creating a new instance of this, bulk equal to new bulk write. Now we are going to use the insert, update and delete methods in the bulk. To start with, I'm going to do an insert. Category IDE. Oops. Name, it's going to be PHP Storm IDE. Come on, price $19. Similarly, I'm going to insert Visual Studio here with the price as 0. Then update. As you know, update has two array parameters. The first one is for filtering. So let me check the existing record here. NetBeans. The name is NetBeans here. Category, it's the same. I just need to do a set here. $set. Update is done. So NetBeans will change into NetBeans IDE. And finally, I'm going to delete this one. That's a drone parrot. Name is, I have a name already. So we have 4 operations, 2 inserts, 1 update, and then 1 delete. In the next step, I'm going to use the manager execute bulk write method. The first argument is going to be the database name, followed by the collection name, it's products, and then the bulk. This step is not required. Similarly, this one is not. So we have a manager. On that, we have called the execute bulk write. We have used the bulk write class, which is under MongoDB driver. and then we have called 4 operations on that bulk: insert, and then update, and finally delete on that. So let me run this one. Refresh, products, view documents. NetBeans ID is changed, updated successfully. Visual Studio is inserted. Yes, it's done. Price is 0. PHP Storm IDE, yes, inserted with price 19, and then drone parrot is gone. So this is how bulk write works. This is very simple but very useful for batch operations. GridFS with PHP, this is an important and useful topic, but currently there is a minor issue with the installation and configuration process for the MongoDB library. That is, under Composer's MongoDB SRC directory, you may not find the GridFS directory. This is in most cases. So you may need to pull the source from the GitHub, and then you need to manually replace this SRC folder's content with the GitHub's one. For instance, the issue faced, it will be like this. If you search for MongoDB GitHub PHP and then navigate to the PHP library page and to the API. Under this API, you can see we have a namespace GridFS. So there must be a corresponding directory under your Composer's MongoDB SRC location that is available under this C users, username, vendor, MongoDB SRC directory. If it is not available, you just need to download that from the GitHub source directory. That is this one. You just need to download the zip file and unzip the source contents under this. So you'll be getting the GridFS source code here. After this only, you'll be able to work with GridFS and MongoDB. Let me create a new PHP file for that. Demo grid. I'm going to use the code portions from our existing samples. We got the manager. In the API, we have a class bucket under this GridFS namespace, which has key functions for finding files in GridFS collection and uploading a file as well as downloading a file from GridFS collection. We are going to use that class bucket. It takes 2 parameters in the constructor. One is the manager, the another one is the database name. After this, we are going to use the upload from stream function, which is going to take file name as a parameter and a resource as a second parameter. So the bucket class here, new bucket. The first one is a manager parameter. Second one is a database name. I'm going to use the demo PHP DB for this. That's done. Next is a file resource. Let me use a local file which I have already saved. langs.jpeg. Yes. The mode. That's done. The final step is to use the stream method. Upload from stream. upload from string. The first parameter is file name. Let me give a random name, demo grid, and the resource, that's $resource. That's it. This is going to create a new collection and insert this file into that. We don't need these two. Manager, yes. Let me run the code now. Done. Refresh here. Yes, we got the new collections, view documents. Demo grid is there. Click view file. F1 view. Yes. This is the file which got successfully uploaded through our code. It's just a 3-step procedure. You need to get the manager, then you need to create a bucket class with this manager and the database as a parameter, then create a file resource, pause the file resource here, and close the file resource after this. This is how GridFS works with PHP, and always do remember to replace this src folder with the content from GitHub. In MongoDB, we have a run command method. In PHP, we have execute command, which we have used for our list databases sample. We have seen the available databases using the execute command against the admin database. To learn more about commands, just Google for MongoDB commands. It will list you the various command options. As I mentioned earlier, this is similar to the run command method, which is available under MongoDB. So this example we have seen previously for listing the databases available under admin database. So let me use the same for a different purpose, I mean a different set of command. It's going to be demo command. For example, if you want to get details about the database, you can always use the dbstats method and the database you need, php demo db. I want to get the stats of this particular PHP demo DB. This command dbstats, if you search in the command list, you'll be able to find that. This gives you the report storage utilization statistics. We are going to run against this PHP demo DB. This is the result of this dbstats command, which is going to give you the storage size. So in future, if you want to execute a command, just refer to the MongoDB database commands document, get the related command, and then use the command class and the execute method to execute against the preferred database. Node.js, MongoDB. This is a natural combination, as you know that JavaScript plays a very key role in MongoDB. The following are the key ones in Node.js MongoDB learning. The first step is to install the MongoDB driver using npm. The second and third steps, they inform about the IDE. Either you can use Cloud9 or Cloud Anywhere. These are all web-based IDEs, or you can go for desktop-based IDEs such as WebStorm, Coding, Komodo Edit, Atom, or Sublime or Brackets text editors. I basically prefer Code Anywhere and WebStorm IDE for my projects. So for this demo also, I'll be using the WebStorm IDE. These are the key classes we'll be using. The primary one is Mongo Client, and the other ones are collection, cursor, admin, or the other key classes. We'll be using GridFS bucket for GridFS. So these are the basic points. This is our demonstration list. We'll be seeing the demonstration for a listing database, collection contents, creating new collection, inserts, finds, limit, sorts, projections, aggregations, update, drop, delete. And finally, we'll be seeing about the key one, that is bulk write, run command, and GridFS. So as I mentioned earlier, I'll be using WebStorm IDE for this process. And installation is very simple. You just need to do this one using npm for installing the MongoDB driver. I'm in WebStorm IDE. The first step is to create a new project for our demonstration. This is going to be of Node.js, Express app type, Node.js, MongoDB. Now we got the project. The next step is to see our demonstration list. So we're going to start with listing the databases available. So let me create a new directory, demo. Under this, I'm going to create a new JavaScript file or list db and collections. So step one is to import the required library. So for that, we are going to do this step where MongoDB equal to require it's going to be MongoDB. That's the first step. Second step is to have the Mongo client. So where Mongo client is equal to MongoDB client. So that's done. Now the third step is to have the connection. We know that the URL is going to be the localhost URL to the DB. So the URL is MongoDB localhost. Default port is 27017. Sorry, 17. The database we are going to connect is db demo. So db demo. So this is the URL we are going to use now. Now using Mongo client, we are going to do the connection. So Mongo client dot. It's going to be the connect method. We are going to give the URL and the function. It's going to be URL and the DB. So mapping. So under this, I'm going to list the database. So prior to listing the database, I need to shift the database, that is to the admin database, which is available under db.admin. So this will get us the admin database. The next one is to list all the databases available under this admin database. So dot list databases. It's going to be a function again. It's going to give an error.
all the DBs. So we got the databases here. The next step is to loop through that to get the database listing. So where I equal to 0, let me use a traditional for loop. For I equal to 0, I less than DBs dot databases dot length I plus plus. I'm going to do a console log. Code reformat. So what we have done is we used the driver library, then we have created a Mongo client from that, then we have passed the URL to the connect method, and then we have connected to the admin DB. So on running this, you must get the list of available databases. In case if you're getting an error over here, the module is not listed, then you need to go to this settings, go for Node.js npm. If you search for npm or Node.js, it automatically pops up here, and on this, to install a module, just click install. It may take some time to build up the available packages. So on that, just go for MongoDB. The description, it will be mentioned as official MongoDB driver for Node.js. And then click install package. So our first demonstration is successful. We are able to list the databases available. Let me recollect the steps what we did. We used the MongoDB library, then we have created Mongo client class, and on that we have called the connect method with the URL. Then this is the important step that I used admin DB, and then on that I have called list databases, which is going to list me the databases, and I have printed the available databases here. Now to the next one in our list, that is to list collection contents. So let me create a new JavaScript file, list collection contents. So these steps are same. Let me copy this code. We are not going to use this one. Till this, it's a common code part. I'm not going to use the DB demo. I'm going to use a different database this time. That is demo PHP DB. Under that, we have a collection by name products. Demo PHP DB. The collection name is products. Once we got the connection, we are going to get the database db dot. It's going to be list collections. We're going to turn that into an array of function, which is going to be the function. It's going to be error and the items. On looping through these items, we must get the names of the collections. So the steps are same. Equal to 0. I less than items dot length plus plus. It's going to be console dot
log, we go to items array, under that we are going to get the name. So DB collections to array, and then we have did this closes here, this closes here, and finally we are going to close the DB. We are using the list collections method. That's very easy. So these are the collections available under that we have already seen. One more thing is always refer the API if you are not confident about the method to call. Click on the API. We are under DB. Here we have the method list. We have used the list collections. The samples are given here. Now to the third one in our demonstration, that is to create a new collection, and we'll create a new database. That's very, very easy. So for this, I'll be taking some code portions from our previous examples. Let me copy this one here, and we don't need this. Our target is to create a database under new collection under that. So let me name this one as db.node.js demo. This will be our new database. This is currently non-existent, and this will be created once this is done. Next step is to call the create collection. So to know more about this create collection method, as I said earlier, refer to the API. So under DB, methods are listed here. And I'll be able to see create collection under this. Yes, this is the one. It's very simple. The next step is to give the collection name. I'm going to give this as products. On running this, we must see a new DB created and with the collection named products under that. It's done, I hope. Yes, we got a new DB and a new collection. This is how a create collection and create DB works. It's very easy. The next one in our demonstration list is insert. So we'll see both insert single and insert many, and then we'll see about find queries. It's going to be insert demo. For insert demo, we'll be using some code blocks from our previous example. And then this portion for connecting. We have two types of inserts. One is insert one, and the second one is insert many. For insert one, it's simple. We are going to just provide a single document.
In our case, this one is db dot collection. The collection name is products. And that we are going to insert one. It's going to be the name of the product, that is Amazon Echo, the price of that, it's going to be 180, and the category is electronics. So once we have done this, we must be able to see that this document got inserted into the products collection. So let me do a console.log. Insert succeeded. So on running this, it must create this record, this document in our collection products. So let me run this one. The insert is successful. As you can see, we got one document in our collection. So for insert many, it's the same. So we need an array bracket for this, since we are going to have multiple documents. Come on, third one. Here, this one is Amazon Fire TV, and this is paper white. That's around $100. This is also around $100. On running this, we must see multiple documents inserted into our products collection. So let me do that now again. To MongoBooster. We got multiple inserts using insert many. So this is a way to insert a single document and to insert multiple documents. Now to the next one in our demo list, that is find and find with query. This is very simple. Find is very simple. Let us use the same code block from our previous demo for insert. So instead of insert and insert many, we are just going to use a find method. So find, and then we are just going to do a to array. So to array will give us a function. Under that error, docs will be there. This will be because of this find method we got. And once that is done, then we just need to print the docs. Let me do a console.log of docs. And then do a db close. So this is the matching for that. So it's simple. We just got a find method without any filtering parameters, and we are converting the result to an array, which is going to give us the docs. And if you want to print the error, you can easily print by using a if statement. The else block, you can
print this portion. So it's very, very simple. We just need to call the find method. Let us run and check the results. So we got Amazon Echo, Amazon Fire TV, all those. So this is how find works. We got 3 results, right? So to limit that, you can always use limit function. Can limit by 1. And running this, we will be getting only 1 result. So limit is seen. Next is sort. So let us sort by the price. So under sort, we are going to give the field name. The field name is going to be price, and the order is going to be -1. So the most priced will be listed in the top. So this will give us a top 2. So 180 is the most price, so which got listed here, because we are doing a descending order. So this is how sort works. In case if you want to filter the results, you can give the filter over here. For instance, in my case, I'm going to filter by price, which is equal to 180. Let me take out this one. So these are the 2 records with price 180. This is how it got filtered. And in case if you need only few fields in the output, you can use a projection criteria. That's very easy. So in my case, I don't want the ID, so I'll be making ID as 0, and I just want the name. Name is 1 and price is 1. Means the columns name and price will be included, whereas ID will be excluded. Sorry for terming it as column, it is field. So fields will be included and this field will be excluded. So let's see the result. So we got it clearly here. So this is how you can do projection. So we have seen about projection, sorting, limiting. So in our list we have covered limit, sorts, filters we have did, and projections. So these 4 are covered. Find with query is also covered. Aggregation, let us see it later. Now let us go to update one, update many, delete one, delete many, drop collection, drop database. These are easy ones. Next one is a demo. Update and delete. I'm going to take the same sample from here. The next one in our list is bulk write. As you know that bulk write is used for batch operations. So in turn it reduces the number of round trips to the server. The bulk write API is a little bit different. So let's start with that. I'm going to create a separate JavaScript file for bulk write demo. And as usual, I'm going to use some portions from our existing code. So we don't need this one. So now we got the connection to the database. Next up, as usual, we need to get the collection. We're going to use the product collection. So db.collection. The name of the collection is products. On collection, we are going to do a bulk write. So let me call the bulk write function. The next step is bulk write. We are going to do many updates and inserts in a single operation. So array is required. Then let's start with insert 1. Watch this API or the syntax because it's a bit different and compared to the insert one. In insert one, in a previous case, you might have seen we might have called the method here, whereas in this case, the API call is different. Let me save some QNest security camera. Price is around $50 and a category is electronics. So this is our first record. The second one is going to be a update. I'm going to update this 199 as 190. So price 199 is the one. Filter is finished. So next is the update. Come on, update. So for update, we'll have a set operator, and for that set, we are going to set the price value. Price 199. I'm going to make it as 190. Matching, it's matching. So for update 1, the loop is ending here. Filter. So everything is fine. Now let us collect the result. Function, it's a error result. So console.log, it's going to be done, and db.close. So we are doing only two operations here, insert one and update one. Just watch the syntax. It's a little bit complex when compared to the other ones, but it will be very, very useful. Make sure that you finish the loops properly. Let's run this one, bulk write demo. So it's done. Let's check the database. We must see new insert. Yes, we got the new insert. And similarly, this value is also got updated. This is how bulk write works. Here we have used only two operations, but there are many other operations. As you know, we have delete one, delete many, update one, update many. That can be also used here. This is how bulk write works. Just make sure that you have a square brace here and all the brackets must be correctly finished here. Now let us move to the next one, that is run command. Run command is very, very simple and easy. So we are going to use the file IO here. First up is to use that. So where fs is equal to recover fs. That's done. Second step is where grid is equal to okay. The other steps are similar to the previous ones. So let me take some code part from here. So now to the file uploading part, I mean file saving part in GridFS. GFS is equal to grid. So in this we are going to give the database, that is a DB and the MongoDB. The next step is to read the local file. From file we'll be using for this. This API is very simple that it will reduce the complexity. File name is Langs demo. The source of the file. Let me have a separate variable here for that. So to add clarity, file source is equal to, in my local machine I have a file in temp folder. The file name is langs.jpeg. So I'm going to give the same here. That will be src. That's it, done. Next we'll have a function which will have error as the first argument and the file data, console.log, make it as file saved successfully. Followed by this, I'm going to close the database. You can add a step here if error return or something. So we are here to just understand what this one does. We used grid here and passed DB and MongoDB as parameter. Following that, we have used the from file function where we'll be giving a file name in which it's going to be saved in the database, followed by the real file name which is in the local machine. So let me run this one. File saved successfully. Refresh here. We got the new collection, view documents on that. We got the Langs demo, which we have mentioned here, Langs demo. And on double clicking, we must see the file. So this is a file I have uploaded from my local machine here. Similarly, you can do actions for reading. It's clearly given in the sample over here. So I just used this one. You can use read file, write file, to file, all those. So just try to use this npm package which eases your work for GridFS and Node.js. It's very, very simple. With this, we have seen about GridFS. So we have covered all the topics except aggregation. Let us see about aggregation. Aggregation is very easy. The next one in our list is aggregation. Aggregation is of three types, as you know: single purpose aggregation, aggregation pipeline, and Mapreduce function. We'll be using single purpose aggregation and aggregation pipeline for this demo. To start with, I'm going to create a separate class for this one. Separate file. Aggregation demo. So I'll be using some code portions from our existing examples. Now we are connected to DB Node.js demo, to this products collection. This is the data in products collection. This is very simple. Let us do the count first of the number of records in this collection. So for that, you just need to call the collection, the name of the collection here, and then the count. So we are not going to filter anything. We want the count of all the documents on running this, we must get the total count of documents in that collection. So it's 13, it's matching. Now let us see the distinct values here. I'm going to take a distinct on this particular name. So that's very easy. Distinct. Here, let me select the field name, its name here. So these are the distinct names available here. So this is how single purpose aggregation works. Now let us see the aggregation pipeline. That's also very easy. As you know, we have match in that, we have project, and we have the important one, that's group. So let me use the same for this. I'm going to comment out this portion. We'll be calling the aggregate method. Collection, the name is products dot aggregate. This is the one we are going to use. So to start with, let us use match first. So in the aggregate, I'm going to use the match operator. So for match, I'm going to list the items with price greater than 100. That simple price. And then we'll be using the greater than 100. That's it. So on running this, we must see the documents with price greater than 100. Code format, yes. So we got the list of documents with price greater than 100. So that's our match operator's work. Next, I'm going to project only name and the price. So for that, I'm going to use the project operator. That's very easy. Project. Oops. Name is yes. Come on. Price is yes. Come on. The ID column we are going to ignore. So this is how project works. We got name and price. ID and category has been filtered out. The next one is the important one. We are going to use a group operator. This is a bit challenging when compared to the other ones, because here every field will become a variable, as you might have worked with a group already. The first one is the ID column. ID, it's going to be the name field. I'm going to find the total price under each names. For instance, you can see here a duplicate document is there with the same name, Amazon Echo, price is 189. We must get the sum of this one. So the next is sum operator, and we are going to do the sum of price. It's matching here. Yeah, this is wrong. So let's run this one. So we got the result as expected. We got 2 instances of Amazon Echo with price 189 each. Now using sum, we have summed the total price. This is how aggregation works. Let us recollect what we have done. We have seen about single purpose aggregation initially. We used count and distinct. Later we have used the aggregation pipeline. We used aggregate. We use the match operator, project operator to filter out the fields, and the group operator. So with this, we have seen the complete Node.js demonstration list.
We are going to see how to use Python with MongoDB. It's very simple. MongoDB team has given a clear set of examples to do the same. So on Googling for PyMongo, you'll be able to see this link, PyMongo MongoDB API. Click on that. So this is a documentation page for PyMongo. As I said earlier, clear examples are given over here by the MongoDB team. And similarly, the installation steps are all explained over here. I'm going to demonstrate how Python works with MongoDB using 3 simple examples. The first one is a CRUD demo. The second one is bulk operations. And the third one is the important one, that is GridFS demo. So let's start with the basic one, that is CRUD demo.py. I'm using the PyCharm IDE over here. Let me walk through the code. The first step is to import Mongo client and version from PyMongo package, and then I have given a print for version. Then we are connecting the Mongo client to the local host. Following that, I'll be connecting to the database. In my case, the database is InventoryDB, and I'll be using this one, products best selling. So this is the collection I'll be using for demonstration. The first step, it's going to get the total number of documents. So like we do in the command line, here also we are going to do the same. So db.productsbestselling.find and then a count. So that is going to give you the total documents here. So let me do the same over here. On running this, we must see the count. So that's 15 here. That's in the command prompt of NoSQL Booster. And the second thing is we are going to filter the query based on this particular condition where name is Amazon Fire 7. So what I have did is db.productsbestselling. So this is a collection name, and then I have called the find method, and I'm passing the filter query as a parameter here. So let's do the same in the MongoBooster. I mean the NoSQL Booster. So no records are there currently. So let me give a query for Amazon Fire TV here. So Fire TV. So we got it. I'll be doing the same here. Then we have a filter to list out the products with price greater than 100. So let me copy the same query over here to NoSQL Booster, and on running I must be able to see the records here.
So the same query is copied to the Python code also. That's the beauty of this. And then we have update query over here. Instead of Fire7, I'm going to change this FireTV. So to cross check it, I'm just going to copy the same code over here and execute in NoSQL Booster. On running this, yes, it has been updated. Following this, we have insert and then finally delete. So this is the main thing you need to remember in Python using MongoDB, is that you can simply copy the queries from your command line directly to the Python code. The only thing to note is that you may need to use the single quote or double quote for the key value. So that's the only thing. This code is available in the resources section. Please use that. So it's very, very simple to work with Python and MongoDB. You can simply copy the queries from your MongoDB command line directly to the Python code. Following this, we have bulk operation. Bulk operation is very simple. I have just imported insert1 from PyMongo library. Then I have called the bulk write method over here. Following that, individually I have called the insert1. So this will be inserting records into the MongoDB as a bulk operation. That's the thing. It's very easy. To know more about bulk operation, you can just search for MongoDB bulk operation. So this is the method, that is bulk write, which is used in MongoDB command line. In Python also we do similar operation. As you can see here in this example, it's given very clearly. We have insert one, update many, replace one, delete one, and delete many. These all operations will be done in a single step. So that's called bulk write. So the same thing I have did here. I just called insert one, and then I'm just inserting the documents over here. So the next one is GridFS demo. It's very, very, very simple. As you know that GridFS is used when you are going to store and retrieve documents or files which are greater than 16 MB allowed size. So if your file size is going to be greater than 16 MB, you have to use GridFS. We are going to see how to use GridFS in Python. It's very simple and straightforward. I have just imported GridFS. Following this, I have called GridFS over here. So for saving the file to MongoDB, I am using fs.put method. I have put two different files. One is a PDF and another one is an image file. And similarly, to retrieve them, I have used find one method. And then I have read the file content over here. So let me run this one. Yes. So two are saved, and similarly this one is retrieved. Let me cross check the same. On refreshing, we must see GridFS. Yes, we got it. View. Yeah, so the files are saved here. On clicking this, I must be able to see the file content. So this is a file which is saved in the MongoDB server. We did that through our Python code. And this is the image file. Yes, the files are saved over here. And I have retrieved the files. Path out is here. So this is the file output created. It's the same. It's very simple and straightforward. You just need to import GridFS in the top. So after this, call the GridFS and then call the put method to save the file and read method to read the file. That's it. So it's very simple and straightforward. So this is how Python works with MongoDB. It's plain simple and straightforward. For more information, visit the documentation page of PyMongo, where there is a separate example section which gives you a good idea about how to work with Python and MongoDB. MongoDB in less than 50 minutes. So the target of this video section is to give you a good know-how of MongoDB in less than 50 minutes. So after this video, using the accompanying documents, you will be able to work out the key sections of MongoDB in ease. We'll be covering most of the commonly used key topics of MongoDB. In this video section, we are going to cover these topics. The first one is the basics, where we'll be learning about the basics of MongoDB. The second one will be seeing about CRUD operations on MongoDB using MongoBooster client. We'll be seeing quite some queries in this example. Following this, we'll be learning about capped collection and TTL. These are very easy and important. Then we'll be learning about regex, full text search, and finally GridFS and aggregation. These are very easy and important. So our time starts now. So this is the PDF which is available in the resources section of this lecture. This has 11 steps. Each step has its own queries and examples. The step 1 is to learn why MongoDB is different and a simple overview about MongoDB. MongoDB is a NoSQL database. As you know, it's a leader. NoSQL primarily offers two features, that is the schemaless feature and the second one is horizontal scalability. So these are the two things you need to remember about a NoSQL database. So MongoDB is like a Word document which is completely structureless and you can put anything into anything. Whereas the traditional databases like Oracle, MySQL or like Excel sheet, where the data will be arranged in tabular format. So this is the primary difference between MongoDB and the traditional database. There are three key things you need to remember about MongoDB. That is, it stores data in document format. The data will be in JSON format. And finally, you need to learn about the methods available in MongoDB. That is very, very important. So this diagram shows the important components of MongoDB. We have a MongoDB server. Under that, you can have many databases. Under databases, we have collections. Collection is a group of documents. So this is simple. Server has databases. Database has collections. And collections will have documents. I have connected to my local instance of MongoDB using a RoboMongo client, and you can see how the data is organized in a collection. The document will be of JSON type and it will be saved in binary format, that is called BSON. To know about JSON, please open the document which is in the resources section. Click on the sample JSON structure. This is a Wikipedia link. On clicking this, it shows a simple personal details JSON. As you can see, we have key value pairs, both are string. Then we have collection of key value pairs. So this is called object. Then we have age as a number. And then we have an array. Back to the document. To have a very quick reference about JSON, click on this link. This gives you a clear idea about a JSON data type. For instance, we have array here, we have Boolean. It supports null value, we have number values, and this is called an object in JSON. Then we have the regular string key value pairs. So this example can give you a good understanding about JSON data types. I'm in the reference documentation page of MongoDB. As you can see, the operations in MongoDB are done using methods. For instance, this find method is for finding the documents. Find and modify is for finding and modify the documents. So these methods you need to remember. Traditional databases uses SQL, whereas MongoDB uses these methods. So this is the primary thing. So always remember that MongoDB has methods. We have seen the step 1. The step 2 is to install MongoDB and its client MongoBooster. MongoBooster is one of the best client of MongoDB, primarily because it has two key features, that is IntelliSense, and it has code snippets support. So you can see the code snippets as well as you will be getting IntelliSense for any kind of method. So to download MongoDB, just Google for MongoDB downloads. It takes you to the MongoDB download center. Click on this. I'll be using the Windows version. Click on the MSI file. It's a straightforward installation. Once MongoDB installation is done, you need to run the MongoD.exe. This is the server process under this path, that is C program files MongoDB server 3.2 or 3.4 bin, and then you just need to run this MongoD.exe process. You can run this by double clicking, or you can run through command line. Prior to this, there is a very key step that needs to be done. That is, you need to give a data directory to MongoDB. MongoDB generally expects the data DB in this path, that is C data DB. So create this folder and then start the server process. You can double click it, or you can run through the command line. So it's cd, paste here, then MongoD.exe. So that's it. Once you are able to see this particular line waiting for connections on port 27017, this is the default port for MongoDB. It means that your server is started successfully. The next step is to install MongoBooster. That's very easy. Search for MongoBooster downloads. Click on the link. You'll be getting a fully functional version for 60 days. The installation is very straightforward. Download and install. Once installed, you just need to run the MongoBooster process just by clicking here. The connection is very easy. You just need to create a connection. The default values will be auto-populated. Press test connection. It will be successful. Once that is successful, just save and connect. Now I have successfully connected to the MongoDB server. As you can see here, I have many databases pre-created on MongoDB and they are getting listed. Under databases, I'll be having collections. So click on that, you'll be shown the collections. So these are the collections. For instance, in this collection, I have around 24 documents. So this gives me the documents. The data is presented in tabular format, but the true format is on JSON format. So this is the format in which the data will be presented to you, but MongoBooster is giving you options to view the data either in tree format or in tabular format or in the true JSON format. Now we are in step 3. Step 3 is to create database, create collection. Just remember the architecture: server has databases and database has collections. Let me create the database first. Right click, create database. The database name is demo. So database is successfully created without collections. Now to create collection, right click, create collection. So let me give the name here. I think it is user profile. Yes. So user profile. Okay. Collection is successfully created but without documents. Open shell. Let me create collection through command line now. Pasted the code. Let me make it as a user profile. Yes. On executing this, you can see the collection is created through command line also. Refresh. So we got two collections: user profile, which is created through wizard. The second one is user profile X. I'm going to drop this one. Drop collection. On running this, the collection got dropped. You can see true printed here. The next step is to insert documents into this collection. For this, we'll be moving to step 4. There are two key things to note are document with different structures in same collection. Every document will have a default underscore ID. So let's see the first one. For instance, here we'll be having two user profiles, one with ID, name, age, income, sex, nationality, language, additional info, etc. The second user profile will be different, where we'll be having user ID, logged in, last login, location type, etc. So different structures. This is a sample data which we are going to insert. This is the first one and this is the second one. So 2 different types of documents are going to be there in the collection. So that's important. Step 5 is to do a basic CRUD operation in MongoDB, insertion and multiple insert in single query. Sample data. So we are going to insert the first sample data. Let me select from the JS file which I have. Now I have to paste this on the window. Right click here, view. So it's an empty collection as we know that. I'm going to paste here. Pasted. As you can see here, we are going to insert in user profile. The query is very clear. If you keep the cursor over there, you'll be able to see the method, syntax, everything. Now let me show you the code snippet, user profile dot insert. As you can see here, you can see the code snippet as well as the method definition. The code snippet is easy, you can easily understand from it, and the method definition is below that. So that's the coolest feature of MongoBooster. Now I'm going to run this one on running. We must see 2 documents created. Yes, 2 got created. Right click, view. So these are the 2 documents created in JSON view. Now back to table view. Now I'm going to insert the sample data too. So let me copy from the JS file. Copied. I've pasted it. And I'm going to execute this one. I'm running this. New documents are created. So totally we have 5 documents. Right click, view documents. So we have 5 documents. As you can see here, the documents have completely different structure. That's the beauty of MongoDB. We can have different structure documents in the same collection. So this is what is the first point we mentioned, documents with different structures in the same collection. The second one is every document will have a default field ID. So this field underscore ID is created by default. It is auto-generated. It is unique. There is a bug with MongoBooster that this ID column, which I haven't mentioned, is shown there. But if you check with RoboMongo software, there is no ID column. So it's a bug with MongoBooster. So ignore that. So just focus on this one. This ID column, underscore ID column, is auto-generated. So it's auto-generated, unique, it is indexed, and can be replaced. So now to the step 5b, that is CRUD operation in MongoDB, finding documents. I have the code here. Let me copy paste to MongoBooster. Right click, view documents. I'm going to paste it in a new window. So pasted. The first one is a find method. So under collection methods documentation, you'll be able to see the find method. db.collection.find, and we have the query and the projection as a parameter to the find method. So let's do that. Field value. So I'm just giving a empty find. So it is going to list all the elements. So we got it. The next one is nationality. We are going to select as Australia. Let me execute this one. So we must see the record only with Australia. Yes, the single record with nationality as Australia is listed here. The next one, we are going to use the age field. For instance, here age is greater than 30. To know about these operators, please visit query and projection operator section in the documentation.
click query selectors, you'll be able to see the operators equal to, greater than, equal to, less than, equal to, not equal to, and all. So we are going to use greater than operator here, and the next one will be using less than operator. Let me run this one. So we got age greater than 30 listed here. The next one is to find documents with age less than 30. So we got a single document with age less than 30. Here it is 26. The next one is the AND operator. We have two conditions. The primary key to note is the square brace. So we'll be having multiple conditions within the square brace. The condition number 1 is the age has to be less than 35, and the condition number 2 is age has to be greater than 20. To know more about AND and OR operator, visit the query and projection operator sections in the documentation. Under this we have logical operator. Yes, we have here. You can get the details of AND, OR and other logical operators here. Now back to our code. On running this, we must see documents with age between 20 to 35. Yes, we have two documents with age between 20 to 35. Next, it's the same for OR operator, which is going to give us a lot of documents because the conditions are same. It is similar to AND operator, but in the opposite way. On executing this, so these are the documents with OR condition satisfied here. The next in our list is count, limit the number of documents, which is going to skip the number of documents, and sort. We have 1 for ascending and -1 for descending. So we are going to see this. So first one is count. On running this, it's going to give the count of documents. Yes, we got 6. The next one, we are going to limit the number of documents to 2. So we must get only 2 documents. Yes, we got only 2. Following this, we have skip operator, which is going to skip the top 2. So we'll get 4. The other 2 documents are skipped. The next one is sort method. We are going to use the ID field, which is going to do a -1, that is descending order of this ID field. Let me execute this one. Run. Yes, we got the ID field in the descending order 4, 3, 2, 1. So if you want to see the definition of sort, you just keep the cursor over there. You'll be able to see the description of it. We have seen finding documents. The next is 5C, that is update and deleting documents. So we are going to use the update method. We are going to update the location US to location as the United States of America. To MongoBooster, right click, update documents. So we got the query here, update. You can see the update syntax here. Then we have a set operator. Then we have option fields, multi. Multi means it will update multiple documents. Currently it is false. These are all option fields. The next we have upsert. Upsert means it will find for the document. If it is not there, it is going to insert. It is also set to false. So this is optional. We can totally take it off. So let me take the query from the JS file. I have copied it. I'm going to paste here. Yes, done. On executing this, we must see a single document updated with location US to USA. Done. So one matched, one document got updated. Let me view the documents to see the changes. View. Yes, as you can see here, one document has got updated. That is because we have set multi as false. The default is multi false. It's not like our traditional databases. So if you give multi as true, the option as true, it is going to update multiple documents. So let me execute this. On running this, the documents got updated. Let us view the documents. Right click, view documents. As you can see here, the documents have updated. The next one in our list is to do a remove. Let me copy this code here to MongoBooster.
On executing this, the first two documents with user ID 01, 001, 002 will get deleted, so removed successfully. Right click, view documents, so the documents are gone. So this is how remove works. It's very simple. You just need to call the remove method. So we have finished updating and deleting documents. So we have finished the basics. We have finished the simple CRUD operation. The next is capped collection. Capped collection is very easy. The only main difference between capped collection and the other collections are we have a size limitation in capped collection. For instance, we'll be setting the maximum size as 10 here. So it can hold only 10 documents at a time. So all other documents will be ejected out. So let me copy this query, paste it here, done. Capped is true, size is limited, 50 KB. On executing this, we must see a new collection by name, log capped. Let me do a refresh. So we got the log capped collection without any records. Now I'm going to insert the test data into that. Now I'm going to insert the demo data into log capped collection. Let me copy from the JS file. Now I'm going to insert log data into this. As you can see here, we have log 1, log 2, log 3, log 12. So this is the demo data we are going to use, but the max is 10. So 2 of this will get ejected. I mean the log 1 and log 2 will get ejected. So we must have only the data from log 3 till log 12. Run, success. Let me do a refresh first. Yeah, we got only 10 records as you can see here. That's because we have capped the collection to 10. Let me view it. Yeah. So as I said, mentioned earlier, we have only 10 records, that's starting from 3. We are going to see about indexing. Indexing is one of the primary part of database management because it fastens your search query. In MongoDB, by default, it creates an index on every document on the ID field. So in this demo section, we are going to learn how search works before and after indexing. So for that, we'll be using explain method. So this is the field I have been mentioning. Default index is created in the ID field. Let me copy the query. As you can see, I'm searching for income with around 6 million. On executing this, we'll be able to see the result in JSON format where we'll be getting the total number of documents examined. That's here. Currently, we have 4 documents and all the 4 documents are examined to find a document with this income matching. So let us create an index on the income field and see how the search works out. So we are going to create an index on the income field. The syntax is very easy. That's create index method is called with the field. On running this, yes, the index has been successfully created. Number of indexes after is 2 and before is 1. And you can use view indexes to see the indexes in the collection. Get indexes. Now you can see here we have 2 indexes. So now let us see the execution statistics. On clicking run, we must see the documents examined must be less. So total docs examined is just 1. Previously it was 4. So that's the power of index. To drop index, it is very easy. You just need to call the drop index method on the particular field. That will drop the index. Now to the step 8, that is a TTL collection. TTL collection stands for time to live collection, where the data will be kept only for the specified seconds. Note that it is seconds, not milliseconds. So the documents will be automatically deleted after a particular specified second. So in our case, demo TTL is a collection name. To create a TTL index, it is very easy. You just need to create an index specifying that it will expire after particular second. So log data is a field, demo TTL is a collection name. So create collection is demo TTL. Now it's created successfully. Right click, indexes, add index. So add field. Field name is log underscore data. Okay. Expire after. Just see the field. We have expire after. I'm specifying. I'm going to preview it. On clicking preview, you'll be able to see the query here. So it has created a create index on this field, which is going to expire after seconds 10. So it is similar to our query. On running this, we must see expire seconds. I have to select completely. On running this, we must see the index is created successfully. So the number of indexes after is 2 and before is 1. Now right click, indexes, view indexes. So as you can see here, we have 2 indexes now. The expire after seconds is 10 for a particular index. The next step is to insert the test data. Now we don't have any data here. As you can see here, I'm going to just insert date on the log field. Let me copy this. So log data will have only date. I'm going to run this multiple times. 1, 2, 3, 4. So 4 times it got executed. You must see 4 documents here. View. So we got 4 documents inserted at different times. As you can see here, I'll keep on executing this. So after 10 seconds, the data must go off. Yes. Now there are no records in the collection. So this is how TTL index works. So just remember the syntax. Now to the next step, that is step 9, text search. Full text search. Full text search is very important in MongoDB because it is schemaless. It's very easy to do a full text search. You just need to create a text index on a field. As you can see in the documentation here. So this is a documentation page for text search. MongoDB supports query operations that perform text search on string content. MongoDB uses text index and the text operator. So this is important. So we have to create a text index and we have to use a text operator. So this is the syntax for the text operator, which will be performing the search. We'll be giving the search string first, then we'll be specifying the language, then we'll be specifying whether it's case sensitive or not, and finally we'll be specifying whether it is diacritic sensitive or not. So this is the syntax for text operator. Prior to that, do remember that we need to create the text index. So let me do the first step, that is to create a text index. Let me copy from the JS file, copied it. So demos text search is the collection name, copied it, pasted here. So we don't have an index. So let me create a collection for this. So demo text search. So the collection is created. Now I'm going to create an index on the message field. So indexes before and after is 2 and 1. Indexes, I'm going to view indexes. As you can see, we have 2 indexes. One is of type text. Now I'm going to insert text data value into full text search. So let me copy it from the JS file, paste it on MongoBooster, and then run it. So now we must see around 11 records here. Let me do a refresh. We have 11 records. 11 documents. If you see the document, it's very easy. It has messages, good coffee with cures fatty liver, good coffee, best Mongol. So it's a simple document. Search in full text. The first one is to search for message with good, easy. So it will be search both with good and easy. Let me paste it. On running this query, we must get messages with both good and easy. But currently we won't find because it's not a text search. It's a plain find query. So it won't find anything. So let us give it same thing with text search now. Pasted it. As you can see, I have used the text operator. Previously I haven't used it. And then I have given the search operator. On running this, we must see the documents with both good and easy. Let me expand this one. So easy. So we have documents matching easy and good. Now I'm going to ignore fatty. On executing this, we must get results without fatty. Yes. So the document with fatty text is not selected. So let me show it again. In our previous execution, we got the document with fatty liver is mentioned, but currently, since we are ignoring it, the particular document with fatty text is ignored. Next one, I'm going to search a complete text is also here. On executing this, we must get an exact document. So which has the exact text. Now the interesting one, that is, I'm going to search for goodness. It will be listing the documents with good also. That's the power of text search. Selected, run. So you can see documents with good text also. So that is the intelligence of full text search. Now to the next one, where we are going to search for easiness. So it will list the document with words easy also. Let me run this one. As you can see, MongoDB queries are easy. So this document got listed after we searched for easiness. Similarly, we can search for happy. We'll get documents with happy as well as happiness. As you can see in the result, we have document with happy as well as happiness. Now I'm going to search the word the easy. The word the will be ignored. Let me search it. As you can see, there are no the in the document and it is ignored. So the common words will be ignored. The next one is very interesting and important. Please note that every document search will have a text score. You can also manually rate a document, or by default it will be given a text score. Remember that every document has a text score. So now we are going to see what the text score for every document. I am going to search for coffee. So as you can see here, the search results have score mentioned over here. So every document is having a text score, and note that the text score is based on its own algorithm. For example, if you take the first document, we have coffee repeated many times, so its text score is higher for this particular keyword coffee. So it's easily understandable. This is how text search works. So 3 things to remember. For text search, you must create a text index. Number 2, you need to use text operator and search operator. And number 3 is every document will be given a text score by default. You can also edit the text score manually. Now let us move to the next topic. We are going to see about Regex. Regex is very important because we have different formats of data, and Regex eases our work. This is the documentation page for Regex, and we'll be using the Regex operator. The good thing about Regex is that it is Perl compatible. PCRE or Perl compatible Regex are very famous. The syntax to use Regex operator is shown below. As you can see here in the leftmost, we have a field name, then we have a Regex operator followed by pattern, and then we have options operator with different options. This is a sample data we are going to use for our demo session. It is very simple and it has only name field. Now let me copy the data to MongoBooster. Pasted. On executing, we must get around 13 records. Refresh. Yes, we have the persons collection with 13 documents. So we have Rick David, Elizabeth David, David is in uppercase, and David Warner, David, John David 1, Paula David, Davidson, David King, first David, fifth David, Siju David, and then the names Arun, Karun, Ahmed without David in them. Now let us start with the regex queries. So now let us start with the first one in regex queries. Let me copy this to the MongoBooster. On executing this, we must see names with both David and Arun in them. So we have Rick David, Davidson, David, all those. And then for Arun, we have Arun and Karun. Karun is included because Arun is there. Now to the next one. Regex search with all David in caps and with options as I. If you see the documentation, I is for case insensitivity. So we have case insensitive search here. So let me copy this one and execute here. And on executing, we must see David names with David in both small as well as in capital letters. So that's done. The next pattern is similar to that of the first one, which has the same function as that of the first query what we executed. And similarly, the next one is for ignoring the case. Let me execute this. The result will be similar to the first one. So we got the similar result to that of first one. And for case ignore search, so we have both cases listed here. Now this is a simple query where we are just going to search for David in caps. So let me execute this. On executing this, we must see only 2 documents with David in caps. Now this is interesting. We'll be searching for starting with. So here we are going to search for starts with 1. So we must get first David. Yes, we got the same result as we expected. Result is first David. The next one is we are going to search for the term son star. So we'll be getting Davidson here and case is ignored. As you can see here, we have Davidson, David King. This record will be listed in the result. Running this, yes, as we expected, we got Davidson, David King. So that's because of this pattern. To the next one, where the name is going to end with run, we'll be using the dollar symbol in that selection, and then on executing, we must see Arun and Karun. Yes, as we expected, we got 2 records with ending with run dollar. Next is we are going to search names with digits in them. Let me select this. On execution, we must see 3 documents. Yes, John David 1, where we have number, first David, and then fifth David. So this is how regex works. With this, we have seen about the basics of regex operations in MongoDB. You need to refer to the Perl regex manual and MongoDB regex manual. GridFS is very important, as you know that it allows us to save as documents with sizes more than 16 MB, which is the BSON limit. This is the GridFS documentation page. GridFS is a specification for storing and retrieving files that exceed the BSON document size limit of 16 MB. So this is the definition for GridFS. Instead of storing a file in a single document, GridFS divides into parts and chunks and stores each chunk as a separate document. GridFS uses two collections to store files. One collection stores in file chunks and others in file metadata. So this picture can give you a good idea about GridFS. As I said earlier, always remember that there is a 16 MB file limit for the BSON file. So using MongoDB, we'll be using MongoFiles command. We'll be creating a bucket which will have two collections for FS chunks which will save file chunks, and a FS files collection which saves the metadata about the file chunks created above. So this is very easy. Let us see a simple demo. We'll be using a simple demo using MongoBooster. We'll be using GridFS bucket and it will create two collections, FS chunks and FS files. So first step is to right click here, create GridFS bucket. On clicking this, demo underscore GridFS. So the name of the bucket is demo underscore GridFS bucket. And on clicking OK, we must see a new bucket here with the symbol of save icon. The next step is to add files to that. Right click, add files. So this is the image file I have selected. There are two options, with full path, without full path. I'll be selecting without full path. On clicking this, the file will get uploaded and the file got saved in the bucket. And on right clicking, on clicking view documents, we must see file chunks, around 6 we have. To view the image, double click here. It shows the image uploaded. Note that this is in MongoBooster, not in image viewer. Now we have seen a simple demo about GridFS. Now let us move to the next topic, that is aggregation. This is one of the important topic in MongoDB, but it is very easy to understand. In aggregation, we have three types of aggregation. Aggregation pipeline. This is a widely used, commonly used one. The next one is Mapreduce. Aggregation pipeline replaces Mapreduce. And then we have single purpose aggregation operations. Under single purpose aggregation operations, we have count, distinct and group methods. Count is for counting, distinct is for getting distinct records. Group is not suggested to use. So let us see more about aggregation pipeline. For aggregation pipeline, we have stages, expressions and accumulators. As you can understand from the name itself, stages process the data in stages. So match operator and group operator are used. Whereas for expressions, we have string arithmetic expressions, and for accumulators, we have sum, average. To easily understand about MongoDB aggregation, Google for MongoDB aggregation, click on the link aggregation under MongoDB manual, click aggregation pipeline. A very good diagram explaining aggregation is provided. As you can see here, we have different order details. So we have aggregate method and we have two stages here, that is a match stage and the group stage. We have different order details here, each one having a custom ID. A match operator is applied and customers with status A are matched here. All are having status A. The last one is having status G, that is ignored. Then a group operator is applied here. The group operator groups the records with similar customer ID and it shows the total of the orders in status A. This clearly explains how aggregate works. So let us start with the user profile count. We are going to do a count in the user profile collection. So we have 4 records here, view documents. Now we have 4. Count has to give us 4. We got 4. Now db.userprofile.distinct. I'm going to take off this slice, it's not required. Distinct on a particular field name. So let me do a find to see the field name. We're going to do a distinct in the age field. So here it's age. On running this, we must see the distinct age values. So this gives us a distinct age values. So we have 35, 26, 30. So those are distinct. Now to the third query where we are going to use the aggregate method. We are going to match based on the income greater than 4 million. Code from here. Let me copy the query from here. Paste it on MongoBooster. On running this, we must see records with income greater than 400,000. So we got 5 and 7. So both have greater than $4 million income. Now to the next one where we are going to use group operator. We are going to count the total users using the sum. On running this, so we must get 4. We got 4 because our greater than value is 40,000 only. So we got 4 total users. Now to the next one where we are going to do a sum based on the income. So income field is used. This will give the sum of persons whose income is greater than $4 million. So we got $13 million. Match first. As you can see, we have 5 million and 7 million. So the result is 13 million. The sum operator is used on the income field. So $income is a field. So that is a key point to note. We have used greater than. So we got 13 million. Now let me use less than here. On running this, the result is 680,000. Let me do a match on this to demonstrate. So we have two incomes, 290 plus 390. So it adds up to 680. Do always remember to see and understand the diagram in the documentation. It gives you a clear idea about how aggregation works. So we have covered all the basic topics. The basics is done, the simple CRUD operations is done, capital collection we have seen, TTL we have seen, Regex full